Yes, but oh, it was last night.
Uploaded, sorry? I uploaded it on my topic. Uploaded on the room, right?
Yeah. From the website.
What do you mean? And then I can upload it.
Yeah, yeah.
Actually, Yeah, of course I have. Are we going to talk about unlimited? Because no, because that would be a better use of my brain. No, well, it's exactly the same. Yeah, which would be even better. From people. Yeah, of course. Which let me just say. Because I think I checked for you. Me. Does it work? Yeah. I mean, it's not a dark.
You have to do. Yeah, exactly. Want to? Better to panic with your
Better not to turn on your computer.
Yeah. Want a warning?
All of it. That would be very. I mean, I'm just going to have like a very short talk, and then it's more discussion.
That's great. That's perfect. That's what we are supposed
That's
to
what
do.
it's supposed to be.
Like,
No ideas anyway. So.
testing. Okay, this one. Hello? Yeah. So meanwhile, maybe a couple more people join. So thank you to our sponsors, LPC sponsors. We wouldn't be here, and the micro conferences wouldn't be possible without the sponsors. So thanks a lot for the sponsors. We are going to have a few talks. I think it was a few before the break, and we will do the standard break, so you have a chance to get some things in the middle of the session or the MC. And we are going to start with Alexander. Let me switch here your slides. So yeah, the Rust MC and the MCs in general in LPC are supposed to be discussion-based, right? We sometimes do presentations, we sometimes do some we have to introduce, give context, so that's fine. But please, if you are part of the audience, please ask questions, because that's what the presenters are supposed to do: answer your questions and have discussion and lively discussion. Okay. And Stephen Rosdet always says for the MCs, which he organizes or he leads. If you go through your slides in a micro conference and you manage to end your slides, normally you have done a bad job. Okay, so we are supposed to have a discussion, and so please feel free, unless they say otherwise. Please feel free to interrupt the speakers. And yes, we are going to start with overflowing with fear. This year we have mostly kernel topics, but the Rust MC is also open to non-kernel topics as well, related to Rust. This one is related to the kernel, so please, Alexander, whenever you're ready. So Alexander works for NVIDIA. He has been doing a stellar job on reviewing and helping not just NVIDIA things, but also the community patches and things that we need for Rust in the kernel in general. So thank you, Alexander.
Oh, hello everyone. Thanks for coming. So this is just like a couple of slides to initiate the discussion, but I really want this to be a community discussion, because I personally have no idea how to properly address that. But as we all know, Rust is the language of safety that never ever crashes the kernel, except when you. Oops. I can't. Oh, okay. Yeah, that's okay. Except when we try to add two numbers. Basically, the code on the top, whenever you see the code on the top, what you should consider is that you're seeing the code in the bottom. Because A plus B right now in the kernel will panic the kernel if the operation overflows. So that's one instance of implicit panic, and we accept such code, I think on a pretty regular basis. Oh, and I'm going to be
by default, right? With the I'm trying to give an example.
Yeah.
Lively discussion. Okay. That's by default when we have the kconfig option.
Yes.
Right, yeah.
Yeah. Another instance is if you try to index us.
Sorry.
Yeah.
It's no sound in the room. So somebody else can confirm that they cannot hear me. That's not possible, but Gary, you are there, I think. Can you? Okay, so Gary, it works for Gary, so I guess it's Benjamin
Is it
on
okay?
Benjamin's side. Okay, so we will continue. If somebody else has a problem, please let me know. I will contact the organizer.
Okay, so that's one such instance. Another one is if you try to index a slice, or you have an out of bounds check. So this one is more expected, but this is also something we need to consider. So my biggest problem with that is that these panics are inserted by the compiler without any sort of warning. And if I work on driver code, I have no proof that a given function that I've just written does not contain some landmine, unless I analyze the lower level code representation. And this is also not something we can just transparently remove, right? Like Sergey, you mentioned you can just change these panics. You can just ignore these panics. But if you do that, what you are going to have is undefined behavior and possibly security issues. So they should not, but you right. But you might not be.
I don't have anything to say. I don't have anything.
But
Yeah, please.
Yeah, but if you don't panic, your DMA access might not be done at the address you expect it to be, which can be a big problem.
To be specific, overflow, is it unsigned or signed that is undefined? Because unsigned should be defined, I think.
Yeah.
It's not in Rust.
Everything's defined.
So if you have a U32 that you overflow,
Yeah,
that's
but
defined in Rust?
it's not undefined behavior. It's unexpected behavior, which is still bad, because say if you're doing a DMA, if you are like computing the start address of a DMA operation, you're not doing the DMA where you think you are.
Like in RCU, for example, we have use cases where overflowing an unsigned integer is part of the algorithm.
Oh yeah.
So,
well, if it is, you have a specific operation for that. It's called overflowing add, I think, right? It's just you have to be explicit that this is what you want.
Yeah. So in Rust, we have essentially you have a range of ways you can do the arithmetic. You have saturation, trapping, wrapping, undefined, so unchecked, and also conditionally checked, which is what the operators do. By default in the kernel, we do check and we panic, but we can also do the other one, which is wrapping by default with the operator. So there is a bunch of ones, and you can pick, right? And you have also the fallible one, that is check that Alexander has. So you pick what you need, and that's what we really like about Rust. You pick what you need. In C, instead, as you know, in C, well, you get what you get. And now the C committee, for example, the other day, like 3 days ago, 4 days ago, they were discussing in the list adding, for example, type modifiers or maybe attributes to have something similar to Rust, to have something that where you specify, okay, for this type, it will be saturation, for this type, will be wrapping or whatever, right? So I think that's a very good idea that Rust provides those operations per call, right?
Like, for instance, it's quite common to encode error code, negative error code into unsigned long pointer value.
Yeah.
Do you panic the kernel when you do that in Rust?
No, because in Rust you encode error codes into a result type.
Oh.
So it's a different type, and so this addresses this kind of problem.
Turn it to C function, which expects to just unsign long and then checks if it's an error pointer.
Yeah, so then that's what the foreign interface is for, and it's supposed to take care of that. So this is, I think, a different problem.
I just want to add one thing about Joe's thing Joe mentioned. So that field in the RCU is, I think that it will if we implement it in Rust, that will be atomic, and atomic has kind of different rule compared to normal integers. Atomic will always wrapping, I think. Yeah. But that is there should be atomic because there will be like concurrent access to that field.
Another way or a generalization of what you're saying, in Rust, even if you do that with the normal integers that we have, right, the standard integers, if you will, the primitives, in the kernel and also in other projects, what we really want actually is not really to use, in many cases, the primitives. What we want to is to define new types, right, which are like, you can consider them like strong type defs, like a struct with Rust in C, where you have your wrapping an integer, and then you only define the operations that make sense for that type. So you don't even have the chance to call the wrong operation, right? So that's something we are doing, and we have a few issues, in fact, open right now for newcomers to take this primitive that is used, a U64, for example, or a usize, and convert it into a new type, give it operations that the current users are using, and then we limit that to those operations, right? And then the mistakes are you have less mistakes because you cannot just mix randomly different integers that you are not supposed to, for example, add together, right? Apples and oranges.
Yeah. So as you said, like a bit before, as long as your intent is well specified, as long as you say, I want something that is overflowing, that is wrapping, or I want something that is saturating, it's great, and that's what Rust provides. The problem is when you do A plus B, what is your intent exactly, and how can you be sure this is doing what you want? So it's something that has an easy fix, right? It's a bit cumbersome. Every potentially panicking operation has a fallible alternative. You can use checked add, you can use get instead of an index operation, and you will get like an option. It's just it makes the code heavier and more tedious to read, and most of the time you expect that the compiler is going to be able to optimize these out anyway, because your index is within like the correct bound, and the compiler can prove it. But you still have the doubt. Is it actually optimized the way? Do I still have this landmine in my code? And I think it would be very valuable if we could get feedback from the compiler using say some opt-in clippy option. There is a panic in your function here. Yeah.
So, Gary, to speak, and I forgot to mention this in the beginning, for remote attendees, please enable your cam when you speak. So, Gary, can you please enable your camera? Okay, but there's raised hand. Okay, thank you, Gary.
Yeah, okay.
Go ahead, Gary.
So, okay. We can't hear you, Gary.
So now you're muted. Now you're. Yeah, we can hear you.
Yeah. So I think this has a lot of similarity with the build error related stuff, because you want some compile time check. Right. So in general, this is not something that Clippy can do because it runs way too early in the pipeline. It can analyze the MIR. These of the checks are not handled currently at the Rust compile level. It's done by LVM to optimize these out. So basically, you need optimize LVM IR to do any of the analysis that you're mentioning. So not some capability that Clippy can do, although it is something that K-Link is trying to do. So earlier this year, for Congress host, I've had the build error, which is now K-Link can analyze where there is a build error that's not being optimized out and point you to that. So I think adding to that, it's possible to do some analysis post code generation to point you where are the unoptimized panic messages.
Yeah, I guess one challenge with that is, so there's two things. I was wondering, like, can we use the linker to, like, if there's a panic, I'm guessing right now it's linked to something in the kernel, so there's no link. If there's a panic called like a Rust panic.
But, just like build error, you can. So what I discussed with Clippy is, but not on the optimization side, right? Just when we have certain operations, we ask Clippy, hey, we want to give you a list of, so we give the linter a list of methods that we would like to require the developer to write a message on top, a comment on top, where you are supposed to explain the reason why you are. Oh, thank you, Odin. So I'm in touch with Clippy because we want to have, we want to pass the linter a list of methods, which is customizable, right? And for those methods, when the developer writes a call to that method, then we will require on top of it / panic, for example, or / ordering for the atomics, or / whatever we want. So we have the same that we do for the safety comments, right? When you call an unsafe function, right, you're supposed to give a message, you're supposed a reason, right, for why that is safe. The same way we can do for panics. So you are supposed to write why the kernel is not going to panic there. Or if you use an atomic operation that has an ordering or two orderings, then you're supposed to explain why that ordering is the correct one, for example, right? If you are using a fence or whatever, etc. So the Clippy team is I think they like the idea, and we have somebody, Alejandra, in the Clip team that is willing to work on this and help us get this done. So that's one solution that we could do. Of course, that's before optimizations. It's like literally, if you call this method, you have to give a reason, even if there is no, maybe the compiler can see that there is no potential for the right.
Kind of sounds like what C++ does. Let's say it's a function with throws, and then you tell what exceptions it can throw.
Not really, because this is giving a comment. It's giving a reason, right? So in C++, normally you don't give reasons on calls for why you are calling that or why it's okay to call that, right? I mean, projects can do it, of course, but I mean, it's not. I have not seen many projects doing that. In this case, it's essentially forcing the developer, and the linter will complain if you don't do. It will force you to write why that is correct. And we have seen these benefits. So, for example, in Rust, that's not required. It's a lint, and many projects don't use it for the unsafe calls. But we have seen the kernel, we enforce it in almost the beginning. We wanted to have that, and we enforce it now in the kernel, so everybody has to follow that. And we have seen that the safety comments are really good, because it's redundant information sometimes, if you will, but it allows you to double-check that the reviewer, for example, or an AI reviewing the code can actually see that what you are doing is correct, right? So because it works well for safety comments, we are willing, or we want to try for other kinds of things, like, for example, the ordering, the panics, and other things, that anything that we may think about that is good for the developer to explain a reason for what they are doing something, that I think we should do. And we call this tag comments, if you will, or a general mechanism for doing that.
We actually had a case the other day where somebody came along on the list and was like, hey, I found this comment. It seems wrong. I don't know anything about Rust, but it seems wrong. And they actually found a problem.
Exactly.
By reading this comment.
Exactly. It's like an error correcting code is what I say. These comments. Also the preconditions. In the kernel, normally in C, you don't write normally preconditions. In many cases, some subsystems have comments like that. But in general, we don't write many documentation, right? What we have found with Rust is that because we are forced to write safety preconditions, only the safety ones, but at least those. What we have found is that it's, again, a kind of a correcting thing. It's redundant information, because you could figure it out if you read the function, but then you don't know if there is a bug in the function. You have to assume the function is correct to understand it, or maybe you find an error, but then it's complex to understand, oh, then somebody did a mistake writing, implementing this function, right? While if you have the precondition, then you know. If they don't match, the implementation doesn't match what the documentation is saying, then you know it's a bug. Right. While the other way, you know. So it's like an error correcting code in that sense.
Just wanted to add on that. Probably we are also looking at implementing some pattern type which can restrict the range of integer values, and I think that probably will come with library methods or functions that you can specify a stronger guarantees on that. When you do let's say, index accesses with those values of pattern types, you will never get overflowing.
But that only works if it's a constant length of the array.
But it does work for additions of, if you have integers and you add them, then you don't get an overflow, for example.
When congenerics are good enough, we could have also types that return a different, right? And we could do some more things. There is a question in the chat. Daniel, do you want to put the camera and speak up, or do you want me to read it? Oh, okay. So yeah, please maybe mention it in voice. I can reply to that.
Yeah, the question is, why do you need a new Clippy lint instead of maybe augmenting the existing disallowed methods in like that family of lints? And then you could just use the built-in like expect method that already gives you the rationale. Don't get me wrong, like the / panic thing.
So I have quite a few reasons. I have like an issue in Clippy with explaining all the rationale, but the major reason is the lint reason feature is the lint underscore reasons. I think is the name of the feature that you are talking about, where essentially we would use an expect or an allow on top of the call. For example, you are calling a method that requires this, you put an allow, and then inside the attribute you put comma reason equal quotes and just plain the reason there. But the thing is, that syntax is very, very heavyweight. I mean, it's very heavyweight. The reason is on the right side, and you also have to give a lint name that is not really relevant. Like it's an implementation detail, right? So what we really want is to write like the safety comments, which is super easy to read. Also, when you are working on your IDE, it's super easy to see the comment because it's in green, and so on and so forth. So there are several reasons, and I have more. Also, another one is that when you use an allow, right, or an expect, what you are saying normally is this lint fires here, and it's a false positive. In most cases, right? It's like I need to overwrite this lint, while the safety comments or the panic comments or the ordering comments are not as a false positive. I want that the lint fires, and I want you to write it. It's not if you write an allow there, it's because you are saying the linter has a bug where it's requiring me a comment that this will not be there, right? So there is a difference there, and that's why I prefer that we do and that is what I argue to the Clippy lint that is different, and we should do that and not the lint reasons approach.
Seems reasonable. Also, while I have the thing. On the topic of just like how to check for panics, I maintain a library, the GDB stub library, and that's a library that I really don't want to panic because it would really stink if your stub is panicking. So I have like some CI passes in my code where essentially, yeah, after the LLVM optimizer is run, I'll actually dump the assembly from sort of my library and sort of the stub that it links to, and I'll literally just grep for like calls to panicking code. And that's how I sort of write no panic code, but it is certainly not super fun, and you are at the behest of the particular LLVM backend and architecture that you're running on.
But that's actually an acceptable solution, right? Because in many cases, you expect the compiler to optimize this away. You just want confirmation,
right?
But you do not have this panic side for various reasons. Right? One of the reasons that if you cannot prove to the compiler that this is not going to happen, how can we be so sure yourself? And the second is, well, these little panic sites add up in terms of code footprint. Maybe not much, but still they add up. You don't want to have this in your code. But I think the biggest problem is one of information. How do we know that our function is, after all the compiler passes, actually free of these panics? I think Gary raised his hand.
Go ahead, Gary. We have
another one.
Hello. Yeah. So I guess one of my questions is before we get to ask how or like in what mechanism can we avoid these panics. I'm just currently thinking about the rationale for even like requiring this, because having no panics in Rust for these check operations is essentially you are saying if you're thinking about C equivalent, you are going to prove that the whole program is UB free. Right, that's what you are trying to achieve when you're trying to assert that none of your code has panics, which I think is a lot of burden in writing the kernel Rust program. You shouldn't be required to prove your C code is UB free before you submit it in tree. So adding a panic comment for every possible size of panicking implicitly, where if they happen in C as UB, I think it's a lot of burden for the programmers. I think it's good to have the tool to do this.
So just to clarify, the panicking thing, we are not required. So what we do is we pass a list of methods that we consider should be really have a comment on top of them, right? It's not every single panic in at least that's the way I see it. Okay, personally, the way I see it, I agree with Gary that we probably cannot require every single panic to be annotated. Maybe we could. I mean, maybe we're wrong and we can do that. But in principle, and for another thing that Alexander said is that the operator essentially is introducing a panic. To me, that's fine. I mean, personally, to me, that's fine. I mean, I am not that scared of panic in the kernel as long as it's not in any path that the user can, the user space request can get into, right? Yeah. So it depends on the context. If you're in a context where you're in a syscall, well, you better be sure you are not panicking the kernel and so on. But if you are deep in somewhere that there is some logic, and that logic is obvious that it cannot happen, and it's a real bug that if it happens, then I think panicking is more, or is, how to say, is appropriate, yes, right? And also it depends on, what we don't want. So, for example, Linux, as far as I understand, and don't quote me on this, but as far as I understand, what Linux thinks on the C side is, well, there's two cases. Either there is no problem, the condition cannot happen, and therefore it's okay to just assume it, or you don't know, and therefore you have to have a check, right?
Check, yes.
Now the thing is, he doesn't want to have checks for things that cannot happen. It means he doesn't, in the Rust case, he doesn't want to have, for example, that's my interpretation, okay? And I agree with that interpretation. Maybe I'm misreading Linux, but at least personally, I don't want to see functions that are infallible, or they should be infallible, just adding results everywhere, just because there is a panic somewhere. So if it cannot happen, it cannot happen. And if you cannot prove it, then yes, use a result. But if it cannot happen, then we should try not to introduce error paths that nobody is going to ever test, right?
Yeah, there's similar cases in Binder where, in Binder, we have a fair number of cases where this operation will panic if something is wrong, and if it's wrong, there's a bug in the driver, and if somebody triggers it in the field, which I have seen that happen, and I've gotten bug reports assigned to me from the Google system that collects panics from devices in the field. So yeah, and if that happens, it's a bug in the driver, and I will go fix it, and that's it, right? I don't think making Binder 100% panic free is one of my goals. That even CBinder has calls to bug on if there's a bug in some cases. I don't think.
But these at least are explicit.
Yeah, of course.
This is the intent is properly expressed.
With the operator, it's also the operators in Rust that we use, it means you are sure there is no overflow, period. It's not that, if you use an operator like plus, it means there is no overflow. You are asserting there is no overflow. It's true that it's a bit implicit, and I agree that maybe we should just move to use everywhere a call for that. But I mean, it's what it is. When you're reading Rust code in the kernel right now, at least, if you see a plus, it means you have a bug on there. And you should really be careful if you are in a context where you're not 100% sure that can happen, right?
Yeah, I have cases in Binder where I use plus and minus and error indexing, and when I wrote that, I meant please file a bug report against me if this overflows or if this is out of bounds, right? That's what I meant when I wrote that. And I also have some cases in the user space access code where I have some additions, and then I have my comment where I explain, oh, this is not going to overflow because so and so reason. And if I got that wrong, I want to know about it.
Now, there is also, I want to be fair to, there is two use cases, right, or two sets of users. There is the set of users that are desktop, the original kernel people using the kernel. For that people, when you have a driver that you are not sure if it works or not, if you panic the kernel, it's very bad, because then you don't get the bug report, because it's not Google and they don't have this infrastructure where they collect the bugs and so on, right? So you will not see the bug report, and that's very bad, and the user will lose data and so on and so forth. So it's very bad, and that's why I think Linux doesn't want to see panics and so on in the kernel. But then there are other set of users like Google or whatever that if there is anything wrong, they want to stop everything because somebody may be trying to get into the server or whatever, right? So for the first set of users, they can build the kernel without the overflow checks, for the overflow checks. Okay, for the overflow checks, you can disable the overflow checks in the kernel. It's just that by default, we have them enabled. Okay, by default, we force the developers to take into account that the overflow check is there.
Yeah, and I don't want to go too much over time. I think we are.
Oh yeah.
I just want to add a couple of things. First of all, the null checks in the kernel are, if you walk through a call chain, you'll find that if you're passing a pointer, not every function checks for null, and that's on purpose. Because you know the call chains, and again, you're asserting that it's not null. And if it is null, you get a nice clean kernel crash that you can debug, except in some situations. And that's part of the history of how it's supposed to be done. The other thing is I'm a little concerned that about the direction of going, well, let's add some more / rules, because we already have executable comments. We've already gone more than far enough in that direction. And I think adding more, okay, you have to write this comment in order for this code to exist. Let's be very, very discerning about adding more of those. I think right now the balance works. We have some / panics, we have some / safety. That's fine. But if we have to do / plus, I think we've gone.
No, / panic we don't have yet, but we want to have.
I saw 1 or 2 of them in the code.
No, but it's not checked by the linter. I mean, we will.
It's not checked.
Yeah, I mean by the tool.
I saw the
not,
convention.
yeah.
I didn't realize it wasn't checked. And like you said, just to emphasize, the plus already has a built-in bug on in it, and that kind of follows the kernel convention, which is.
So there is different people have different opinions, and I am hearing from all sides different opinions. I'm trying to find the right balance. I think, as usual, what happens with these things, and what we saw with the safety comments, is that in the beginning, people react a bit like, oh, no, I don't want to do that work. It's a bit too much, right? Then when people get used to it, then they are like, oh, I really like it, and I want everybody else to do it because when I read code, I want to see it, right? It happened with the doc test. It happened with documentation. It happened with the safety comments. It happened with the Rust format. It happened with the how to write the style of documentation. It happened with many things, and I had to push a bit. It's my role kind of to push a bit these things. Of course, there is a point where we may find, okay, this is enough, right? This is enough, we are done. But we have to find that place, and I'm trying to see with the community where we can go, right? I think it's good to push sometimes the boundaries a bit and see if it works. Maybe in certain parts of the kernel, we could do it maybe for certain parts, see if it works, and then expand it later to other parts of the kernel, right? But I want to keep pushing a bit some of these boundaries, because without having to stop everything on this track, right? And without, when you're out of tree, you can do whatever you want. So we could have, you can run without Clippy, you can run with other things. We could have a development mode or something like that is more lenient. But if you submit upstream, then you have to do it. Okay, if you need to put it upstream in the end, then you have to follow the stricter rules. Right?
Yes, and I had some questions. So the overflow checks, they apply for underflow as well, right? Because okay. Why don't we enable it by default? Because I recently reviewed.
It is enabled by default.
Enabled by default. Okay.
I was just pointing out that for certain set of users, like for example, if you're really worried, that distribution is really worried that they are going to crash their users, and they prefer to have wrapping, like you can disable the overflow check. So it's a kconfig option. You can disable it. But by default, and I asked Case because I didn't know exactly what to do. Should we do it by default or not? And I asked Case. Should we just go for it? Because it's new code. If it's new code, it's very easy to just enforce it in the beginning, right? While in C code, it's way harder, and Case Cook is trying to go through all the C code and trying to enforce these things and trying to get rid of overflows, and there is whole discussion of that. In Rust, I talked to Case, and he was like, no, yeah, please do the overflow checks by default, and we did. I have his backing on that, and he's a security guy, kind of, right? So yes, we are doing the overflow checks by default, and it's working. So far, nobody has really complained about, I have the overflow checks, and it's a really pain,
And on the topic of using plus directly, if you're absolutely sure that things cannot overflow, then I think dead code elimination should remove the panics completely.
Yeah, the optimizer can, of course, remove those branches. Yes.
So in that case, like using plus shouldn't be a problem, I think.
Yeah,
of course. Yeah, of course.
And that's actually a path that would be good to take if we can take it. But on the topic of panic comments and the like, this is also something where the type system can be probably leveraged more for that. Like we discussed with Alice about a bounded integer type for indexes that just removes the possibility to even express this undefined behavior, and that's the ideal case because you don't need a panic comment, you don't need anything. And we're very over time, Miguel.
Yeah, we are. Yeah. Sorry, I got them so engaged that I please keep track of me as well. Okay, right, thank you, Alexander.
Thank you everyone. Great discussion.
I moved you. Is you? Yeah. I think it's you, right?
Yeah, we can take out that.
How do I?
Yeah, let me.
one of these yours?
It's called LPC 2025. I don't see.
Let's see. Okay, may I have please? Can you?
I have another session to go to at 10:45.
Thanks a lot
I was fortunate.
Yeah.
Thanks for being here.
I'm sorry.
Oh, Miguel, that's it.
We have a bit of after at the end, so we have 10 minutes
Yeah,
before.
but I need Matthew.
Okay.
I think we're okay.
Yeah, so Andreas is part of the core team in the kernel, the RAS core team, and he's going to talk about external looking for X-array. So please, Andreas, go ahead.
Yeah, so this is a continuation of a discussion we had earlier this year in the Rust for Linux workshop. And let's see, just to give some context quickly. When you want to do transactions across multiple X-arrays, you want an external lock to have transactional semantics across the trees. In this situation, we have, do I have a pointer? Yeah. We have some struct, we have a lock with another struct inside it, and this struct has two X-arrays. And when we access these, we call the lock function that gives us a guard, which when we deref that gives us a mutable reference to the inner struct, and that is guaranteed to be unique. So there can only be one mutable reference at a time to this inner struct. And that means because we can assert we have exclusive access to this X-array, we don't need to take the lock. There's inside the X-array, there's an embedded lock that the API will automatically take for you when you access the array. That's one problem that I have. Another problem is when we want to insert into an X-array, there will be an allocation happening inside the X-array. If you use the simple API, the X-array will go and drop that lock to do the allocation, reacquire it, and carry on. But if we're holding the spin lock for the outer struct, we basically cannot insert because we can't drop the outer lock to do the allocation. In my specific, there it is. In my specific scenario, we have an API for the X-array on list called the reservation API that allows you to pre-allocate an index so that insertion will never fail. But in my specific case, I can't use that because I don't know which key I want to insert on. Specifically, I have a simulated block device where we have a simulation of a volatile cache and a persistent storage. And when we write to the cache, and there's a question down there.
Sorry, when you say key, do you mean the index or?
Yes.
Okay.
So I use the X-array as a mapping structure.
So
mapping from
index to entry, and you have an index. Yeah. You don't know the index, but
I don't know because that's determined by a cache eviction policy, like to select what entry in the cache to evict to have place for my new write. Exactly.
Okay. Thank you.
So therefore, this reservation API is no good in this situation. Okay, so two distinct problems: taking the lock when we have a mute, so we don't need to take the lock, and we cannot hold this external lock while we insert because of the allocation. So in the previous discussion, I suggested we basically bypass the internal X-array lock when we have this mutable reference. I have some code for doing that, and I propose that we give the X-array guard. The guard is what when you lock something, you get the guard back, which gives you the access to the thing inside the lock. We propose that we give the guard an ability to drop the outer lock somehow give it a token or a something that allows it to like drop a lock that's not owned by it. We had some really good discussions. There were suggestions of how to make this nice with field projections, so you can project through a lock guard to get a guard of the inner type, and we could use arbitrary self types to let the X-array self parameter be this guard, and in this way allow the operation of the data structure, and have the X-array drop this outer lock. And Alice commented like this might not work for you because in the same batch, I also produced an entry API for the X-array. An entry API is, if you're not familiar with that, it gives you a handle to a position in a data structure that allows you to operate on it. So like if you say get a certain index, you get an enum back, and that will either have the variant vacant or occupied. And so it's vacant. If it's vacant, you insert. It's and you get an occupied entry back, right? But if you if this insert operation drop the lock to allocate, then once you reacquire your lock, someone else might have raised you, and your vacant entry is no longer vacant because and then that gives like we can make this work because we can detect if we have someone racing us, but it gives you a lot of failure paths in the code. So I think we can make it work, but it's not ergonomic. So that's this is the background. So actually, one of my colleagues suggested to me like, well, why don't you just pre-allocate all of these nodes that you want to insert? And I'm like, but I don't know the index. Yeah, but the X-array is the nodes for the internal nodes for the X-array come from a cache anyway. So you can just like there's a maximum length in the tree from the root to the leaf. So you can just pre-allocate the upper bound of the number of nodes. You get a downwards thumb over here.
I hate the pre-allocation API. I really do. It's so inefficient. I please just no.
Why? Because like at least in my case, I can stash these. What I did is like I made a buffer for these nodes, stash it in a per CPU somewhere, and then the allocation of these is amortized over time.
We'll call it sheaves.
What?
So Liam's making a joke. We've actually made some improvements to the slab allocator recently, which pull basically this entire approach into the slab allocator rather than having consumers like the X-array and the maple tree do it themselves.
So I could hook into that maybe and like get my little pool of guaranteed nodes in there.
Yeah, that's kind of the point. Yeah, you could pre-fill a sheaf and then you know that you're going to have enough for what you want to do. But like Willie said, if we can get around doing a pre-allocation, it would be much better. Maybe, what are the two trees? You need individual access to those, sorry, the X-rays. What are the two X-rays? You need individual access to those as well?
Or what do you mean by individual access?
Well, editing them individually as opposed to in a group. You said there's two, you have an external lock. Why are we not using one lock for both X-rays and letting the X-ray do its thing in there?
Because the spin lock's actually embedded in the X-ray, just like it is in the maple tree. So if you had two maple trees, right, you wouldn't. I know maple tree currently has that horrid external locking support, but
yeah,
like we're trying to kill that.
Right? I don't think we'll ever do it, but okay.
Fine.
Yeah, I mean, so if we get something like that for the X-array, that would be very useful, I think.
Yeah, I mean that's my preference. Is that we actually introduce a way for the X-array to know, and in C as well as in Rust, that the X-arrays know that there is the outer lock,
yeah,
and they just ignore the fact that they've got an inner lock, and they do everything they currently do, but they do it on the outer lock instead of the per X-ray lock. And Alice is gesticulating wildly.
But didn't you just say you're trying to kill the external lock?
Okay, so actually, you know what? We don't have time to get into that. What I'm proposing is different from what the maple tree currently has. Let's leave it at that.
Yeah, what about the slab allocation improvements that avoid the need for pre-allocating nodes? You mentioned that, but you didn't go all the way into it.
Yeah, so it doesn't actually remove the need for pre-allocating nodes. You still need to pre-allocate nodes. It just centralizes it in the slab allocator rather than having it re-implemented in each subsystem. So it's still not as efficient, but it's not as inefficient as it used to be.
Yeah, it does a little bit of, you don't have to return the nodes you didn't use. So you don't free things that don't need to be freed. So.
Right. In this particular case, the way I did it is I never return any nodes. I just hold on to the ones that I allocate until the driver's unloaded. Then I'll return them, right?
Yeah. So that's kind of what I used to do in the maple tree and the pre-allocation. And then when we went to sheaves, because allocating and then freeing those nodes was inefficient, what we do is we take a sheaf that has pre-allocated nodes, and then we hand the sheaf back, which
Would you
still
call it
has
a sheaf?
sheaf. Yeah, it's a bundle of wheat.
Okay, new word day. Okay, cool. I'll bother you guys about that. I think.
Yeah.
Figure that out. All right. So that's that. Let's see. Okay, this is like my why we should do the pre-allocation, right? Because then I have better control over where I can fail, and I get fewer error paths. But the allocating in a central place in the slab allocator would give the same benefits, I presume, right? So that's still valid.
Yeah.
Yeah. Yeah, and the patches for both the entry array and the this allocation buffer is on list. So have a look if you want.
So another thought I have is, so if you go the approach of you have this outer log and you drop it inside the X-array operation and retake it. I mean, so that seems like it could be confusing, right? Because you took the log, but somebody else went ahead and accessed it while you had the log anyway.
Right, I agree.
I think I remember I had some discussion about renaming XA log to XA enter to.
We did, yeah, I recall.
It's like 2 years ago. We discussed this and then it never went anywhere.
But no one sent a patch, I think.
I sent a patch and nobody looked at it.
Oh.
Sorry.
Anyway, I would definitely prefer not having to drop the logs while inside my transaction, because then I go through all the retry logic. Okay. Yeah, so we still have the internal lock that we have to take. If I get a way around that, I'm happy. So yeah, I have some options here, like ask the nice CRA, XRA maintainers to not, because we have like lockdep checks inside the XRA. So if I don't take it, lockdep will yell at me, right? It works, but I get warnings. So we can ask for ways around that. We are playing around with writing an XRA implementation in Rust. It's just a toy for now. It's we have it in user space. It's sort of let's see what's possible. Like how far can we get with that? And then someone told me you can actually just lie to lockdep. You're not supposed to, but there's a way where you can sort of just ask lockdep to not care.
This so I don't remember if it was XArray or what it was, but there was some API where I was writing the Rust drop implementation, like the structure. And when that code runs, you know that you're the only one accessing the entire XArray. And so you don't really need to take the log. I think I ended up taking the log anyway. But I think it would be nice to have XArray APIs where I'm promising that I'm the only one accessing the entire XArray, and therefore it's safe. And,
exactly. That's it.
And if you want to allocate, you can just do it because I'm the only one accessing it, because I know that from code structure. And so there's no need to even release any logs because I don't need a log.
Yeah, I mean, I think this is XA destroy essentially, right? Like we're deleting the entire X array. So
yeah, but before I call XA destroy, I have to iterate it to call it destructor of every item.
Yeah.
In case they have a Rust destructor.
Yeah, no, absolutely. There are similar things on the C side, and I was like, oh, I don't really need to take the lock here, but there's all the lock depth checks, and then I thought, why am I trying to optimize the destruction path? This is not something anyone's ever going to notice or care about.
Yeah, but even if it's not the destruction path, I mean, in Binder, I have a bunch of red-black trees, which is kind of similar, right? When I access the red-black tree, there's no internal log. I have to log it externally somehow, and I just call, and the red-black tree API in Rust uses mutable references, which means I have to say I'm the only accessor of the entire red-black tree right now, because I have a mutex or whatever. And accessing the X-array using that logic when it makes sense, I think it could be useful.
Okay, so I talked to Andreas about this problem a bit yesterday. So one of the future pieces of work, and this has been pending for like 7 years at this point, so I'm feeling a bit dirty even talking about this because nobody's done the work. One of our dreams is that eventually we will be able to compact slabs. So if we have a slab full of X-array nodes, or rather we've got like 50 slabs full of X-array nodes, and they're all like 2/3 used, we want to be able to reclaim some of those just to free some memory back to the system. In order to do that, we need to know that nobody else is accessing this node. So the compaction asynchronously to any Rust code that's running, asynchronously to any C code that's running, will need to take the lock and know that taking the lock has excluded things like the XA destroy path from changing those nodes under it, because otherwise we're going to be leaking memory and all that kind of stuff. But of course, nobody's actually stepped up to. Well, no, somebody did step up to do this, and he got to like V10 of his patches, and then I think he decided it was never going to land and went off to do something else. So if you look on the Linux MN mailing list, you will find the old patches. But yeah, we haven't landed it. But at the time that I was doing the X-ray, we thought this was a genuine possibility that it would land soon. So we went to the effort of doing all of this locking.
Okay, but that seems like unless it never lands, that seems like a good reason to design the REST API with that in mind, right? And then you do actually need the internal log no matter what, even if you have an external log.
But maybe we shouldn't design the APIs around, I said, like 7-year-old dead ideas.
Yeah, I say, I'm deeply conflicted about bringing this up as a reason not to do what you want to do, because I mean, I can see, 4.3% performance improvement, like exactly. That's not nothing. I mean,
it's a this is the most it will ever be, right?
Yeah.
Kind of benchmark.
Yeah. But what I would say is that I don't think this precludes us from using the external lock approach. What we need is a way to get from, here is a random node in the X-array. How do we find the lock that controls it?
Yeah.
And there's ways to do that. So
it's not possible to walk up the tree, right? Do you have back pointers? No.
Yeah.
You do?
Yeah, we parent pointers.
Walk, I guess.
So yeah, you can walk the parent pointers all the way to the tree that holds it. What we don't have yet is anything at the top of the tree that says the external lock is over there. That's all we would need to add.
Oh yeah, but also you can't really walk up the tree if you don't know if you have the lock, right? Because it might get ripped out from under you.
Because we support RCU.
Okay, yeah.
We can.
All right, sure.
But that's kind of interesting. So I think in Rust, if you do external logging, right, you have an external log and then you have your X-array or whatever inside. Like if you do that the obvious way, it's not safe to go from the X-array to the log, because the log might be in the process of being dropped, but we haven't gotten to the X-array first, right? I mean, let's say I have a log that protects 5 things and the X-array is the last one. I might start destroying the things, and I've destroyed the first 2 of them, but I haven't gotten to the X-array yet. I haven't told the X-array yet that I'm going to clean it up. So it's not safe to go to the mutex anymore. But And if you want to write the Rust code so that you can actually go to the mutex in that case, well, I won't say it's impossible, but the obvious way of doing it won't work.
Doesn't destroying a mutex require you taking it? No, you can just like you can destroy a mutex that someone else is holding.
Okay. I have to stop you here. Sorry. I think I try to give you 20 minutes, so the original time. We have 10 minutes of buffer at the end, so we are only 5 minutes late. So let's go with the next one. Thank you, Andreas. Thanks a lot.
Thank you.
And also thank you to the XRA maintainers for joining. Thank you, Matthew. Do you have it? Is any of this? No?
Let me see. No, wait.
Otherwise we upload it, no worries.
Wait, let me check it.
No, I don't think so, right?
Don't think so.
Okay. So.
Presentation.
Yeah. So download, save, quit, zip, upload, browse, presentation, upload,
yep.
And then it will appear automatically.
Yeah.
Okay, so we are going to move to another different sort of topic. Benno is part of the core team as well. He has been working on quite a few things, like reviewing a lot of patches from everybody, but especially Pininit, he solves a major source of unsafe blocks in the kernel. So he's going to talk about it a bit. So thank you, Benno.
Thanks for the introduction. Yeah. So I'm currently thinking of writing a chapter for the Rust for Linux book on initialization. I started this effort because Pininit has become a much bigger thing in like the last 2 years, I think, and it's currently very, very entrenched into many things, because initialization is very important and more difficult in Rust than in C. But let's just go first through a few goals of my talk here. So I want to give a good explanation for why we need such a complex library just for initialization in Rust, whereas in C it's very straightforward well, compared to what we have to do in Rust. And I also want to give an up-to-date introduction to Pininit, because it's been a while, as well as I have been adding new features, and it would be probably good to give a overview there. And next, I also want to obtain some information about on how to go about writing this book, because I know so much about Pininit that like it's very well, it's just second nature to me to just do it and handle it, and I've had the experience that for others it's not that easy, and it's not that intuitive when you try to use it the first time, especially. And then it gets better the more you use it, of course. And for example, Danilo, who sadly couldn't make it here, has become very fond of it and is using it in many APIs in the DRM subsystem, and putting it to good use, and also asking me to implement new features, which is also very, very great. Then I also want to give a small outlook on the future of Pininit and in-place initialization in Rust in general, because we're working on moving, or well, giving a language feature that implements the same thing as Pininit, because having it integrated into the language gives us much more leverage as to what we can do with error messages, overall diagnostics like extra warnings and so on, as well as support for other features of Rust in a more native way. And so questions, of course, welcome. Please just interrupt if you have anything here. Big discussions I would like to move to the end, but I think just from the micro-conference spirit, we can also just start discussing in between if it's something important. So why is initialization so complicated in Rust? Let's take this very simple example from C. where we have a big buffer and we want to just initialize it with a value. We can just do this, and the equivalent code in Rust looks like that. Now there's a big difference here in the code, because C uses an out pointer here to write to the buffer, and Rust just returns it by value. So in Rust, this will require a stack space of 1 megabyte, and in C it doesn't, and that might be a problem. So that's the first difference. So in Rust, we don't really have a concept of an out pointer. And yeah, so in the kernel, this would overflow the stack. So there are many conventions for using out pointers in C that all of you know implicitly and use. And if somebody does it wrong, you point it out in the reviews. For example, you always have to initialize the out pointer value when you have an out pointer or write an initializer function. Well, not always. If you have an error, you don't do it. And it's actually important that you don't do it, because if you return an error, then somebody might not clean it up afterwards because they expect it to not be initialized now. Well, except in certain cases, you also initialize a part of it only, and so on. So there are many, many different nuances to this, and it's actually like tribal knowledge that you have to have in each subsystem for how it's being used. And this can also, well, all of these conventions can be broken if you need to do that. In Rust, this is very incompatible with how Rust does things, because all safely accessible data must be initialized. We don't want to run into accidental UB. And this is a hard rule. We can't bend this. We can use unsafe code, of course, but that's not what we're here for. So we have to somehow find a way to make this safe and still keep all the data accessible. A bit about out pointers in Rust. They don't exist today. And they would have to solve a very difficult problem, because they would have to ensure that you initialize the value before you return from the function. And we still want to have a error compatibility. So if you return an error, we want you to not store stuff in the thing. So that involves very complicated control flow analysis, and also completion. Like if you have a struct, if you have an out pointer pointing to a struct and you only initialize one field, you have to give an error. And this is very difficult. We're currently working on this as part of the discussion on the language feature. But yeah, it's very difficult. So let's go to a bit more advanced example in C. So we have this struct that contains our buffer from before and a mutex. And we want to write the driver probe function, where we write it to our foo device. And so we take the private data, we allocate, and if the allocation errors, we return the error. And then we just grab this pointer for the private data, and then we initialize the mutex, and then we initialize the buffer. And this is should be rather standard, unless I messed something up. In some sense, the private data pointer is an out pointer here, because, well, we're just writing to it. And one important thing that we all know about the mutex is that you are not allowed to memcopy it around after you initialize it. In Rust, we call this moving. I don't know if you have already heard that. So we're not allowed to move a mutex after initializing. And in Rust, we say that we pin a value if we require it to never move again. So this is how we talk about it in Rust terms. And in Rust, because we want the mutex to be initialized from the get-go, we also say that it is pinned at creation. Let's take a look at how we convert this example, or rather how we initialize in pinInit, and later we will convert the mutex example. So first, let's start off with the buffer example and fix this weird Stack Overflow error that we have here. We first change the return type to, instead of returning self, we return an initializer of self. And this, we'll have to change the body still, but this will ensure that we, instead of returning the value directly, we return something with which you can initialize the value. Then we will add this init macro around the struct invocation, and now this already works. So this won't overflow the stack. In that, well, not exactly. We have to change this as well. So this is a bit verbose. I will just show a shorter version of that in a second. But essentially, this will write the value to the array. And now we are overflow free. This back arrow signifies that we want to in-place initialize the field. And this is the shorter form in which you can spell, because everything, the generic arguments will be inferred by the compiler for you. Any questions so far?
Does that end up creating a lambda effectively?
The initializer, you mean?
Yeah.
Yes, it effectively is a closure in Rust, and it also uses an out pointer under the hood, but that is very unsafe, and this macro hides that away.
So is there an actual unsafe code in the implementation of this?
Yes.
Okay.
Here's a question.
Which was the language feature?
Wait.
Wow, cool. Which was the language feature to which you were referring?
In-place initialization.
In-place initialization. Sorry, I don't have all the context here, but is there a reason that library-based solutions that use some kind of ghost variables or type state to track the uninitialized state of memory were rejected? Like, why does it need a language feature?
So, because we want compatibility with other language features as well, and because it's a very primitive notion that language should contain.
Fair enough. It's not very ergonomic if you add a bunch of type parameters to try to track initialization state.
Also, diagnostics, we can give much better errors or warnings or suggestions on what to do differently. For example, if you write the code from before, you could now add like a warning, hey, this overflows the stack. You should use in-place initialization for that.
Cool, thanks.
Yeah, I mean, like the macro is a reasonable way to do it, but I think we can do a lot better with the language feature. Right, I mean, let's take what we managed to do with a macro and make a language feature that can do it better if it's actually going to be useful in the language.
Yeah, and I mean, just to pile on, I've always felt that if you go one level higher in reasoning about this whole thing, it always seemed to me like a huge missing chunk of Rust. The Rust describes itself as a systems programming language, but I would at this point describe it as a almost systems programming language, because you can't do DMA. You have no concept of memory staying in one location. So it really belongs in the language to complete the story.
Also, sometimes even if a language allows, in principle, to do something as a library, right? In C++, there is this principle sometimes that people claim that, oh, we can do it in a library. The language is great because we can just write it as a library. But that's sometimes problematic. That compile times explode. Sometimes optimization is worse. Just to give the example of variant. In Rust, instead of std variant, we have enums and proper enums, and they are way better, right? So sometimes you really want something in the language for all those reasons. Yeah.
All right, and we can also add any other fields that we want and initialize them just as well. So also the order is honored. So we'll first initialize the data and then initialize the count. Which will be important later. So just some things about the details of pininit. We have this trait as an initializer, and it is an object that carries the data needed to initialize a T. We already spoke about the internals. It is effectively a closure which carries around the data needed to initialize the value. And it's when you don't run it, the value is not. You don't create the value. So don't. If you just create the initializer, nothing will happen essentially. There are several ways to create an initializer. Any value by itself can be turned into an initializer by just moving the value to the location. Then we saw the init macro to create an initializer for the struct. And then there are several functions in pininit to turn initializers into bigger initializers as well. For example, we can also have zeroable data initialized by a zeroing initializer. And then there's the complication of pin that we talked about before. We need all of this again in a slightly different variation in order to ensure that values that ought to be pinned after initialization or at creation actually stay pinned well after they are created. So we have the duplicated trait, the pin init trait, the pin init macro, and so on, and that's also how the crate gets its name. Additionally, we need a compatibility between pinned initializers and normal initializers, and that is that each normal initializer also is a pinned initializer, because the only condition that a pinned initializer additionally gets is that the value after creation will stay pinned, and every normal initializer can harp with that. Now let's try to convert the C example that I gave before into Rust. So we start out with the struct definition, and here we combine the buffer and lock into one field, because that's how Rust locks work, and that's great. So we only have now one field that we have to initialize. And let's take a look at the driver probe function. In Rust, we normally, when we write an abstraction for a driver, well, a probe function, we do it with a trait, and which I call the foo driver trait, and we implement it for my driver. And then we have this data field, which we instead give for the private data. And then we have our probe function signature, which looks like this usually. And the aref here is used for reference counted objects, so which is usually the device which is reference counted. And then what we don't allow the user to do is access the private data pointer. Instead, we let them return a pinned initializer, and then we will allocate for them and then use the initializer to initialize the private data. Now, since we do the allocation for them, we can get rid of the allocation code. And also, now we don't get an error at the moment. So we can also get rid of the error code and the other stuff. And now we translate the mutex init call, which will turn into the mutex new function. And buff init will turn into buff new, which we wrote before. And now we just need to combine them in the correct order and put the pin init macro around that. And then this will give us the full function, full converted code here.
We have a comment from Paolo. Can you give a summary of the competing proposal for initialization, autoreferences, and there is a link to a HackMD, and which one is more likely to succeed?
So we have many different proposals for in-place initialization going on at the moment, and there's a huge discussion on what way we want to do, and we're essentially taking the best bits from every proposal and trying to merge them into one. And so I don't think that we can say there's one proposal that will take over in the end. We'll try to pick the greatest parts and come up with the best language feature that we can get. So I don't think that I can say, well, I would say they are competing proposals, but we are trying to merge them essentially. And a summary for the proposals that we have. So we have one proposal that gives us out pointers, where we try to give some, like, add more stuff to the borrow checker, so that the borrow checker can track which fields you already have initialized, and then if you don't, you get an error. But that requires us to return something in the function called an init proof, where you essentially prove that you have initialized the full struct, which would be created by the borrow checker, but we have to track it in the function signature, which stuff has been initialized. So that's pretty complicated at the moment. So we're trying to see if there are ways how we can simplify that. And the next question is why initialization trait takes a raw pointer and not a reference. And to that I say, reference is currently should point to initialized memory. I think there are some discussions of relaxing that condition, but for the moment, using a raw pointer is the correct semantics. We could use a reference to a maybe uninit. That would work, but that's not compatible with unsized values, and I think we at some point want to have initializers for unsized values as well. There's a question there.
Thanks. So do you support, or any proposals support, an alignment of where you initialize?
So the types in Rust specify an alignment. So if you want a bigger alignment, you should specify that in your type.
Okay, and so then when I pin it, it will be pinned to that particular location with the alignment.
Yes.
And I put stuff in the unused alignment bits.
Well, that's like a different part, right? So you're talking about the pointer to the thing, and the thing doesn't have to have any say in how the pointer looks like, right?
Right.
And like
so I can bit or things in there and
yeah.
Okay. What's that? Okay.
Yeah.
Putting stuff into the unused bits of the pointer is not something this feature does.
Yeah, so this feature is entirely concerned with the value itself at the location. So it doesn't do anything with pointers or stuff.
So in our experiments with writing the X-array in Rust, we we use the X-array uses the lower bits that are guaranteed to be not used by the pointer because of alignment. And I was actually talking to Chang the other day about this, and using these bits for niches to store data is not currently supported, but it's something that maybe someone will look into, right? Yeah.
Our niche optimization doesn't recognize this pattern, or we don't support it yet, but we can look into that.
You have many different pointer types in Rust. You could have pointer types where you can do it, right? I mean, the normal box type for storing an allocation doesn't do it, but you could have a box 2 that does it.
Okay, so we have one final thing that we need to add to the example to make it compile. And that is in the struct definition, we need to add this pin data annotation at the very top. And then we need to say that the buffer field is a pinned field. This might go away in the future, depending on how a certain language feature evolves. But this essentially says, well, it generates some code that makes the pin init macro work correctly. And in Rust, at the moment, you can fields of structs have a property which is called structural pinning. And it means that if the outer struct is pinned, the field is also pinned. Because you could have, for example, like an integer there, and the integer is not something that an integer you can't really pin anyway, but you could have a field that you don't pin and that you're still allowed to move out and move into. And in that case, you wouldn't put the pin attribute there, but because the mutex shouldn't move, we put the pin attribute here. And as I said, there are some discussions in the language about making this part of the type. So you say mutex will not move, period, and then this gets a bit easier.
Yeah, that pin attribute on the buffer, the mutex type, does that end up accidentally pinning the buff as well?
The mutex gets to decide which fields of it are structurally pinned. And we recently changed this. And so the buff will also be pinned. Yes.
Okay. That's a choice.
Yeah. But the mutex won't move. And so if you put something, so also important thing in Rust, there's a thing called the unpin trait. If you implement that, then pinning doesn't concern you whatsoever. It's, for example, implemented for integers, and then you can just ignore this.
This is just like in the spirit of intuition. I was curious, like other cases where it makes sense to use a box versus dealing with all the complexity of pinning.
Sure.
Although stuff that is allocated with a box is fixed on the heap, but it can still be moved, right?
Yes.
There's that.
So you can pin a box, and then the contents of the box will never move again.
Yeah, you can pin a box. But then I guess in that example you showed, you can't really use a box there because you have all this allocation and freeing. And so if you need all those features, you need to use the pin in it.
Yes, exactly. So if you want to, for example, you could always box a mutex, and then we wouldn't have this problem. And that was discussed at some point, but it's not feasible from a performance standpoint.
Okay.
And you?
And is there a way to, like, because the way I need to use pin init and the whole pin logic when I know that the memory must be not movable. I was wondering if this is more of a semantic thing, right? I was wondering if there's a way to automate and immediately recognize, if I look at a patch and I'm like, oh, there's a bug here because this guy didn't use the pin init, something like that.
So if you're not using pin init, but you still require, so our APIs that are designed with pin init, you can only use them with pin init. So there's no way to misuse the API in that sense because, well, unless you use unsafe code.
Yeah, but like let's say there's a mutex, I know that I need to use pin init because otherwise the memory is moved and mutex is broken. But this is not like, is it detect, like, do I get an error when I try to compile? And or otherwise, when I have a larger location, for example, on the stack, that would be a runtime error, right? Not a build time error.
Yeah. So Kayland, for example, Gary was working on detecting too big stack frames in the compilation unit. So
okay. There are tooling around.
Yeah.
Okay.
Yeah.
For the mutex, you cannot construct it without pinning it.
But the mutex is kind of easy because it's designed to be like.
But for other values as well that can only exist pinned, it's simply not possible to construct them in safe Rust without pinning them.
So
Sorry, bit of a simple question, I suppose. It wasn't clear to me when the initialization actually happens. Like, is it at the same site at the pin init macro, or is it later?
Yes, it's later.
Okay.
So you have to run the initializer. There's, for example, a special function called box init, where you can pass an initializer to, and then the box will create a new box and put your value directly inside.
Okay, so that is a behavior change technically from the C implementation.
Yes.
Okay, thank you.
It is more comparable with you would return so you're returning a function pointer which points to like an initializing function. That you can compare it with that.
One question here in terms of like if you have variable alignment in the structure itself, do you have to can you manage that in the Rust in some way, or do you have to do substructures to have like that the alignment defined in that particular context?
So the compiler will assert that types have the maximal alignment of their members, and it will also like structure the members such that they are aligned, matching the whole struct.
Yeah.
Because it doesn't honor a declaration order of fields. It can move them around depending on which representation you use. I'm not sure exactly what.
Let's say, for example, I have like a ROM table that I want to like process or parse. I don't like get initialization out of that has like certain aspects that are like byte aligned, others are dword aligned, and other things. How does this map to like the initializer?
I'm not so sure what you mean by the alignment has to do anything with initialization. For me, it doesn't have to do anything with it. So. Okay, so I have a lot of other things here which I could talk about, but I'm just gonna skip them. You can look at the.
We have 7 minutes until the break. 7 minutes, 5 minutes, and then Xiang will talk after the break. Okay, and then we are back to schedule because Daniel, his talk was promoted to the referee track yesterday, so we have more time there. Yeah, thank you.
Okay, good. Well, then I can still go through error handling, which we have ignored for the moment. And so let's say I want to add a new field to my driver data, which is an arc of some stuff. And an arc is our version of a reference counted object, which is like a box, essentially. If you've programmed standard Rust, this is not the standard arc, but our arc. And we need to allocate to create it because, well, where otherwise would it live? And so since allocation is fallible, we also need this support in our initializer. And we just do that by adding the error type that we use in the function signature, and we have the kernel error type, which represents the error no from C. And now what we just do as before, we initialize the buffer. In this case, we do it as the second field. And to initialize the arc, we can just call the arc new function where we pass in the data that we want, and then the GFP flag that we want to use. And the question mark operator works as expected here. It short circuits. When the allocation fails, the initializer will fail, and it works as you expect. There are some weird quirks when you have error coercion. So if you have two functions that return different errors and but coerce to the same error top level value, then you get into some problems. But that's not too concerning with the kernel, because there we almost always use the kernel's error type. Question?
Also kind of related to my previous question, since the initialization is now deferred to like a different place, this means that this error handling needs to happen at that place now, as opposed in the new function.
Yes. There's a Are you awake now?
No. When you get,
I'm sorry, you have jet lag. Sorry, Daniela.
To not get into that, you don't have to put the allocation of the arc inside this pin init. You can lift it out, and the allocation of that thing will happen at the time that the new function is called. So you don't have to defer. You can allocate the arc first before the initializer runs, and then you just pass a pointer basically. You can move the arc, yeah. But the data is on the heap, so you don't move that. You just move the pointer, right?
So the initialization of the buffer, you said that one of the nice things about this is that you don't leak stuff on failure, right?
Yes.
So how does that work in this example? Like you've written zeros to the buffer, but the arc fails. How does that work?
So the buffer luckily doesn't require us to drop anything, but let's say we had two arcs, for example, and one allocation works and the other fails, then the pin init macro will go back and deallocate the thing before failing the initialization.
What about the buffer new zero stuff?
That will not happen if the first one fails.
So you should always put the stuff that fails first in
well, depending on what you want to happen, right?
Yeah. But it's you can leave side effects is my point.
Yes,
failure.
You can have side effects, exactly.
So you have to be careful with.
So the initialization happens in the order that the fields are described?
Yes, in the initializer.
Okay, thank you.
So just to follow up to the question asked before, so if buffer new had a side effect that you need to drop, and we had some allocation, or not allocation, but initialization after that fails, what would happen is if that returns an error result, would buffer get dropped, and then any of the requirements to tear down the side effects be gracefully cleaned up?
Yes. Okay, and that more or less concludes what pininit had been doing for the last 3 years. And there are a couple of new features that I have, and I won't go through too much detail. So I'll just give them on this slide. So I've added code blocks that you can run in between your fields. If you want to run arbitrary code, for example, if you need to call into the seaside to do some random stuff. You can also do it at the very beginning if you have not initialized any field, or at the very end after you've initialized all fields. Then I also give you access to all previously initialized fields. For example, if you again need to call into the seaside and like give this some random pointer to the seaside, or do some other stuff with already initialized fields, like read stuff from them or write to them as well. And then also, most importantly, I provide pin projections using the pin data macro, which allows you to turn a pinned reference to a struct into a pinned reference to the fields, which you almost certainly will have to do if you're working with pinned structs. And then I've added this init scope function to compute data before even creating an initializer, which you might want to pass to multiple fields, but which you can do with accessing the previous field. I have some details.
Oh, yeah. So one quick question about pin projections.
Yes.
If the field implements the unpin trait, will that just implicitly convert the field directly to the non-projected variation, the mutable reference to the field?
So pin of a unpinned, so if you have a pinned mutable reference to an unpinned type, then that implements deref mute, and so you can turn it into a mutable reference to the thing.
But it won't be implicitly coerced.
It won't be implicitly coerced, but maybe Alice, you want to say it? No.
So right now you put the pin annotation on the field, and you're not supposed to put the pin annotation if it's not something you want to pin, right? But there's a language feature that might replace the pin annotations with using the trait.
Yeah. Daniel?
As that thing we discussed a couple of months ago about like composing pin, where you needed to have a box in order to build it. Do you remember what I'm talking about? Yeah.
Yes.
It's a pin of mutex t where t is pinned, I think.
Yes.
This is going to be solved with your new pin projection feature?
I think so, yes.
Or is it unrelated?
I think we probably should go into that detail after the talk, but I think so.
All right, that's okay.
Okay.
Thank you.
Let's wrap it up. Maybe last.
So just let me go to my last slide. So I have many improvements coming. If you want to take a look at the slide or slides later, many different things. The most important thing in the list is that we will have syn now rendered in the kernel, and we can use way better proc macros. And from the language feature side, we have lots of stuff going on, and well, we're coordinating with many different things, and we're trying to create a good feature that the kernel will benefit a lot from. And we feel like that the Rust side has seen the value in having like the so-called killer app, which is the Linux kernel, to essentially drive the development of in-place initialization.
Yeah, and one comment that is that people like Benno, and others are the ones. So people from the kernel side as well are developing these features in upstream Rust in the language. So we have some influence on the language that we want in the kernel, right? So that's great, because we have some influence that we can get a better language for the kernel, and that's what we wanted since the beginning. And it's great. It's not just Rust doing their thing and then we use it. It's just that really there is people from our side developing those features for the kernel, and then other projects, of course, to use.
So, and then thank you for your attention. If you want, you can come up to me and ask any questions and give me feedback on how to start writing the book, because I feel like I'm not too sure what are the difficult parts, or where you have problems understanding, or where you need like additional examples. I think like for C developers, giving code examples in C and then the translation to Rust is very helpful, because it's what you already know, and then you can match what things are different or which stuff is the same, and yeah. So any feedback, welcome.
There is something Gary said. yeah, Gary's making a joke. Gary's making a joke about the C committee or C++.
Yeah, so thanks.
Thank you, Vero. One comment on because Beno is mentioning the book. So this is something that is not yet announced, but you are getting a hint of. So we have been thinking about for years, even since when we started. Ben, Wesson, and I, we wanted to write a book. So we may have the time now to do it. So if we get to a point where we can announce it and it's a good thing, you will know, right? And one of the first chapters is Beno that will be writing it. So okay, thank you. We will continue with Xiang after the break, and then the schedule is the normal one. Thank you.
Fix that problem. I need that in here.
Which problem?
I think
So the mutex should be done.
I sent the patches, but like
yes.
Something was missing to make it work.
Pin projections.
That's what I'm asking.
Yeah, those are in.
Pin projections are it?
Yes, it's master. Master.
So I can do mutex of T where T is bin, and I can access T. All right, thank you very much.
You have to call dot project. Call dot project.
Oh.
And then you get the struct out where you have all.
And also, he will join online.
Okay, we're gonna need that into your soon.
Yeah. He will join online, present online.
Okay. So. But you are in his break now?
Yeah.
Yeah. Well, it would be nice to have you here, nevertheless, on the stage.
Yeah,
okay?
I will
so that you
hear.
can control the slides and so on, and he can enable the camera.
Yeah.
But he has the VB login. He can join he's able to join and chat, or he doesn't have.
I will confirm.
Okay. Well, confirm that he can join the room and that he sees the chat and everything. And if he's there, also we can do a test if you want to do it right, that he can enable the camera. Okay. So maybe it's the best.
Yeah, I'll do that.
Okay.
And you can use it.
I have a quick community question for you. This is my first Linux Plumbers conference.
Oh, really?
So I'm a former professor in the kind of programming languages in the Tyler area. My students made a lot of contributions to Haskell, and to a less extent to Rust. Like, we sent a bunch of interns over to the Rust team in 2013, 2016, when the language was changing fast. But I was curious, like, when I used to go to like Rust meetups, sort of a weird combination of C++ keyboard and Haskell keyboard language. It's obviously like, yeah, is there some subset?
Yes. So,
I just want to ask.
Well, I know developing.
Oh, the guy just gets to talk.
Which again, cool. That's like C.
Yeah, exactly.
So Gary, so we have been working
in the governance.
Way to get a.
Yeah, we heard the statistics on this yesterday. Like 20.
Yeah, so there is one is the last one, right? Which is the global. That one we have a bunch of people that are really expert on that. Not just us, for example, there's also Bjorn, and also
About to grab one.
So we have.
Not to be confused with Bjorn's true stuff.
No. It's
Are you trying to get the?
I'm trying to, yeah, I'm trying to get the easiest page. Oh, the hand up.
I think you would need some.
For example, the top one, I think.
Got it. I just feel like the whole Rust experiment was last 10, 15 years. It's such an interesting sociological experiment, colliding together like systems and people who work on operating systems with a lot of fairly esoteric language features that are very much inspired by academic stuff, essential types, traits, so this collision of worlds is very interesting.
I knew the problem was we got a we managed to get things and have we would say
So we got in my school got these people from both Rust experts and kernel experts together and work together.
I've seen some of these blog posts about over these like anti-Rust rants for the kernel folks that were.
Yeah, there is people maybe that Rust on the Rust side more. But that's not. I didn't know Rust. I was not really Rust. Take the needle. The needle, for example, he was actually so people around we are. I was in the C committee when I started.
Oh, you were the C committee? Oh, C committee. Did you know Jeremy Seek or Andrew Lundstein?
Well, I knew.
I never used this.
No, I was
yeah, but now you are.
I was telling the
oh.
Never used it.
Yeah.
Not if there is something that counts. Or I will use it. In the school, I was telling you guys need to act. Like, you need the feature of Rust. You need it. And I'm telling them, I have lost I see like that. I was telling them, like, you need the feature.
Does this happen?
I'm trying to log in. Yeah, how to log in this.
And I am there, but it's like, and they have this paper, and I'm like, it's not even it's not, even the finish one, not reaching one. I tell them, I can up an age and they're like, well, I need to, because today I can write in the graph. And it's much better. So what was it? And I was
That's also all of the other features that we use.
Exactly.
Well, that's interesting. So, like, I'm new to kernel stuff. I made my first kernel patch this fall, but a language compiler guy. But you know, I've always used CLD as a compiler target. Like, it's fine to compile to C, but oh man, not yeah. Your C kernel seems so exciting just to have like parametric polymorphism, like parameterized types.
Yeah. So it's,
although I haven't actually seen much of the rest of it yet, I don't know how it deals with all the mismatches. Like the list abstraction, like you have to interoperate with a lot of C.
Yeah, we do.
Actually, we don't write anything. We have to just write abstractions that come to the C side.
In fact, that was the big test that we had to prove. What we had to prove in the beginning is, can we actually write those abstractions? Because that's the hard part. Like, really, the effort, it's not great, whatever, it's really writing abstractions. Wrap all the same C code, and then provide that safe interface.
So I haven't seen this basic thing, but the list type in Rust has a proper type parameter.
Everything is wrapped in safe interface.
Even though the memory representation is still just the same.
Sometimes we use
it's a bit weird to use.
Sometimes we use native implementation for the abstraction. And it's easy.
We have a vector, for example.
But the most other moments,
a vector is writing.
But most of the ones that we do, we call it to zero. So we just call it to the normal.
We just want to do things by types. It's all about add type parameters. But you can track the properties of things that are always like.
Is that really? For example, I think I had a post here. He is great. It's like, yeah, the really hard part. Write them. The rest is smooth sailing. If you have a structure really nice, then the rest is easy. And everybody writes right ways. Some can write 100% centralized. And people say, no, it's impossible. No, it's possible. We already have that. So just they're great. 100% safer.
I love you reducing that safe blocks. That's cool.
Yes,
this is the first time I saw the init syntax. It looks a lot like Haskell and Nets.
We had a lot of concept of Ben up here, he was a student in university. Well, he's still a student, but he was starting and he's like, oh, I want to, I think this is bad. I have this idea. So he and Gary essentially solved it and gave us that's good because we removed some amount of potential annotation. Broken
Is your research tribe OS or programming languages or which area are you doing your PhD? Okay, so very much PLN. So Popple? What's your home conference?
Oh no, I'm not yet a PhD.
Oh, okay.
I'm just applying.
It's about to. Good luck with that. I was a professor in that area. So like Popple, PLD, I was my home conference. But we do have some good crossover conferences like AskPlus, sort of. We got some others. Oh, well, I don't have tenure anymore. I was at Purdue. state of memory.
Yeah, so we had all these amazing students like Ben and others.
Yeah.
We're very young when they started. Now they're not so young. But I mean, 5 years ago, consider Ben, 5 years ago, he was very young, and he was great. And then we also have people that is way more senior that really wanted to have not just that these were young or as people.
The growth rate is amazing. Like 4x in 1 year.
Yeah, actually it's 5. Like it was 4.577, and that's not even counting the vendor. You can't depend on quality system.
Yeah, we don't count the vendor.
We don't count the vendor. It's almost 5 times. I said 4 because that's for a year, but LPC was far. I count since the last LPC is almost 5.
Have you at all experimented with the ability of today's agents to help with code wording?
Yeah, they can do it.
Because it just seems to me like an area where they're doing particularly well. I'm having a swarm of agents support a 500,000 line Java program that's going pretty well.
Writing abstractions using.
Abstractions? Oh, no, I mean the drivers.
Oh,
yeah, no, I mean, the thing is like, the more strong types you have, the more you can set the agents on track.
Not just
But I just need the raw porting of code.
Not just so I don't know if you were in the beginning, but we were discussing, it's also the documentation. Because we way more, we, for example, write all the safety conditions before enforcing the beginning. You have to write. Therefore, it's not just, you have, you know, when you write the safety condition, in C, you have function, right? You have to assume the function is correct. And then you infer from that what's supposed to be the behavior. But then if it's the back then, you don't know whether there was like it was an intention or it was intentional. You don't know why, because we if you unfortunately have to write the condition. If you see a mismatch, so if you see a function, that's an for example, there's a safety justification, right? And that safety justification doesn't match, that doesn't work with the definition that you have for the function. Then you know it's bugging function automatically. So it's like an unrandom correcting code. You have redundant.
So you're saying the safety preconditions are in the comments,
yes.
But if they could be enforced in like a horror logic or something, as a precondition.
But what I mean is even in English, it's way more useful because it's error corrected like in C.
But ideally, you would sort of port it from the comments to like some actual type system precondition.
Yeah, we try. I mean, we put as much as possible in flags, of course, we try. But then it's things that are either very anaerobic or very hard, right? So the others are in English, but they don't have it in English because that was a question in the beginning. Like, it's going to be that useful.
One example there, for example, the loop list has a function called remove, which you I think that's unsafe.
Yeah, I'm testing that. He will already do it.
Because I don't know if it's in the right list that you're giving. Well, no, that's not the right one. I think there's one function.
But you're saying even the Rust wrapper remains unsafe.
No, okay. Almost all functions are safe. There is one exception where you have to use an unsafe because I can look it up.
Now I wish I had business cards this modern era. And I'm just music. Yeah. No, I'm just excited to see it make more progress. And gradual typing, you're familiar with gradual typing. So gradual typing in programming language theory, which you're going to be doing research on. Oh, you're doing, okay, so you're all the way to figure out how much of a
yeah.
Got it. Yeah. I mean, it kind of overlaps.
Yeah.
Do you do a lot of stuff with group assistants? What's your favorite point? Agda? Okay.
You know about that?
No, I haven't. I just know Cool. All right, so this is funny because like Linux kernel and type theory very opposite ends, but I should let you get it.
Y luego nada, luego now, so they were paying several companies were paying now I'm independent. So the idea is that I can be independent, so they can tell every company now. So I can tell everybody. know if I.
Does your badge say independent or?
Yeah, it doesn't say.
It is. Right, correct. This is the function on the list.
Yeah, and then at runtime, measure specific. Well, I mean, not because I don't want to hear.
No, so the problem is you have a race condition.
But the question, what is recommended essentially, obviously here is a function, just a question.
Oh, yeah.
So we have we enable the how's it called unsafe. Yeah. But we're not. Yeah. So we always require unsafe operations to be marked, even in unsafe.
Oh, so even the quality you want to make
Because originally in Rust, they are
able to do here.
Yeah. Originally in Rust, an unsafe function implies that the body of function was unsafe. But in reality, it's completely opposite. And therefore, now they are seeing the language that change that, and they are going to, if you are doing this also, they will be a error in the future. So it will be opposite. So an unsafe
But it's nice because it makes it super graphical. Like if you count exactly the number of unsafe errors. And so is there some extra pattern you can add to the outside to have like a safe Rust way of removing things?
Yes. So we have like the cursor. You can walk with this, and then you can remove the item where the cursor points at.
Cool.
And this thing is only for the case where you have the item and this, but you don't know where exactly it is, and then you have to walk.
Yes. I've had a lot of experience with developing cursor libraries for dealing with type safe manipulation of serialized byte streams. Yeah. So you serialize or custom message. We still want to access the images. I don't know if they're good Rust libraries. We had a specialized file for this master. But it's something like because and you need to do exactly it's not tracking initialization because you're literally writing out the structs bytes like serializing the tree, children of the tree. So for that kind of scenario, it's not just structs, it's like a whole person thing.
I mean, I recommend doing it now.
Yeah. State has to completely be tight. And then when you're done, like you get back the messages.
How is that? Isn't the structure dynamic?
Oh, sorry, and the serialized message case, or well, it is dynamic in the sense that if it's not sized, like if I have a binary tree and it's the first binary unbalanced tree, you don't know how big it is, you don't know how deep the branches are.
I don't think but you've done lots of Rust.
Medium amount of Rust. Like the team I formed at NetApp used Rust for the first 3 years. I had a lot of employees and students who did Rust. I used Rust. I was his picture.
So you want to have
Okay. Now, can he try the camera?
Size sounds like present or absent.
Yeah, he should. We can also, if he wants to control the slides, we can do that. We can give him. Okay.
Easier.
Can you tell him to ask or say something? To see if.
Hello, is it working?
Hello. Okay, it works.
I didn't hear it. I didn't hear him.
Can you hear me?
Yeah, it's just a really.
Yeah, it works. Okay, it works. It works. Perfect. So I will give him. I think I can give him presenter when the time comes. I give him presenter role or something like that, and then he can control the slides. But if he cannot, then you can do it. Okay? Yeah. Just in case.
Okay, that's great. So wait for the slide here.
Okay, I just downloaded them. Check if they are please check if they are the correct one. I just downloaded, but just in case. Yeah. Yeah, me too.
Good.
It's good? Okay,
Okay,
so then
yes.
we upload it. We upload it, so it's ready. Upload. Presentation, the one. Upload. And it converts. Let's
Oh,
see
it
if
converts,
works. Yeah,
okay.
yeah. Well, if it is PDF, they don't. If it is PDF, they don't. So that's good. Because sometimes the conversion could be. Let's see if it works. You see, preparing pages. It's processing. I don't know exactly what it does, but it processes somehow the pages.
I have 40 pages,
Yeah.
but most of them are quite short. So
Yeah.
hopefully.
No worries. No worries. You have 20 minutes. I can. Do you want warnings? Warning time, or you control the time, or what do you prefer?
Yeah, the warning would be great.
Okay. What 5? And there is 5 left.
5 left.
Or
yes, 5
5,
minutes.
for example. Okay.
I will try.
Okay. So it works. Okay. Let me. I'm going to upload the other ones so we have them. We'll upload all of them. Yes. After you, it goes Rahul.
Rahul, yeah.
Okay, upload.
Hard-earned money.
Do you happen to know where Jonathan is?
Corbett?
Yes.
No. If there is not, if there is kernel summit today, I don't think there is kernel summit today. So I don't know. If there is a kernel summit, he is in the kernel summit for sure. But otherwise,
Wanted to talk to him about documentation, so we can get the chance at this talk.
what about, what do you have any?
I just
Because that is so interesting for me. That
more documentation on the C side in the code.
On the C side?
Yes.
In the code?
Yes. Putting more docs in the C side in the code.
Yeah, I mean, the thing is, it's hard to enforce. I mean, he wants that, but it's hard to get people to do it.
Create a warning.
So, hello, come again. Why remove was unsafe? You said the race condition?
Yeah, that's the race condition. Because you have the list links.
The link is sync.
So, well, so you put it like you have this list links, right? And if you're in a list, they can change at any moment because the list could be like from another thread and be writing to it.
So yeah, that's the question. It's just for the sync.
I think we have made it sync, yes. I think that's why it crashed. Because otherwise it's not really useful, right?
All right.
We are not. I guess we can call it full house.
Yeah, people is getting. It's usually it happens that people is getting talking outside with the coffee, so we can wait a couple of minutes if you want.
Oh,
if
yeah.
You see, otherwise we can.
Or can I just can get?
You want me to say something in particular, or whatever I have to present you, or you want me
Oh
to
yeah.
say?
So Miguel, you know me. So feel free to. Yeah.
So we are starting again. We moved, as I said, Xiang to now because Daniel had his talk in the referee track, so we use that time for Xiang. Again, thank you to the sponsors of the conference. Otherwise, we wouldn't be here. As I said before, we will do the remote attendees should put the camera on, and please keep it discussion based. If you want to ask questions, please do. Unless they say don't, please by default do, and feel free to ask, because that's the idea. If the presenter goes through all the slides, then this is a failure. Okay, so so please interrupt and please have a discussion. Okay, and now let's switch now we can switch the slides. Now that the sponsors are happy. So yours was presentation. This one.
Yes.
So Xian has been working on the Rust language features, now also working on a bit of kernel as well. He wanted to get into. Xian is taking care of some of the hard problems with upstream Rust that we have in different areas, actually. So yeah, thank you. Xian, please go ahead.
Thank you very much. So I'm Xiang. Or you can call me by Ding, whichever you feel comfortable. And let's talk about some Rust language changes that we've been looking at over the past year. And well, there are two things I would like to cover. It's a mini update on arbitrary self-type, but also, as promised by Benno, let's talk a little bit more into in-place initialization, and that is where I think the fun can begin, and we should get some discussion. Now, so before talking about arbitrary self-type, I think I need to loop you all in about what this is actually about. Like, what is the business, the whole business about the self-type? And as a motivational example, let's look at a typical C function that operates on an object. Let's call it just context. And you give it some input, you call it method. That is ABC, even let's call it A of the of writing any functional C code. And we have a equally competent, let's say, language construct in Rust. We can just do the same, like here. Why not? It just works. But we can do a lot better if we kind of introduce some structure and organization to a code
because the method is actually only applicable to the type context and not just any other type over there. And you are actually allowed to write a method that is strongly associated with a type context. And that would also allow you to call it like in that is in a style that is inspired by C++ or even earlier Smalltalk and stuff, with a dot method syntax. And what is message passing style really here? Is that in C you can only write the method within some kind of scope, and it doesn't declare any association with any type. But language like C++ and Java and others allows you to employ this message passing style to associate methods, or let's say annotate a section of program that is applicable to a type. And the type here is also called the agent or the object in various literature or language specification. In Rust, it is called receiver. And it takes up a particular, let's say, a bit magical variable name just called self. And that is the message passing style, basically. Now, things get a lot interesting when we start to throw things at it. In C, this is a really common pattern where you have a reference counting object, and the only meaningful way to do that is to introduce a kind of invasive reference counting. You embed a reference counter inside your type everywhere. And for that to work, you have to usually have this ref count bound bump function that you call before you wanted to duplicate the reference count. You will have to manage this reference counting manually, make sure that you call it at the right place. And for Rust, we wanted to do the same. Eventually, at some point, since about 2017, that, okay, I don't want to just receive some value of context, but I need to make sure that I can reference count it. But before 2017, we can't do that as a receiving object, like a receiver value. So we just make it happen. Okay, now it would just work. As a self, we say self is a reference counting of a context, and then we just do our clone. That has been perfect for a while until we have a second issue. Hello, Ping, my good old friend. So we wanted to further specify let's say a restriction on the value that we receive, so that the pointer usually the pointer or the mutable borrow is guaranteed to be pinned inside by its memory address. We wanted to make that as kind of a valid method receiver, because there are sections of program that you really want that guarantee, the pinness guarantee throughout this section of function. So we just make it happen magically without saying that whether we want to do anything else until we have our third issue. Now we are interested in introducing generic smart pointers. Pointers that are really interesting. There are use cases, for example, C++ interoperability to annotate a pointer that is coming from of origins of C++ construction, or let's say with other language sources, for example, Python or whatnot.
Or in the kernel, aref for generally reference counted stuff.
Yes, yes. These are very important stuff is that all these smart pointers, they have let's say interesting sets of guarantees and various interesting let's say interpretation or safety guarantees. And now we kind of, for Rust language, we kind of need to generalize over. And it doesn't only apply to pin, but all these smart pointers as well. So we kind of think about it, okay, so we need to figure out a new kind of message passing style now, that because the receiver of the receiver type of the, let's say, the magic variable self does not have to agree with the let's say the object, or let's say concept of the concept of this typing, or that you're associating this section of program with a method to in some form, or let's say on the surface. Now you just now not only you can specify ampersand mute or bar mute or ping, you can do any pointer. Now that's what we call it. That's why I would call it. Now we're entering a new kind of style of message passing with some Rust characteristics. And before entering our actual problem, let me explain a little bit of another language intrinsics. Well, let's call it dereferencing. It is a this concept is about indirection and a generalized like a dereference of a pointer. In Rust, we can have types that works like a delegate for another type, that saying that by doing dereference, I can point you to a different value. And for that, you can descend into the actual value you are interested in. So, for instance, you can do a double borrow of context. So it's a pointer to context, and you can still call methods to it, which will get dispatched to a method that's kind of associated with the type context here, the same method that I have been showing earlier. And the magic is that we automatically throw in a dereference, like to remove the outmost pointer out there, and things will just continue to work. That same concept applies to box. And box, for that, because it implements deref and deref mute for the type within, when you make a method call, like x.method, it's not calling a method that is associated with box. It's rarely useful. But what happens here really is that through some mechanism, it figured out that exactly one dereference needs to be performed, and therefore a star is inserted for you automatically. And in the later stage of the compilation, that star is reinterpreted as a call onto the trait method deref that is declared in the deref trait, which is kind of to refresh your memory. It's kind of defined in this way. So it's kind of, let's say, intuitive. So target is the type that this pointer is really delegating for. Now the problem here comes is that pin is kind of out of place. In the current implementation in the Rust standard library, for pin to derive as a to derive derived trait, when you do a dereferencing of the pin type, it has two quirks. One is that it actually bypasses the pointer that is within the pin guarantee. It goes straight into the target. Right? It doesn't really because we have this pin guarantee. We don't want you to hold a pointer to the things that you make sure that you have that then you say that you have this type here, but rather it's the thing that you're referencing to, which is inside here. And for that reason, the deref implementation for ping only works when the pointer has a deref. The second is that the receiver trait that I said to describe the association of methods with the context type has only works for types that implements deref for some reason up to this year, which makes it kind of quirky, which I call it the bane of a strong deref and receiver coupling. I lost my slides. Yeah, so because okay, 5 minutes, that's good. Okay, so for that reason, so if you think hard about it, the ping of let's say this opaque pointer that that wraps around a pointer that you don't want to deref into because it is probably coming from C++. You just don't want anyone to peek into this value of context out in there. You want to use it. You want to continue to hold it as if it's a receiver, but it doesn't work anymore because now in order for it to become a valid receiver, you need to have a deref, but you don't want it to happen anyway. So we kind of hitting this problem of strong coupling here. So we have the first question that we kind of encounter is that do we really want for a type to work like a receiver value as soon as you have a tderef? And prior to that, we kind of running thinking about, yes, we have a lot of suspicious cases where we actually don't want to have it. What does it mean for a for a method to receive a value of peak mute of some type T? It seems kind of superfluous, but also there are cases where there are kind of values, but they are very specific to use cases, like, for example, X array. We talked earlier about whether we could make use of making lock guards as a receiver to annotate that we can do something about lock guards temporarily unlocking it and doing it, but it's a use that is very niche. But hardly you can argue to say that, oh, I want to have this across the entire ecosystem. I want all log guards to be able to work like method receivers. People have been telling me that it feels like it's inviting for people to write weird code. Let's say something that it would be really hard to reason about. Oh, I skipped two. And second question is that we have been talking really hard about is that is having receiver target equals to a deref target really reasonable? Do we really want to have that? It seems that we probably will have quite a few missed opportunities or being too restrictive on the possible codes that we can write with this restriction in place. So my thoughts were that is that maybe we need to rethink about what the message passing style is really about for Rust. Is that we need to separate the concept between the receiver that we get, which expresses the contracts and access to the capability, all this concept embedded into the value. For example, ping says it is a ping guarantee, and the value that is inside is what you associate this method with and things that you want to work with. And the message where it annotates the section of program where the access is actually being granted for this period of time. And I figure out the table that kind of makes sense, saying that for a borrow self or a borrow mute self, it's talking about access to value that has some access control. Ping has ping guarantee. For ping of opaque of context, it's not to say that you really have access into context, but rather it says about the ping guarantee and interoperability. It doesn't say anything that you really want to have some direct or some access into it, into the context. But rather the opaque of context where you pass this opaque pointer around. And finally, reference counting. Okay, so I think maybe I'm thinking right now is that we probably want to put some unstable feature gate on this new message processing style. I think arbitrary self-type is kind of great at the moment. We can just ship the rest of it on the stable flag. And we will continue on experimenting with this new message passing style concept for, let's say, to discover useful, let's say, use cases out there. And we are looking forward to feedback from you, and especially use cases where you find very interesting and impactful, with the second point where receiver target is not equal to direct target. So that is what I have for arbitrary self-type. But I wanted to also quickly talk about in-place initialization. So we are cooking about 3 proposals, like C++ inspired guaranteed value in placement. When you call a function, the values are automatically constructed in place because with some ABI magic, we're passing an out pointer to the function. But on the service language level, you wouldn't even notice it. So if the optimization applies, it should just work. But it's only a guarantee. We know that. That's why we have ping init crate here. So there are, for the under the category of explicit emplacement, we have a placing function as well as ping init. But let's move it into a standard library. Sounds like a good idea. Now, disclaimer: the fourth proposal that we are going to talk about is not something.
Yeah.
Set, but
Dean is working on a lot of stuff, as you can see, and he wants to talk about it. But yeah, let's try to give to the schedule. So yeah, any question? Any quick question? One question we can take very quick. Otherwise. I'm sorry, Dean, for interrupting this. Okay, so let's move. Thank you, Dean.
Oh.
I assume I'm next.
What was it? Can you finish here?
Oh yeah.
Which one is it?
It's
Name of the file?
LPC, the long one. Yeah.
Okay. Well, you want to say something particular? Or?
Yeah, I could. Oh,
you want me to say something, or you want to present yourself?
Whatever you prefer.
You're at NVIDIA now, right?
I am, but this work isn't part of NVIDIA.
Oh, okay. Okay. Well, Rahul, I met Rahul when he joined Cangrejos. He was working on some abstractions and some driver work that he was really doing very well, with a very nice presentation in Cangrejos. And yeah, today I think you are going to talk about it a bit more. And yeah, he works at NVIDIA, but it's not part of the NVIDIA work, this talk.
So I've always had a passion for personal computing, and I always liked the Linux kernel, and I'm a huge Rust language fan. So I want to take on this challenge just for the sake of kind of having fun and enjoying Rust for Linux. This talk is not about the work I'm doing, but more about the challenges I faced while doing it. So I'm going to skip through a couple of slides since we're tight on time, because they're more about the work I'm doing upstream and less about the language and Rust for Linux. And I kind of want to focus on those challenges. So just really quick background. So I have a couple of patches that are upstream. I haven't iterated on them recently. The state they're in right now, they work on a specific mouse device. Without that driver, if you try using the buttons on the mouse, you will not get any input response. And that's due to a bug in the design of the hardware. And the goal of the driver is just to simply override that behavior. We'll delve more into that later, but it's very simple. And truthfully, aside from an experiment for Rust for Linux, drivers like those should be implemented with HID BPF. So if you're looking at something like that, I highly encourage you to look at HID BPF. What I'm doing out of tree, so now I really want to take those patches and I want to go further. The patches I sent upstream, they're very small, but there's some discussions with the HID maintainers, so we haven't merged those in yet. So on out of tree, what I'm doing is I'm enabling a bunch of controls for Razorblade hardware. So if you're a Linux Razorblade laptop user, this might be exciting, and I'm happy to get dog fooders, so feel free to reach out. My original work and why I was motivated, I want to actually control monitors that use USB-C externally, and I linked my Cangrejos talk. But there was a lot of concerns about the current state of GCC RS and the maturity of the tooling to make a really large, substantial core subsystem feature. So I'm diverting away from that. And so that's why I'm working on reverse engineering Razorblades and improving support there, since that's a standalone HID driver. Really quick background, since we'll need this for the examples. So HID is a really high-level protocol. It's mostly about parsing and representing hardware that's involved with human interactions at a really high level. There's input, there's output for maybe driving haptic motors and things like that on game controllers, and there's a feature set report for what a device is capable of. Thanks to HID, we don't have to worry about the complexities of USB, Bluetooth, I2C, SPI. It allows us to really work with complex hardware in a really common and simplified instruction set. So this text is a little bit small, but the key point is, it's a clean representation. It has a nice layout of the data, and this is common across a wide set of devices. And so this is really helpful because we don't have to know about the really low-level details about how a specific keyboard, a specific backlight, a specific mouse, a specific game controller is implemented. But now let's delve into kind of the Rust for Linux work and what the driver development looked like and some of the challenges. So in the core C side of HID management, we have this concept called HID groups. This is not part of the HID standard. The reason we have HID groups is a bunch of devices have similar behavior. One example are multi-touch devices. So when Windows 8 introduced Metro UI, they created these multi-finger, multi-touch devices and had a bunch of manufacturers design new protocols around that. And they're all handled the same way and need a really specialized set of parsing. If we naively had a device table and we added all the trackpads that needed to support this, one, when manufacturers create new components or Synaptic or someone else creates a new trackpad, you'll have a broken experience on Linux. But to solve that, we try to parse a feature set on the device and dynamically guess if it's something like a multi-touch trackpad. And so this is really important in the core HID subsystem and something we needed to take over to Rust. However, to take it into Rust, it was non-trivial. The biggest issue there was that the typing that would get converted, since they're C defines, would be 32-bit unsigned integers. So all these HID groups would come into Rust via bindgen as 32-bit unsigned ints, and all the APIs would consume them as U16. And that's kind of a major problem because then we have to have manual work taking every binded define and then mapping them to a equivalent Rust type that's the correct type representation. So I take all the bindgen dynamic defines for U32, convert them to U16, and then wrap them in a Rust enum. And so it's pretty tedious. One of the advantages is, it forces me to document all the fields, and that's kind of good. But it would be incredible if bindgen would take a look at an integer constant expression, since it's well known what the value would be, and find the smallest representative type. And the advantage to that would be you can grow the bit.
I don't think we can do that because if there is many zeros and ones around in defines, then that could be a U8 or a I8, right? Because at least it would need to know the smallest across a group at the very least, right?
Right. So I was thinking about that. And maybe another feature is, so we have a header file where we include all the C headers for bindgen to then do generation. If we can have some kind of comment annotation or something where we can say, for this pattern of define, we want to then map it to a certain type, that would be incredible.
What about having the suffix in the C header, in the define?
So my concern with that, instead of having it in the layer where we do the include, is I'm worried if some maintainers will get annoyed by sprinkling annotations.
It could be, but that's the solution I would immediately think of. The thing is, I don't know if, because bindgen has, I don't remember exactly, but there is some issues with the integer expressions there and whether it maps correctly. But if bindgen would do those well, I would just, my suggestion is that we use that proper type in the C side as well.
So that is the issue. I think bindgen is kind of very naive about integer constant expressions.
There are some bugs there. There are some bugs, but I think they should be solved. And I saw a PR recently that solves part of it. I don't know. I don't remember all the details. There were several bugs. One, I think I feel myself, and then other ones. But we should get that fixed, and then we could just use the suffix in the C side, and then both sides would have the right type, right?
I see.
Sorry. So
it was your PR, right? It was your PR.
It's getting reviewed.
Yeah.
We're going to get very precise C types.
Yeah, let me follow up on that because that would be incredible. Having more precise C types would, make this work less tedious, and we'll see more examples where I run into issues, and that would really help out, especially for this next example. Okay, yeah. So this next example is dealing with something that's part of the HID spec. So this is HID items. And by the spec, they should all be 8-bit wide. But bindgen, today at least naively treats them as U32, and this is really burning me. The nice benefit, though, I will admit, for all the tedium, is that Rust doc comments are terrific. The problem is we have all of this in C, and we don't document it at all. And so a lot of people who come into HID have no idea what these mean. And so I will admit, for the tedium, the enforcement of commenting is very helpful, but it would be nice to not have to manually use as here and know, it's safe to represent as a U8. So the work there would be tremendous.
Another possibility is using enums. In some C cases, we replace the defines with an enum. And then if we were able to use enum class, like in the C side, then we could maybe specify the underlying type of all of those.
So I think in the specific reason why they don't do this here, HID main items can be bitwise or together, and they can be combined. And so I think the problem with enums is a lot of kernel developers are adverse of doing those kind of bitwise combination operations on enum values.
Yeah, you can't do that on an enum.
In C, it just defines identifier. It's just you get just the thing. So the enum is just defining the values, and you can combine.
I just don't think it's very conventional, even with.
Yeah, but we did I think in binder we replace a bunch of defines with an enum, for example.
Is that the case? So for binder, we're
so in binder we have some cases where so it doesn't become an enum, but I think I just turn it into. For example, in some cases, I just turn it into Rust constants that they have the right type, and then there's a cast.
No, but for binder, we had a case where I not in binder, but in one of the headers that we needed for I think it was for.
Oh binder. Yeah, so in binder we had a problem where the defines weren't working out. So what we did was that we actually used an enum on the C side. So we translated the C header to use an enum instead of
a bunch of defines.
But that
works much better.
We did it for another reason. We did it because there are some defines that bindgen will not understand. It will not resolve to the constant, right? But if it is an enum, then the C compiler will tell bindgen what it is, so it resolves. So we did it, I think, for that reason. Not for...
So in general, I think it's reasonable to convert the C headers to use an enum instead of a bunch of defines for these kind of cases.
But my follow-up question to you in that enum, I'm assuming each value was used independently and they were never grouped together. You wouldn't take two of those enum values and
you can.
You can.
Yeah, it's so maybe not conventional.
Translate it to a Rust enum in that case, but you can still use the enum and the C side. That's fine. We were actually working on doing this for the MM flags.
Yeah.
And are the MM maintainers okay with that direction? I guess.
Yeah, they're doing it themselves. I'm not even having.
Okay. The problem with the enum is that the underlying type.
The what?
The underlying type of the enum. You know, it's in
Like
in
the
C,
underlying backing type, like
Yes.
integer.
Yeah, I don't think you can choose it
Exactly.
on the C side.
Yes.
So you
we
might
will
not-
we will be able in the future in C to do it. I think in the standard. In C++ you can do it, but we don't have it right now. I look into it and I think we couldn't just do it right now, which is a problem. So Gary, please go ahead. Yeah, C23. Yes, exactly, Gary. So it's interesting. That's what I was saying. Yeah. So if we get the C23 feature and the C compilers are bumped to the minimum that they support that, then it would be very nice because then we could get the enum class equivalent in C.
Right. Yeah. Okay. So I guess part of our dependencies, we're waiting for the kernel to be able to bump up the minimum ceiling.
Or maybe we get a bindgen feature to annotate something, or yeah, there are several ways we could try to improve that. Yeah.
Okay. Yeah. So the next part was creating a USB HID device ID. So this is declaring a device to be proed by the driver. So one of the requirements is I want to build this device ID table at compile time. So this is a const function, just to keep that in mind. So by const function, I mean, if you're familiar with C++, it's like const expr. It's evaluated at compile time. And so one of the big things here that I want to do was, since I have this Rust group enum, and since I'm feeding it to a C API, I want to be able to convert from HID group to a U16. And so I want to implement the from trait. And I think for folks familiar with Rust, typically you would implement the from trait to do that type of type conversion. Onto my next slide, you'll see that I actually could not use the from trait. And that's because if I use the from trait, it will not implement an into implementation that's const or compile time evaluated. And so I basically have a hacky interface where I fake, I have an into method and I say it's const. And what I do is I take the underlying value of the Rust enum and cast as a U16 so I can pass into the C interface. And so that's kind of unfortunate. And my hope or wait is for the const trait implementation proposal that's going on to make headway, and that would make this significantly cleaner. I can implement the from trait and then do this in a const context.
5 minutes, and we have a question on the chat.
Okay.
Are there Thomas, you if you want, you can put the camera on and do it yourself. Otherwise, I will read your question. Are there any plans or interest for a follow-up chat about kernel error or stack trace collection and analysis that Gavin Guo and Guilherme G. Piccoli mentioned yesterday? I don't see them here, unfortunately. We have been exploring this space quite a bit at Google in Chrome OS and Android, and I would be happy to share our experience too and brainstorm some ideas.
I suspect that's not related to this talk, this question, right?
Well, it just came right now, so yeah, I'm not sure. Thomas, maybe you were in a different. You were meant to send the. Okay, maybe Thomas can clarify the question later.
Right. Since we're running out of time, I think I'm going to speed through or continue through.
So I have an opinion about this into function.
Right.
So my opinion is rename it to something else, like into raw, and then it's not a hack.
I was actually going to bring that up later, as I was going to not name it into, because this is exactly the issue. And then I can implement the from trait for other contexts where I would want to use it. So right now, this actually blocks me. Like if I implement the from trait now, I'll end up in a collision because of this into implementation.
So I think the answer is simply, it's not a hack to have a function for doing a conversion. Just don't call it into.
Okay, yeah, I agree with that. So I will definitely revise that in my future patch set. But I also want to discuss the other direction, which was also a pain point that was biting me, which was converting from a U16 back to this Rust type. So the biggest reason why, implementation-wise, it looks simple, right? Here's my C type. this is the group field from the equivalent C structure. So this is a field of a C struct, and I use into because it's a U16 to convert it. So this should be simple, right? But then if you go to my next slide, well, honestly, this from implementation, we'll talk through it, but it has a couple of concerning aspects. First, I have a U16 value. This isn't a huge issue, but it is kind of quirky, is I have to use value into, so basically the from trait to go from a U16 to a U32 because bindgen set all these as U32s. And then I go from the equivalent C value, that's a U32, to my Rust enum type. And then because it's a integer value, I need a wildcard handling.
Yeah.
The reason why this is a bit painful is in C, and I think previous talks have talked about this, you could treat this as undefined behavior. In Rust, you have to explicitly handle this. And this looks fine till someone changes something on the C side where they add a new HID group. And that could be really problematic because let's say if Windows 12 comes out and they decide to implement some new multi-touch device and they added handling for that.
Okay, I think Alice wants to say maybe the same thing I would. So, well, first, if the any is not possible, right? Then we should not return that, right? We should either maybe return a result or do something else, right? Or
right, my later slides expand on that.
And then what I was going to say is bindgen. So we have an issue. I open. So the way that bindgen treats enums, right? If it is an enum on the C side, what I requested bindgen is, can we have a way to convert safely to a Rust enum, right? And it's implemented. I don't remember if it is merged, but the idea is that we get automatically, given a C enum, we get automatically a Rust type, okay, that gives us several operations to get from and to the value, okay, in different ways, fallible, panicking, and with unchecked, so undefined behavior, right?
So I have a couple of follow-up implementations. My first,
Okay, so for one, so there's some patches on the list to create a derive macro that provides a function that does the match for you.
Oh, okay. So that
and as a follow-up, so there's we can break the build if somebody adds a thing without adding it in Rust 2. So the easiest way to do it is to add a extra thing in. So for step 1, you use an enum instead of a define.
Okay.
Step 2, you added like a thing at the end called the HID group count or whatever.
Okay, sure.
And then on the Rust side, you can ensure that Rust has the same number of entries as the C side has, and break the build if that's not the case.
Okay.
Yeah, while we were waiting for the bindgen thing, we implemented. I don't know actually who it was, or maybe.
I actually think using a macro.
Yeah,
is probably better than doing it in bindgen.
No, because we want to generate that code, all that code, for automatically. We don't want to call.
Yeah, we want a macro to do it, right?
But I don't want to do it manually and have to call for every single thing. I want to have it already as a type. And we discussed this.
I think it has to be opt-in per enum then.
Could be, but I want to mark them on the C side. I don't want to have to.
Yeah,
in fact, it doesn't really need to be opt-in because we could do it. It's just that you don't use it, right? If you don't need it. It's optional. You can use it or not. It's just that you pay, I guess, the cost of that you generate more code.
And then there would be a way to skip if there is a count, because then we don't want a count.
Yeah, we had the patches. I don't know if it's the ones you are talking about.
This is a derived macro, not a bindgen thing.
Because I thought, didn't I have, it was years ago, I had this, we had a hack to check to avoid this issue. But I need to talk to me your life, because I remember we had a hack we used 2 calls, I think. We did something that, we generated a function call, a function signature, to check that it was a substantive or not a substantive, but I don't remember the details. I can give to you the details.
So I think there's a comment over there, but I want to say something afterwards.
Oh yeah.
Okay.
And we have to move on. So quick last.
So do I understand that if we were defining proper enum on the C side, all these problems would go away?
If you define the enum on the C side, it depends. It depends. Not automatically. We have to do some things so that. But it helps. Okay. It helps because then you have like an enum. The identifiers are entities in the C compiler, while the defines are macros. So the compiler is not.
I think you should just talk to Yuri or Benjamin and ask to convert it to enum when it makes sense. Because
Okay.
I think it's the most sensible way of dealing with it. And if they have some objections for one reason or another, then you can build all these complications.
Okay, that's great. Yeah, thank you. Alice, very quickly, and we have to
Yeah, of course,
we have to
no
move.
worries. I might have to follow up with you guys at the office.
Yeah, please do. Yeah. Is it
Well, so it's mostly if you want to talk about the builder.
Yeah.
Yeah, but then we open a whole. Okay, we'll go ahead. But
so I think that one's problematic because the build error depends on the runtime value, and I think that's a problem.
Yeah, and that's actually like my next slide is exactly on that topic. We should talk about this in the office.
Let's talk about it offline.
Yeah.
Well, it depends if the builder or if the compiler knows or not, right? It depends
Well,
if
that
you need.
case, it's a runtime value, right?
No, but it depends if the caller has the.
Yeah,
it
so the
depends on the
problem is
case.
this is used in runtime though, so it does panic. And
Okay, but what I mean is that if for example your callers were all supposed to be using constants, then it will be fine.
Right,
Then you
that's
shouldn't
what I
go
wanted
through
to discuss. Yeah.
But yeah. Okay, so thank you, Rahul. Yeah, let's. So yeah, please, Vitaly. Yeah, Vitaly is also joined Cangrejos and is working on several Rust use cases, right? So yeah, please go ahead, Vitaly.
Yeah, all right. Thanks for having me here. This is going to be basically just a description of the problem that I have. It's not a stopping problem, but it's like a performance problem. Because there's a certain implementation which is yet out of tree, but we're working on getting it in. So it's an allocator backend for ZSwap, basically. It's called ZBlock. I was talking a bit about it yesterday on the kernel track, and the idea is that each block is divided into slots of equal size, which are occupied and freed by small objects, which are essentially compressed pages. So these blocks, they can be empty, partially empty, or full. And we're only interested in, and we maintain a list of these blocks, and we're only interested in the blocks that are partially empty, because empty blocks we will actually want to free, and full blocks we actually have no use for. So then we have a very simple state machine. So if we have a partially empty block which becomes empty, we remove it from the list and free. If it becomes full, then we just remove it from the list and wait until there's a free slot in the full block, so then it becomes partially empty, and then it put back into the list. Oops, I think that's probably the old version. Sorry about that. Yeah, well, never mind. We'll get to it. So, sorry about that. So from the perspective of the operations on the slots, the operations on list are rare. Okay, so we can think of it of a read mostly operation for the list, and with that said, there is a C implementation of that algorithm, or actually two implementations, with and without the RCU. And here we have an excerpt of the implementation that uses the RCU. I'm not sure if it's very visible, but I hope it gives the idea. So what we do is that we take the first entry in the list, which is representing a block. And well, if the list is empty, well, life is life. If it's not empty, and it's a stale object in the list, meaning that there are no free slots, then we just try again. And if it's actually not stale, then we know that we can use it to put the allocation object in it. Yes, please.
So what do you need a B lock for?
Spin lock. For list RCU, we need to protect against calling list add RCU and list.
Is the B lock protecting L or not?
It's protecting the list with regard of list by their del RCU and list add RCU, which is not in this listing.
My question is that can you having two of this function called with the same L but different B?
I'm not sure I'm following. Sorry.
So this is function, right? Is there be possible situation where you call this function with the L, the RCU list being the same, but the B being different? Do you understand the question?
No. Not really. I need to understand. I couldn't put this the whole function here, but that's not the problem.
So means that L and B has some relationship to. Is that true? B and L, the list. Yes.
Yeah. So there is a relation. B is the block.
So the list belong to the block. Is that true?
No. The list is composed of the blocks.
So I'm sure I follow.
But
because that's important. Otherwise, the code has.
If I may, I think we're going a little bit in the wrong direction here, and that's probably my fault because this is not.
No. Understanding your use case is the right direction. I'm pretty sure.
What I'm trying to say is, well, there is this C code. It's maybe not very nice, but it works, and we have tests showing that it's working faster than the one that is using spin lock.
Bug code actually run fast. Bug code actually run fast. Faster. So we need to make sure that your code here is correct. I'm trying to do that. Okay, not saying that code has actually bug. Maybe I'm missing something, but I need to understand that.
I think what Bottini is saying is that if the code is not correct, then we cannot compare.
Yeah, we cannot. We don't have a like. So I want to understand that the relationship between the list and the block. Can you maybe describe that? So is that for each list, it only belongs to one block or no? Oh, you said that the list has multiple blocks. By block, I mean the B. Is that a block?
Yes.
Okay. Is that for each list there is one block?
No.
Okay.
So we have a list. We have a list of blocks.
Yes, you have a list of blocks. So you have multiple blocks belong to the same list.
Well, I'm sorry. This thing does work. So I'm sorry for.
Maybe what we can do is take it.
This is not
Maybe we can take it offline.
This is not my laptop, and I can show the whole code right now, but I believe it is working.
As far as I understand, so the list is a list of chunks, and each chunk has multiple slots where you can put a single block, right?
Yeah, that's right.
Right. So this block, we're trying to insert it into an unused slot in one of the things in the list.
Can there be two different blocks using the same list?
Yeah. So it's the list of chunks of blocks, essentially.
It's the list of chunks of blocks.
Yes, and the list contains the chunks where there are unused slots where you can put in a block.
Yes, but there could be the same list but different B.
Yeah.
Then this code is broken. Because operating on the same list, but they use different logs, right? Different B. You log.
So you mean there's a race on 3 slots?
There's a race on deletion on the deletion RCU. You delete the lot. When you delete something from RCU, you have to make sure that you are not you exclude with other deletion.
Maybe it's
yeah, but this block. I mean, blocks are divided into groups, and a certain block can only go into a certain list.
Okay, that's maybe something missing.
Yeah, but then again, it's because it's not the full listing. So I'm not sure. Maybe it was a bad idea from the beginning to get this code here because it's incomplete. But there's a certain relation between a block and oops, a block and a list. So a block cannot go into 2 different lists. If it's the same block, it cannot go into different lists. There's always a list that we select for a block basing on its size, basically.
And don't worry, don't apologize. It's completely fine. I mean, the fact that we got the discussion is good. So don't.
Yeah. But I mean, I'd like to go to the problem, and the problem is that we want to have that kind of thing in Rust, but we don't. Oops, once again, we don't really have the implementation we could use in this particular case directly, or anyway, maybe I don't quite understand how to do that in Rust, and this is actually what I need some help with from the community, from you guys. So the implementation, it's not like there's no implementation of RCU, but it's very basic, and there also was a very good talk on Cangrejos about extending the existing RCU implementation for Rust. But the problem is that even with those extensions, it's not quite clear what we should do exactly in this Z-block case, because it's list RCU that we're using. Yes.
What do you actually need from RCU?
Yeah, that's on the next slide. The first awkward attempt I made was to just mirror the RCU lists in a quick and dirty way in Rust, and that is a working prototype solution, I would say, but it's really ugly, and safety also goes sideways. So yeah, what can we do next? Try to implement the RCU list in Rust. But if we do it if we want to do it in a generic way, well, I tried it, I failed. So there are variants how to do that. But if you try to do it like full featured, then it really becomes problematic. So I sort of gave up midway.
Well, which C APIs do you need?
Okay. Yeah. So the thing is, we actually used the list in this implementation. We used the RCU list in a very simplistic way. So we don't really need to walk through the list, because we always take the first element, for instance. So we need to basically have first a null, add RCU, del RCU, and well the mutual exclusion, and then deferred free, which is a problem But otherwise it looks like we may get away with the list RCU type, or I don't know, handicapped list RCU, because we will not implement the whole thing just using atomic pointers.
So already read out slide. I just want to confirm. So the list you are using actually kind of own the object, right?
Yeah.
So it only exists in that list, doesn't exist in any other list. Cannot be referenced unless by inner RCU character section, right? Is that correct?
Right. For the lifetime of the object, it can only belong to a certain list.
Okay. And then I think this might work because this is a simple one. Sorry, go ahead.
Yeah. But then again, this is basically what I'm thinking of. Like I'm thinking of a simplistic implementation, which maybe I don't know, which we may not want to call a list as such, but this particular thing seems to be able to make it. Unless I'm missing something, which is also possible. But then the deferred free becomes a problem, because in the C variant we use KV free RCU, and there is no analog for this in Rust, and I'm not sure how to do that in Rust.
For that to do in Rust, you probably need to make the bound to T to something like has RCU head, which you have to implement the trait which describe this struct has RCU head in it. And then you can basically call the K for RCU. Oh, K for RCU. Wait. No, you don't need to do that. Well, you can. It depends. So, but either way, you probably need some extra trait bound. This is list RCU not for all the T, but for several T, that the T has to have a head in RCU head in it, and then you should be able to do that.
How do we encapsulate structure RCU into whatever we have in Rust?
You mean RCU head?
Or otherwise, we need to have like a struct RCU in our structure to be able to call call RCU or KV free RCU.
Right. So you have to implement your type, which has a RCU struct RCU, or actually it's RCU head, into your struct. And for this thing to be work, because this thing is generic, right? So it has to describe that in a way that it has a trait. T also has a trait bound by has RCU head. And then if you can look into like work queue and timer, you'll find the normal way we get from if this type has this field, then we can get pointer to that field. And then you can able to pass that to K for RCU.
Right. Okay. Yeah, that's a very good point. And KV3 RCU as such, we just I guess it's not very nice to just call it directly via bindings, but on the other hand, it doesn't fit that well into the memory allocation traits that we have currently.
Right. I think we need to call that directly. Call KV directly.
Okay, let me stop you there before. So thank you, Vitaly.
That's it.
Oh, okay. So thank you, Vitaly, for the presentation.
Thank you.
I'm really sorry to interrupt a nice discussion. So, but yeah, we're at time. Thank you. And now we have a remote presentation. Let's see if we can set it up properly and it works. Our last presenter is remote. Let's see. So,
right. And actually, how do I control it?
let me give you 1 second. Now you should be able to control it, I think.
Yep.
Yeah. Can you? Okay. So, but please take the stage yourself as well, just in case things. Yeah. So, Xinhao, sorry if I mispronounce your name. Xinhao will present. He was a PhD student, if I understood correctly, and he's going to present a Rex, which is a Rust-based kernel extension project. Yeah, please take it away.
Yeah, and thank you for the introduction. So yeah, I'm Jing Hao, and today I'm going to show you how we can design a safe and usable kernel extension framework, basically in Rust. And yeah, let's get started. So a bit about the team. So I was a PhD student at UIUC working on safe kernel extensions, and there are many other people who are on the project, including Rowan from Red Hat, who is also in person right at the podium. And then there are people from Rosa Lab from Virginia Tech, led by Professor Dan Williams, XLab at UIUC, led by Professor Ting Xu, and also people from IBM Research. So yeah, in recent years, BPF as a form of safe kernel extensions has become particularly popular and seen in a lot of use cases. So this includes the networking use cases represented by Cilium and Catron, and also the tracing use cases such as the BPF compiler collection and BPF trace. And on the right-hand side, we can see this figure from Bernard Grech, which showcases the places where people can attach BPF for tracing. So in the model of BPF, the programmers usually write their programs in a high-level language such as C or Rust, and then the program is compiled into BPF bytecode, usually via LLVM, and then it's loaded into the kernel via the BPF syscall. And at this point, as we all know, the in-kernel BPF verifier is going to execute a symbolic execution on all possible code paths and verify a set of safety properties. And if the program passes the verifier, it's accepted in the kernel and can talk to a restricted set of helper functions. And so the verifier verifies several important safety properties. Those include membrane type safety, safe resource management, runtime safety concerning program termination and stack usage, and as well as the absence of undefined behaviors. If the program does not pass the verifier, it will be rejected. But a lot of times, we actually don't know why the program is rejected. And I mean, a lot of the times, the program just looks fine. And what I'm going to tell you is that those programs are indeed correct. And you can see that we really have a problem on the usability of eBPFs. Basically, we treat usability for safety. So let's take a look at the closer example. So here, the program shown on the screen is it's the code we got from the Cilium project, which is a popular BPF networking project. And what it does is that it looks up a service from a BPF map using a key. And if it's not found in the first try, it will try to redo a wildcard lookup. But this simple code actually does not pass the verifier. When verifier rejects it, what you get is like this huge blob of verifier logs, which is like completely in BPF bytecode instructions. It's hard to figure out which source line those instructions map to. And also the error message at the end is also confusing. It says like invited BPF context access, but why is it invited? So it turns out the root cause in this case is that the verifier does not understand the compiler. And in here, the program uses BPF H2NS to convert the indness of the source port field in the context. And the source port field is defined as the 32-bit int, while the BPF H2NS function only performs operations on the upper 16 bits. So when the compiler sees this, it's being clever. It says, oh, I'm going to just optimize the code to load the upper 16 bits. But for the verifier, it checks the context access based on its size. So it's expecting a 32-bit load on the source port, but only says a 16-bit load. And therefore, the program is eventually rejected with the size mismatch error. So I guess what we argue is that the core of the problem here we're seeing is there's a gap. On the one side of the gap is your source code language, whose language contract binds the programmer as well as the compiler, and allows the compiler to employ optimizations that are allowed under the language contract. But on the other side of the gap is your BPF verifier, which performs checks on a different contract at the bytecode level. So we call this gap the language verifier gap. And a natural question, of course, is how we can close this language verifier gap and make kernel extensions more usable. I mean, if we can run kernel extensions without a verifier, and apparently this gap will be gone. But that brings us to another important question, which is like, how can we ensure safety in the absence of the verifier. And what we argue is that we can actually leverage the language part that already exists. Or in other words, we can use language-based safety together with a runtime mechanism. And we can use Rust as our safe language, where we require the extension programs to be written in safe Rust only. And then for other properties that are like hard to be captured at compile time, such as program termination and stack checks, we can implement those into a runtime. So that brings us to the real thing I want to present today, which is Rex, safe and usable Rust kernel extensions. So in the mode of Rex, we require the program to be written completely in safe Rust. And the program is then compiled by the trusted Rust compiler, and then linked with our Rex kernel crate. And this huge binary, basically binary executable, is then loaded to the kernel. And at this point, the kernel will perform some load time fix-ups to resolve the reference to kernel symbols. And after that, the program can just be attached to like BPF programs to a in-kernel hook point and interact with the same set of, the restricted set of helper functions. And during program execution, we implement a Rex runtime where we provide support for program termination as well as exception handling. So safety in Rex can basically be divided into two parts: the compile time safety offered by the Rex kernel crate, and also the runtime safety offered by our in-kernel runtime. And due to the time limit, I will just focus on safe exception handling mechanism in the Rex runtime today. So, as we all know, certain properties of Rust are actually checked at runtime, and the violation of these, for example, if you do an out-of-bound access of an array, it's going to trigger Rust panic. And in user space, for x86, Rust uses the Titanium ABI-based exception handling, where upon panic, it's going to unwind each stack frame and look for the cleanup code, or also known as landing pad, to execute all those cleanup code. But this is not really suitable for the context of safe kernel extensions, because we don't really want the stack unwinding to fail in kernel space. Otherwise, we risk kernel crashes or resource leaks. And at the same time, executing user-defined destructors is generally not safe either, because it's hard to make sure that those destructors do not trigger nested panics. So,
Sinha?
Yep.
One question, because currently in the kernel, at least in the non-BPF, we just abort. So panics are abort. We don't unwind.
Right.
So do you support? You want to support unwinding on these extensions? Do you want to support unwinding? And if so, why?
It's not really unwinding. It's more like if for example, the program makes a mistake and the extension program panics, then we don't want it to affect the kernel itself in any way.
Mm-hmm. But can you, for example, would it make sense to have like check that there is no panics at all? Like just do a no panic? Would it make sense or?
We could do that, but since we do this project for usability, and the thing I'm concerned is if we do that, we're gonna add new restrictions on and how you could program your extension program.
Okay, we have also a question from Gary, who said before, I think it was on a previous slide, how do you verify that the compiler is trusted?
Yeah, that's a really good question. So that's also one of the discussion point I want to get to. But yeah, and I'm happy to do it like at this point. So kind of one question I want to ask also to the Rust for Linux community is like, apparently to use Rust for safe kernel extension, we need to trust the compiler. But does the trust make sense though? And for me,
I also have a
Yep.
That is.
So I also have a question like related to this. Like, so is the intended what's it called idea that some random person comes with arbitrary safe Rust code and then you compile it and load it into the kernel and then that should be safe like BPF? Is that the idea?
So the trust, I think the threat model is a bit more restricted than what you described. So essentially, what we kind of followed what BPF did in on the threat model. Right now, BPF it's kind of using a non-adversarial model, which means it's trusted user loading code into the kernel, but because they're human, they could make mistakes. So we want the safety mechanism to catch those mistakes before they could crash the kernel. And the same for Rust, same for Rex. Basically, you have trusted programmers writing Rust code, and we're going to compile that and load that into the kernel.
Okay, so we're not trying to solve the I'm a malicious Rust programmer writing very, very safe Rust in quotes. We're not trying to solve that problem. Is that what you're saying?
No, we're not.
Good.
Yeah,
but please go on.
Yep, thanks. All right, so yeah, so in Rex we support exception handling basically in two components, and one is graceful exit, and the other one is like resource cleanup. So basically, we split that into two parts. And so let's first take a look at graceful exit. And so here on the screen is the dispatcher function responsible for calling into the Rex program. So the function is entirely written in assembly, and what we do is that when we enter the function, we're going to save the old stack pointer before the program invocation. And then we're going to invoke the Rex program. And if this program ever panics, the control flow is going to be transferred to the panic handler we implemented in the Rex kernel crate. And the panic handler is going to clean up all the resources, which we'll get to later. And then it's going to transfer the control flow again into a kernel landing pad function we implemented, and that's implemented in C. The reason for this function to exist is that we really want to report something to the kernel console to let the user know like something went wrong, basically. Then it's going to jump back to the Rex exit label right after the program invocation. It's basically after the call instruction. And at this point, it's gonna the dispatch function is gonna restore the old stack pointer, which will effectively reset your stack as well as your execution context to be like the same as before calling into the program. And which means at this point, the execution can just continue as if the panic never happened. And also, I should mention that the code shown here is like a simplified version. The actual version is a bit more complicated, but the idea is the same. Yep. And yeah, as I mentioned, we use the Rex kernel landing pad to report information to the kernel console. And for better user experience, we integrated the safe exception handling with the kernel stack trace, where we dump the stack trace of Rex panics to the kernel console. And to do this, what we did is that we demangled all the Rust symbols inside the program and registered them into the KL themes upon the loading of the program. We also enabled frame pointers during compilation of those programs so that the kernel stack unwinder will be able to walk that stack. And as a result, what the user will get is a trace like this when the program panics. And what you can see is that here, the panic is caused by unwrapping a non-value inside that injector function. Which we hope and we believe would help the user to pinpoint the program, like what went wrong much easier. And yep. And as I mentioned, another important aspect of safe exception handling is that you must clean up the resources, the acquired resources, to avoid basically resource leaks or even lockups. And for the Titanium API, it uses the dwarf information to identify those landing pads, which is honestly quite complicated. And our insight is that it actually does not have to be that complicated for kernel extensions, because they only interact with the kernel with a restricted set of helper functions. And actually, only the resources acquired via helper functions need to be released. So what Rex does is that it records the resources allocated via those helper functions into our CPU buffer, and at the bindings layer. Basically, that means it's inside the Rex kernel crate. And then upon the panic, our Rex panic handler is going to iterate the resources inside the buffer and performs the needed cleanups. And then
sorry.
Yeah.
Sorry, just for me to understand.
Yes.
I guess it is not possible that this downloaded Rust program overwrites for instance, the variable that the stack pointer is pushed into. But I do not quite understand how that's achieved.
Stack pointer, are you referring to this?
Yes, the Rex old SP, that one.
I'm sorry?
Rex underscore old underscore SP. So
right.
How do we make sure that this is this variable stays intact?
Right, that's a really good question. So right now, since I guess this is like still not that mature, we are currently under the assumption that we don't nest Rex program calls. Basically, you won't have another. So once you enter the Rex dispatcher function on the same CPU, there won't be another call into the Rex dispatcher function until this current call returns. But going forward, I'm envisioning we can do basically the same thing that BPF folks did for their printk function, where their per CPU buffer, it's also, the buffer is also a per CPU buffer, but they have they basically have an array of buffers, which means like when you nest, you go to the next index in that array.
Thank you.
Mm-hmm. Yeah, I think we're done with this slide. Yeah. So yeah, we evaluate Rex on the usability, and apparently the buffer is gone, so there's no language buffer gap anymore. And we used Rex to implement the BPF memcached cache, or BMC, which is a fairly complicated BPF program that implements a kernel level cache for memcached. And what we found is that Rex actually result into in much cleaner and simpler code, where the Rex implementation is just around 300 lines, versus the original BPF program, which is around 500 lines of C code. We also brought Rex into the OS classes at UIUC, and we designed 4 assignments on kernel tracing and networking. And what we found is that our undergrad students can actually write correct Rex extensions. And so now, let me use the BMC cache invalidation logic, the invalidation logic to show as a case study of the usability gain. So here on the screen is the part of the cache invalidation logic of BMC. And this loop specifically looks for the set command inside the payload.
We can just go.
We have a couple of minutes left in case you want to,
We can just go through the end of the page to go through the question here. Yes, it's
no,
all the time.
I think this is the second last slide, so we should be able to get to the questions. Yep. Yeah. So several things, interesting things to note here. And so the first thing you will notice that there's an additional limit the developers have to add, which is called BMC max packet length, to be able to fit within the verifier's complexity limit. And there are also, because the verifier also requires explicit bounce checks, there are also a lot of boilerplate code to just check the end of the payload. And also, there's also really verbose logic to match the set command inside the payload. And if we were to rewrite this into Rex, it would roughly look like this. The first thing you will notice that artificial complexity limit, that artificial variable to handle the complexity limit from the verifier is gone. And also the Rust slices already provide bounce checks in this method so that we no longer need all those boilerplate code. And third is that the Rust byte slice allows us to do really easy match of the set command. And to summarize, it's Rex version is just cleaner and simpler. And as a conclusion, the static verification in kernel extensions such as BPF really leads to poor usability. And our insight in doing Rex is that we can actually leverage language-based safety together with runtime mechanism to achieve the needed usability. And what we found is that Rex is able to deliver the usability without losing safety and performance. And so, yeah, our code is also open source on GitHub. So if you're interested, you can check it out. And I do have some other things I would like to bring to the Rust for Linux community. And I guess the first thing is like, how does the Rust for Linux community think about the idea of kind of, it's a new kernel extension mechanism that sits at the middle ground between the Rust kernel modules and like existing BPF.
So I think this is very cool, very, very nice. I think I'm very impressed by also what you've done with like overall. So saying that your students have done that, I think it's looking very, very promising.
Thank you.
Thank you.
Yeah. So, and regarding your thing with like the Rust toolchain, I think as long as you said like the threat model is that, yeah, like we actually trust the people who wrote this Rust code to not like try to exploit us. As long as you say that, like, yeah, if like that's I think in that case it's fine to say that the Rust toolchain as it is acceptable, and I think that's fine.
Is the BPF the same threat model for BPF? Because I think the verifier is supposed to not allow to.
I don't know, but at least in Android we do say that loading BPF programs is equivalent to root.
Okay. Yeah. No, but
So,
I mean the goal. I mean the goal.
I don't know what the goal is,
Okay.
but
No, I was asking how if he knows if the threat model is the same as eBPF or.
Yeah, eBPF also requires the root privilege to do that. To load
Yeah,
the,
so
load the
in-
eBPF.
yeah.
No, yeah, to load it. Yeah, I mean, if you are trusting the people writing the eBPF program as well.
Yeah, I think it's roughly the case right now, unless like you're saying, oh, I'm loading this BPF program I got from the like internet or some like people send it to me. But in that case, I guess you have the transitive trust on that person who read it. So yeah. Oh, I
Gary has a
see.
question?
Gary raised his hand.
So I think with the BPF. Hello.
Hello.
That's
Can you hear me?
Yeah, very loud. Can you reduce the gain on the microphone a bit? The volume.
That's very tough.
Okay, maybe speak a bit softer and that's it. It's good. It's good. No, it's perfect. Perfect.
So I think with BPF threat model is there have been some discussions with unprivileged BPF in the past, but I think people generally think it's huge. Like it's not. I think the verifier is trying to prevent all sorts of misuses, but it's still like you open a huge attack surface because now you are trusting the verifier among other things. So I think it's more like defense in depth way that BPF is basically
you require root privilege to load BPF programs. But I think with BPF, like you don't actually need to trust BPF if it's verified and implemented correctly. But I think in this case, now you have a much larger trusting surface than what BPF provides. Because now you have to trust the compiler, you have to trust the Rust language is sound, which it is not, especially with higher rank lifetimes. I think there's a crate which has forbid unsafe code and allows you to transmit arbitrary lifetimes by using as the unsoundness. So I'm actually, it feels like it's kind of different surface. Like if you are already a root, can you technically, if you're like trusting the user to that extent, can you just load an out of tree module in that case, right?
Well, I guess you can always load like kernel modules, right? I mean, if that's like what you refer by modules,
Yeah.
but the modules, yeah, I guess. So that's kind of a thing I want to ask. It's like the comparison between Rex versus like Rust kernel modules. I guess like one thing that's a bit different is that they probably have a different like execution model. I guess BPF is more like event triggered, but another thing is like, yeah, I guess one thing I'm not too sure about Rust kernel modules is that it does not explicitly forbid unsafe code, right?
No, we don't.
If your use case is that you want to trust the code, you can also say, I'm not going to load this out of tree root module, like out of tree module, unless it's completely written in safe code, right? Then you can also do that.
Well, you also could enforce signatures on kernel modules and those things and say we won't load a module that's not signed by someone we trust.
So, I mean, in my opinion, I think you could even say, I mean, yeah, you probably shouldn't be using unsafe code, but I don't necessarily think the tool even has to forbid it, right? If you trust the developers, then...
Yeah, I agree with Gary that I was asking before because I thought the goal of eBPF is in theory to prevent all the cases, but yeah, maybe it's not the case today, or maybe it's a stretch, but I think it's the goal. While with here, I agree with Gary that it's a bigger.
Obviously, that's a bigger attack surface. I still think this seems pretty cool and seems useful for many cases.
Yeah, it is. Yeah.
Even if it's, I mean, yeah, it's similar to BPF and it's going to attack similar problems, right? You don't want to write a kernel module for your net filters or whatever, but yeah, seems cool.
Okay,
last. How's the performance versus the BPF stuff that you tried to write it?
Oh, yeah. I guess I don't have the backup slide in this like that, but just briefly describe that. So the BPF memcached cache, we actually did a performance benchmarking on that. So basically comparing the Rust version and the BPF version. And what we found is that, so first, the performance is still on par. And we actually have a slight performance benefit over BPF, which is like less than 5%. But you can see that on the figure, on the graph, which we believe we haven't do a actual breakdown of the runtime. But what we believe is that first, your code is simpler because it's easier to write, and second, because in Rust you are directly compiling to the native code. But in BPF, you're usually using some compiler, mostly LLVM, compile that to BPF bytecode, run through the verifier, and then you go to the BPF JIT compiler in the kernel, which is arguably a much simpler optimizer. So in general, I think like the Rust compiler just produces better code.
Okay. Well, for the two, maybe we should stop here to allow people to go to it. Yeah, for the last two questions that you have there, by the way, Xinhao, yeah, I think we should take it offline and discuss how we could contribute. And the toolchain, I guess we can put you in contact with upstream Rust people in case they are interested in seeing how to make it more trustworthy. Yeah, so please, thank you for this cool project.
Yeah, thank you. That sounds great. All right.
Okay. Yeah. Let me put the sponsors slide. I'm supposed to do that.
Just stop that.
Yeah. Here. And thank you everybody for coming to the Rust MC this year again. Thank you.
Okay. Yeah, we are not familiar with Rust before, so we just search around. Everywhere is your response. Thanks a lot. You're welcome. Oh, very cool. Yeah, when did you start working on that? I definitely want the student thing. The student thing was what I like most. Yeah. Yeah, we are. What at the USC? I was actually almost about to be a PhD student. Almost. The music I compete here says that they just do the papers. But it was not it was for architecture, memory hierarchy. Oh, that's amazing. Because they disappeared there. I think that's really something or from. Yeah, that's how
Yes.
Very good. Very good. I am glad you work all the remote. Yeah, that was great. Yeah, and also I appreciate your work. Did you hear that? Yeah, also, yeah, we just started learning the rocks everywhere. Yeah. Everywhere. Yeah. All the people is like also of course the first one in the forum, for example. All that's in the team are also expert. Like Gary is very good. Then Gary is also an expert. Ben is an expert. Bjorn is another one that is everywhere. You can see Bjorn, when we started Raspolino, Weston and I, we were wondering, is Bjorn several people? Like, exactly, because we were seeing him everywhere, not projects, answering questions, answering issues. And we're like, it's a team of people? No, it's a team of three. I guess you can know better, but yeah.
So what do you think is missing?
But I think that's great.
But that last part is to assert that you can follow.
Hey, what are you doing? Were you here or were you?
No, we had the.
Yes.
We're going to just make this code compile. The last time is what? It's local variable. We set A to 0, and that way we're all pointer of itself. And velocity is down to the last stage. Okay. So maybe we should. We don't have a way to do assignment before the whole thing is initialized. We're going to relax it. Oh, so we're changing the compiler. Yeah.
It's way too.
Hello. See that leftmost screen? Hello. So it follows the sound of your voice. I'm sorry? No, it follows any sound. Oh, you mean this? Yeah. But it also follows sound. So if this is quiet, there is probably, I don't know if it's a Bluetooth or they have a tracking the Look, Daniel, he's able to track. No, it's OpenCV. It's object recognition. Look. So it tracks, then hide, and it doesn't track anymore.
Shall we begin? Yes, it's time. Okay. Can you hear me? Oh. Okay, so first, I would like to thank our sponsor for helping us to support this event. Okay, thank you very much. Welcome. What? Oh, yeah.
Showing up on site, so if you see on-site room, that means the conference or the BBB heroes.
Okay. So welcome to the Power and Thermal Management micro conference. Thank you for coming. So the schedule today is the first part will be presented by Saravana with the sync state for the GenPD. Then I will do a presentation of the different issues we are facing in the thermal framework and maybe some limitation we are facing. Then Lucas will give an update about the energy model being updated when given a thermal situation. And finally, at the end of this first part, I will present a generic voting mechanism. Well, I will propose that. Then we do a break. And the second part will be the multiple system while low power states presented by Kevin and by Ulf, who is not able to attend personally the event, so we do that remotely. Thanks to him, because there is a big gap in time. Then Srinivas will do a presentation about the hibernation challenges, and Amit will present the thermal binning support and what's happening with the thermal coprocessors on the recent system. So just a reminder about the microconference format. It's about discussing. So we can interrupt the presentation, ask, discuss about points, and it's about debating and hopefully find a consensus if we can. If we cannot, then we have to move on because the time is limited. And yeah, so just interrupt, ask question, and it's fine. So Steven, how do I switch presentation now for the next one?
Oh, are you?
Yeah.
So hit the plus.
Yes.
And did you upload?
Yes.
Oh, but there's only one uploaded.
Yes.
That's when you're on, right?
Mm.
So wait, what do you want us to do?
It's this, but I don't see the presentation.
Well, the other.
I think what happened is someone closed the session, so
Okay, so do you have your laptop?
But I have all downloaded. They are all downloaded on yes.
On this here?
Yeah. So.
Oh, yeah, just a hold of them. You do one at a time. Yeah, and just say open. Hopefully, it doesn't take too long to do it. That's why you don't hit that red button.
Hi, everyone.
Hi. Hello.
Can you hear me here? I just want to test my.
Yeah, yes, I can hear you.
Okay, good.
Now, as they're coming up, you might be able to switch to it and see which one you want to go to here first. If you hit the action button, it should be popping up. Do you see which one that you have to start with? And then you can just start and just let that thing go.
So you can go now. Okay. It's your turn, Sarana.
I should start?
Yeah.
Oh, actually, can you give us presenter control so that one of us can move? Or I don't know, Wolf
Yeah.
has control.
No, you have to give presenter to who?
I tried to take it and it seems like
Saravana.
I have it.
Saravana.
Oh, you have
Here.
those? Okay, cool.
Yes, I have it. So I can flip the slides. Good morning,
Okay.
everyone from Sweden. Go ahead, Savannah. You can start.
I think we're on the wrong slides though, because next slide didn't look right. Can you go to the title slide? Yeah.
That's not the.
Oops.
No, it's not the right one.
Oh, so hit the plus. So you know what's the name of the slides? Do you know, or what was it?
Yeah, it is evolving Gen PD something something.
Actually, if you're a presenter right now, you could actually go click on the plus and upload or see if your slides is in one of the.
I'm not presenter. If
listing
you
there.
give me, I can upload it immediately. But
Oh.
I'm not the presenter right now.
There we go. There it is. Is that it? Okay.
Yep. That's yep.
Cool. Thank you. Hey, thanks everyone for being here. Honestly, the primary author and speaker should really be Ulf, not me. He did pretty much most of the work here. So this talk is about how we're going to add sync state support to GenPD, or rather the work we've done so far and all the issues we're hitting right now. Ulf, if you can go to the next slide. Thank you. So just to kind of give a quick intro, why do we need sync state, instead of whatever was there before? So if a bootloader powers on, say, some GenPD, and say it's a shared GenPD, and you have multiple devices sitting on it, then that GenPD needs to be kept on until all the drivers have finished probing. So a timeout doesn't really work because there could be devices where the bootloader leaves the power on, but we don't have a driver yet for that in the Linux kernel, or the module has not been loaded yet if we do have a driver. And sync state mechanism is a way that kind of gives a unified solution for all the frameworks. Instead of having, say, one timeout per framework, just like one unified mechanism that everybody can depend on. That's kind of idea behind sync state. If you can go to the next slide. Maybe Wolf, do you want to take over from here? You're muted, Wolf. Sorry?
You guys hear me?
Yeah.
Is it loud and clear? Should I increase the volume or it's fine?
You're clear.
Fine.
It's good. Okay. Okay. Yeah. As Saravana told you, the sync states thing is a common solution to this problem. And what we did for the generic power domain is that we started deploying support for this a while ago, and all the support was made in a generic way, so all power domains or all PD providers could make use of this without actually have to implement anything themselves. Well, in most cases, at least. And this support landed in the 6.17, so it's a couple of releases ago. And yeah, it was quite a big change in behavior, and unfortunately, there was a lot of regression that was reported. So we have been working in the last couple of releases to solve those problems. Well, the most critical ones, at least. And that's been working out quite well, but it's a little bit, it's been a little bit overshadowed. But anyway, so what? Please, so any question?
Sorry, go on.
Okay. So I think the most important things that we want to bring up here today is two of those problems that has not been solved yet that we are targeting to solve. And one of the problem is that some of the power domains remains powered on even if they're unused, which was not the case before. And then we also have a problem with when there is a multi-MPD provider node, the consumer tracking of it in particular. That yeah, we need to make some improvements of.
And then
Well,
one
and
quick context I wanted to add. Sorry, Ulf.
yeah,
I didn't
please go
cover
ahead.
it in the previous slide. I should have mentioned in the previous slide. The idea behind sync state callback is that the driver will get the callback when all the consumers of that device have finished probing successfully. Now, when you try to translate that into GenPD, that's where you're running into these issues. So in case of multi-provider GenPDs that Ulf mentioned, what he's trying to say there is one single device that's providing multiple power domains, individually controllable power domains, and each of them might have their own consumers. But from a device perspective, they're all the device's consumer, not because that's how firmware dev link and device links work. So that's where we're kind of running into these issues. You can continue, Ulf.
Okay, let's move to the next slide. So the first thing we want to bring up here is the how does this unused GenPD stays on work, and why is it a problem, and how can we resolve it? So as the way it's working, as if there's a consumer that is not been probed yet for different reasons, the GenPD stays on, and it stays on because of the generic or the default configuration of firmware dev link is to use the strict mode. And that means that we're simply waiting forever for the consumer to probe before we actually call the sync state callback. So there's no way for us to turn off thing in GenPD. And there's the options that we can use to make this work is to use the SysFS interface, or you can actually change the mode of the firmware dev link from the command line. And that's a little bit, both of these options are a little bit clumsy to use. It's something that's workable, and you can do it, but it's a bit clumsy. So what we did,
Just to kind of highlight one quick point, by the way, the reason the default is strict is to kind of take care of cases where you have devices that are sitting on a GenPD that don't have a driver. So for example, if you have a display backlight that's left on by the bootloader, if you don't have the strict mode, then after you finish booting, then you'll end up turning off the backlight and the display won't work anymore. But while trying to keep functionality, now we're adding these other regressions. And then the sync state SysFS point is that you can individually control it in SysFS, saying for this GenPD device, go ahead and call the sync state. For other ones, don't call them, meaning you continue being strict. And the timeout is a global thing. And then Ulf will talk about the next two options. So we just basically, the discussion that we're going to have here is what options sound reasonable. Do people have other ideas? Do you want to explain the other two ones?
yeah. So what we did to those options that we added to GenPD was mostly to cover the help out with regressions, more or less. So more or less to be able to store using the old behavior that we had before we implemented the sync state thing. And well, I would say that in particular the GenPD flag there, no stay on, is not something that we want to keep around forever, ideally, but it's there for now to deal with these problems. And the other option, the OFGenPD sync state API, is something that is generic and will stick around. But that is something that is also quite well. It's a big hammer thing. So it will apply to the complete provider. So it's not GenPD basis, but to all GenPD that is provided by one provider. But yeah, never mind. Let's move to the next thing that we want to discuss here. So my concern here with this is that we have seen all these regressions happening for GenPD when we did this deployment, and I would say that most of the problems is because that the default behavior that we had in GenPD when we started doing this was that everything was supposed to be turned off when we are done with everything. So in the late init call, we are turning off everything that is unused. And then you had an override flag in the as a module parameter where you could change this behavior and simply keep things on if you need that. With this new approach, with the sync state thing, we're flipping behavior around. So instead of turning things off, we're keeping them on for good reasons. So don't get me wrong, but it's a different change. It's different behavior, and my concern here is that well, NPD is the first subsystem where we do this deployment, and we're going to look into the clocks and regulators and whatnot, other subsystems, and those subsystems is having the same kind of behavior as the NPD has, and we'll probably see some similar regressions when we are going to convert those subsystems. And I'm not really sure if we should do something about it, and if we should do something about it, what should that be? And so what I'm proposing here or suggesting is maybe we should consider to make the default mode being the timeout instead of the strict mode. I totally realize that might introduce some regressions, so it might not be a good idea for the reason that you explained before, Saravana. Or if we could make it slightly more fine-grained to allow to use the third timeout and maybe make a per NPD decision instead. That's a couple of options I have. Is there any other options that the people can think of, or what's your thought about this, Saravana?
Yeah, so the last point about making it like a timeout that's specific to a device, I think if we can add some kind of flag, and I'm sure there's plenty of room to add a flag, where say the GenPD can set a flag. So basically, you still need a flag so that each driver can opt in or opt out. So by default, I'd probably say it's all of them are opted in, and then drivers can choose to opt out. I think that's definitely doable, because we decided not to call the driver pretty much the last point in the on the sequence. We come all the way to figuring out which driver and then say, oh, it's going to be a timeout, or should we call it? Like we have all of the functions, so that should be possible. But I would also like to see if people have other ideas or other thoughts. And then I don't know how much time we have left, but we have one more complicated point that comes after this. So how much time do we have, Daniel?
You have 6 minutes.
Oof. Okay. If people don't have strong opinions, we can probably move on to the next slide. And we can go, yeah. Go ahead.
Yep. Okay. So the first problem that we discussed here is together with this multi-NPD thing, it becomes even a bigger problem. And what I mean with this multi-NPD thing is that for power domains that is using this power domain self equals 1, it means that one device node is actually capable of providing multiple power domains per node. So there is an additional specifier for the domain ID. And for example, we are using this for the ARM SCMI power domains, but there is a lot of other power domain providers that is using this too. So the problem here is that if there is one of those consumers for one of those power domains that is, well, the driver hasn't been probed yet, or there's a lacking driver, it means that all power domains for this node will stay on. And that is not really what we want. So this, together with that, we don't have this timeout that we just discussed in the other slide. This becomes quite a significant problem.
But this
so
is
what please go ahead.
This problem. Sorry, is this problem with GenPD not also related to other kind of resources the firmware is using? So it's here is power domain, but that could be clock, something like that. So
yeah, the same issues will be for other subsystems too. That's what the last point is trying to say. So we're just trying to figure out, is there a common way we can solve it? We have another slide for some suggestions, potential options. But one point that kind of comes to mind, Dolph, is that the previous slide, we talked about those two options. None of those two options are going to work for this, right? Because you'll still be stuck.
Right. So yes, kind of yes. I mean, if we have a timeout on a per MPD basis, that might improve the situation. But yeah, we'll still have this problem with multi-provider thing that we want to make it more fine-grained. So I would say that this problem is more important to solve. If we can solve this problem, most of the issues would be gone, I think.
Yeah.
So yeah.
So maybe I can kind of try to go through these bullets quickly in the interest of time.
Yes.
So the first one,
Yeah,
if I understand correctly, is a firmware dev link, right? Dev link stands for device link, and device link, as the name stands for, is per device. It does not have any understanding of sub-resources within a device. So it does no understanding of GenPD or power domain, right? So the first bullet is, can we somehow have a sync state on a per domain or per GenPD basis? I don't have a clear idea of how I could do that from a firmware dev link level. The other second bullet is, well, there's another issue that's kind of like tangential, I guess. If you have multiple devices that have the same firmware node, a firmware dev link probably won't play well with that. I'll kind of come back to the bullet later on. I think it's a different part. It's a different problem rather. And then the last one is basically saying, so the last point is basically, can a firmware dev link and a GenPD work together where firmware dev link can give notifications to GenPD when every single consumer device is getting probed, and then GenPD can use that to figure out, hey, which of my 10 different power domains that particular consumer use, and then use that to decide when to turn it off. That's basically what the last bullet is trying to say.
No,
Right?
not exactly, actually. Not exactly, because
Okay.
the notification about the consumer devices getting probed is not needed. We have that already in GenPD. So when we do the attaching of all the devices, there are specific APIs in GenPD that's getting called for every devices. So what we actually need is when we are doing a registration of the GenPD provider, we know the node of the provider, and what we need at that point was more or less to try to understand what kind of consumer that is going to be attached at some point.
That is definitely possible. We can give that to you. That's not a problem. But it'll be a mix of, we can figure out whether you need a list of devices or a list of firmware nodes. But as you're saying that, one thing I realized that is, I don't think your previous statement is true, because yes, you might get an API when the consumer is trying to attach, but can you handle deferred probe correctly? If the consumer tries to attach and then detach it, how do you know if it's a consumer that's detaching because probe failed versus a consumer that just chose to detach?
So that's well, to do the attaching, it's a specific API that gets called, and it's actually everything of these things is controlled within GenPD. So if we're doing eProbe deferral, that's because GenPD returns eProbe deferral. So everything is managed.
I'm saying, no, that's what I'm saying, right? You could attach GenPD, everything from the consumer perspective, everything worked for GenPD. They attach it, but let's say they try to grab a clock later or something else, and that fails.
Okay, I get it.
They're going to eProbe defer. So your attach succeeding doesn't mean the consumer finished probing. I guess that's the point I'm trying to make.
Right.
You still need the sync state. Correct.
Okay, guys,
Yeah.
I'm sorry, we're running out of time.
Okay. Okay. Yeah. Okay. Let's wrap it up. And I mean, it's
thank you.
This problem
One
is
question.
something that we will continue to work on. And if you want to reach out to us,
I think I have one
discuss
quick
this.
question, so I'll let them speak. Yeah. Go ahead.
Yep. Okay.
Yeah, the question, for these multi-provider things you mentioned, the issue is how are nested, how do hierarchical domains handled? Is that also a problem, or will that currently work today with sync state?
Well, that's completely orthogonal to these problems. So, yeah.
But I mean, it's orthogonal, but it's related. Like if sync state doesn't happen on the parent, then you also have the problems with the children.
Right. So
Children being
it's,
left.
well, it, right. Yeah, exactly. So, yeah, exactly.
Okay.
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 Thank you.
Thank you, everyone. Thank you, Savannah.
Thank you. Thank you, and let's try to continue this on the mailing list if we can. Thank you.
Yeah.
Okay, so this talk is about the thermal framework issues and limitation we're facing today. So the first changes we had in the 6.10, we are some people reporting regression because we did a change with the mitigation where actually the switch telling when we are mitigating or not was handled in the stepwise governor, and that was somehow a bit fuzzy and not in the right place. So we wanted to move that inside the core, which is the right place to handle notification and then ask the governor to do an action. And resulting from that, so we needed to unify the way these 3 points were handled, and it resulted in, well, when we crossed the 3 point, the way up or the way down, then we stop and start the mitigation. And before, what we had is the stepwise governor was when we crossed the way down the mitigation, it was not stopping immediately the mitigation. It was little by little reducing the cooling effect every time we were doing a loop, and we checked that the current temperature was below the 3 point, then we were reducing the cooling effect until we had no cooling effect at all. And so it was slowly coming back to the normal. Now we just, when we cross the way down, we just stop the cooling effect immediately. And on system where the thermal capacity is fully full, automatically the temperature has been reported as increasing. So we had some overshoot, and this is something we want to prevent. So what we have today is 2 governors. The first governor is a stepwise governor, which is increasing the cooling effect. The more we are heating, the more it's increasing the cooling effect. And the other one is the PID, which is based on power numbers. So if you don't have the power numbers on the system, then you can use this governor, because it needs to put these power numbers in order to use some kind of regulation loop, and it's a PID loop. So it's the second governor is interesting because it can slowly come to the right mitigation effect, and it does not decrease immediately, but you need power numbers, and also is not working very well when you saturate, when you have the change of the behavior. So that means if the temperature is speed is increasing or decreasing, then all the coefficient-based computation is no longer valid. So I think I already proposed that some another LPC, but I think we need to make the thermal framework to evolve a bit, because it's a bit simplistic today, and we have more and more complex system where we have 30, 40 sensors on the board. There is no collaboration between all these sensors, and also we are just doing stupid things. Well, stupid in a sense it's very simple, and so it could be, I think, interesting to introduce some physics, so new information like the speed, where we can deduce from that the capacity. So one example is when you have the 3 points, you have this hysteresis value. If the thermal capacity is full, then the temperature will tend to change very quickly. So you need a big hysteresis to prevent this bouncing effect when you are reaching the tree temperature. But if you have the thermal capacity which is not full, then you have the speed of the temperature is slower, and then you don't need this hysteresis. And the fact that we have this hysteresis, which is if it's a bad value, you have consequences or overshoot or undershoot, or you lose performances. So one proposal is to introduce new information and to measure the trip speed in the thermal framework and update that as soon as we have new notification about the feature. Does it make sense?
So I think one of the issues there is I've looked at power cap and DTPM and what you're asking for new information in terms of thermal capacity or microwatts being consumed by. I think we'll be waiting for a while for vendors to actually provide that level of detailed information. And it also requires a lot of characterization, which I don't think a lot of vendors will do for every board that they work upstream. So I don't know if we can keep, if we can depend on that level of detail.
No, but what you can do is you can, the thermal capacity, you can deduce that from the temperature speed. If you see
the temperature speeds, I mean, some of those things are, that information is available internally, but it also reveals process and other things which vendors might not want to talk about. The other reason why I think this may be wasted work in some sense is that Intel did this a while ago where everything is handled by hardware, and other SoC vendors are also going that route. So maybe Linux won't need those kinds of controls and software.
You think it's too much?
It might be.
Okay. And what about if we find a way to create a governor which is intermediate between what we have with stepwise and what we have with the IPA?
I think stepwise could definitely use a refactor and maybe improvements. I agree with
that. To be less.
Yeah, I think to do some more smarter things in stepwise. But getting new sources of information is going to be a challenge, I feel.
Yeah, okay.
In longer, sorry, can you hear me? So
Yes.
there is something called neural net PID controller, which there is a paper on it. And if you really want self-learning in the longer run, that needs to be moved to kernel or implement some way. Because currently our the PID controller governor is too much tied to IP power, but PID controller can be a generic for use for anything, not power as output or temperature as an input, right? It can be any output, and you can currently you can do the provide the coefficients based on each sensor, and then they aggregate. But as you know, like as somebody was saying, like manufacturers may not be able to provide those coefficients, right? But using this neural net PID controller, you can learn initially it will take some time, but it learns. So there's good amount of research done on that. So
right.
I wanted to ask for a clarification. Was your suggestion that we track the temperature and see the reactions on the temperature?
Right.
Was it that we ask someone to provide how does this piece of hardware react to?
We track the temperature.
Yeah, because Amit's comment was about how do we get the vendors to provide information, but your proposal sounds much more reasonable if we can measure that from the system behavior.
Right.
He's asking for.
He's basically asking for the slope of how quickly the temperature ramps happen.
Yeah, because the slope is dynamic. You cannot have one fixed value. The slope depends on the form factor.
You need for up and down also slope.
Yes, right.
Also, one problem with measuring is that it's going to depend on the workload too, right? Like if you're running, let's say CPU, if you're running some simple while one versus doing full-on floating point operations, I'm sure the temperature dynamics is going to be different. It's going to go faster. So I don't know how we could handle that in terms of, yeah, I agree with Amit that we can't expect the vendors to provide it, and I agree it's also good if you can actually measure it, but I don't know how it's going to handle this case. The workload type being different.
Yeah, that's why the noise is very difficult to control. That's why it has to, self-learn and adjust.
Yeah, I'm not saying we should try to break a neural thing into the kernel. Yeah, don't take my comment as that, please.
Otherwise, you need to be, like as you say, anytime you do any learning, there will be overshoots. There is no, that, like you said, different workloads, different characteristics. That adjusting the time constant. Like currently we have in our system, we have constants for going up and different coefficients for going up, different coefficient for going down. So, and that vendors provide. So, so there's.
Yeah.
So just wanted to highlight a bit. I do have a bit of physics background. So I think the idea of measuring the saturation point of the cooling solution is good, but it would require a good starting point where everything is cold, basically.
Right.
So like system reboots are necessary. And maybe a question or something to think about is how approximate is this solution gonna be, given that you will very infrequently have these cold states. And even by the time you get to like a booted kernel, the cooling solution is already slightly saturated. And you have to account for that, right?
Yeah, I understand. Yeah.
I'm not sure I fully understand, but if you're just asking about when will it be cold, it will be out of suspend, right? When can't you measure it when you come out of suspend if you're looking for the cool time or like temperature? Like if you're looking for a point when all the temperature is low, wouldn't coming out of suspend be a good point to get that? And is that what you're saying? I don't fully understand your comment actually.
Okay. We have to move on to the next slide. So the next issue is the thermal zone versus suspend resume. So so when you go to suspend, you suspend the monitoring of the thermal zone, and while the device might be in use. So basically, you stop watching this thermal zone while you are suspending, and yeah, so you have a small window during this process when you are suspending the system where you can have something happening like a runaway, because you are not watching correctly. So does it really make sense to suspend the thermal zone monitoring when we are going to suspend?
So why are we doing this in the first place?
Why are we suspending?
Yeah, because there is reason, right?
Yes, I think the reason is because you don't want to be monitoring when you are suspended, but
The reason is the cooling devices that are going to be suspended before the thermal sensor, actually, right? Sometimes.
Right.
So we cannot, even if we monitor, we cannot really do something about the temperature rise at this point because the cooling devices are maybe suspended or maybe not. So you can track all of this, but then gets a bit complicated because you would need to track all of the cooling devices. And now if one of them is suspended, so I don't know, do we suspend the thermal sensor before cooling devices, or what's the rule then? And if so, then all that needs to be coordinated within the PM framework, right? So that's a workaround. I agree. It can be moved a bit by suspending thermal zones after freezing user space, which will help already, and that's easy. But then the next step would be to coordinate or to put everything in the right order in the suspend framework, and then we can maybe get rid of this regime, the suspend regime of thermal zones. So because the suspend is basically to stop reacting to the thermal sensor, and the resume is to start over. And that's because of those dependencies and the ordering in the suspend ordering that may happen in the suspend may happen in different orders on different platforms, and there is no coordination between cooling devices and cooling devices suspend and thermal sensors suspend right now. So that's the source of a problem.
I think Saravana has a question.
Yeah, I was going to say, similar to how a lot of other frameworks where they don't have their own explicit suspend resume handler, but rather they react to their, drivers or components, devices suspending. So for example, clocks or GenPD, they don't have their own suspend resume hook. When all their consumers turn off, the power domain just gets turned off. So in a similar sense, can we not do the thermal zone suspending just part of the thermal zones where either the heat generating device is suspended or when one of them gets suspended, then why don't you suspend it then instead of just like having one point where you try to suspend everything? That way, for devices where, say, the heat generating IP suspends first and then the thermal and then the cooling device suspends, you can continue enforcing thermal regulation for much later point into the suspend or like all the way into suspend.
But
so
do we see those problems actually in the field?
What about the critical points, trip points?
No, but I'm asking if we see those problems in the field, or is it just they may happen in theory?
No, that's what problem reported.
Okay, so there are problems, but they are not reported to mailing lists. They are reported to somebody, and then because in order to fix something, you need to know about it.
Yeah, sure. Yeah, yes.
Is this the classic? Yeah, I'm guessing this is the classic a mobile phone lying inside the car.
Yeah, or in the pocket.
Hot country, 50 degrees Celsius, ambient, and that sort of thing.
Okay, we need to go to the next topic. I was about to talk in the next slide about the few strip points, but Amit will speak about that later. So let's move on. Thank you. So next one is
Lucas.
Is Lucas? Yes, yes, it is.
Hello, everyone. Can you hear me?
Yes, yes, we can hear you.
Okay.
So you are presenter now? It's okay? I think you have the hand on the slides.
Okay, thank you. Let me try. Okay, yes, that works. Hello, everyone. My name is Lukasz. You probably know me. I'm going to talk about some modeling today, maybe. We have roughly discussed this topic about updating energy model a few times in different conferences. I have also discussed this with Rafael and Daniel in some of our sync calls that we have. So this is the agenda. I will go through the description of this issue and propose some idea, and we can discuss about the details of some maybe solutions, hopefully. So what's the current situation? We have the energy model, which is used by energy hour scheduler, and inside a power governor, a thermal governor, intelligent power allocator. And this energy model, it caught a feature which allows to change the power values in runtime safely, so we can adjust the power. And this idea is we can adjust the power based on the current temperature. And why? There are two types of power. There is a dynamic power and static power. Static power, this is the leakage that we have in our silicon. And it was really bad in the past, and then the technology has changed to the 3D transistors, and as we can see recently, it's not passing away. It's still there, and you still can have pretty bad leakage, which might impact your decision in energy hour scheduler or in a governor or in the DTPM, which is also using the energy model. In the past, in IPA, we used to have a static power callback, and we could adjust the power based on the current temperature and voltage. That was the model for the GPU and CPU. A bit simple, but it was pretty accurate. There was a polynomial approximation, and it was quite accurate back then. And the leakage was around 50% back then. That was the planar transistor technology, 2015-16. And today we have pretty aggressive and high performance accelerators, or those new AI accelerators in the same silicon die, which can increase the heat. The rule of thumb, it's when you increase the temperature of your silicon by 20 degrees, then accidentally at the same OPP you might get 2 times more leakage, so you double the leakage. And if the leakage is, let's say, 20% of your total power, then that value can make a difference. So what's the proposal? The proposal is to actually adjust the energy model based on the current situation on the silicon, based on the temperature sensors. That's the proposed idea. To actually make it flying, we would probably have to refactor a few bits inside the kernel, which is how we handle currently our energy model driven cooling devices. there are two places where we use estimation of the power based on energy model and utilization. There is a DTPM and there is a thermal governor. They basically use the same idea, and they are inaccurate when something has changed on the silicon. So the proposal is to actually refactor those two, make maybe one common place when we estimate the power based on this new model, and hopefully we could also deduct which actor, the cooling device, is contributing the most to the heat in the silicon. On this slide you can see temperature of the GPU marked as red, and that would impact the whole SoC temperature, which is higher than normally expected, and then you get actually higher temperature on the big CPU sensor. So this situation we might try to recognize and adjust the power values for the big CPU's cluster. So the proposal is to have maybe a new cooling device which is called power cooling. That would actually take the code which is currently inside CPU free cooling and dev free cooling and put into this new power cooling device the code which only uses this energy model. The old one would be compatible and you don't have to provide the energy model for running the CPU free cooling. There is such an option there. So we would just do the split, and that power cooling device, it might get capabilities for adjusting the energy model. So it won't be read-only user of the energy model, but also a write access mode possible. And there is now the tricky bit is how to model this hierarchical temperature dependency, or a chain of the temperature propagation, something like that, because this information doesn't exist in the current kernel. We don't have a DT describing this, and we also have in the thermal zone we have only one sensor. There were patches which were aiming to introduce a set of sensors in one thermal zone, but they are still not merged as far as I know.
Lucas,
Yes?
I have one question. If we can, from user space, update the energy model, is there no a risk to hurt the hardware if we provide wrong power values?
Yes, for the temperature governor that would be the risk. For EAS it won't be the problem.
So
but we currently don't have, Daniel, we don't have currently interface to the user space from the energy model framework. We only have debug FS, not an official sysfs to change the values inside the energy model.
But it's the same. I mean, if from user space the user is putting a wrong energy model, is there? Yeah. How do you prevent the risk related to a wrong energy model?
Well, it might be similar to messing with settings for the thermal zone parameters, right? So you can overshoot. If you change the 3 points, you can also burn the hardware. So it has to be privileged interface if we go into that. It would be same risk, in my opinion.
Yes, it's some risk. I agree. I don't think it's a good thing to allow writable 3 points, but okay, they are there. So
Yeah, that's why I would suggest to keep this inside the kernel and have some safety net when we are playing with the power values. There is one question. I think Case is on the room in the room.
Yeah, yeah. I think I gave feedback like during discussion in the list when this was first merged, and I did discuss with Pixel team actually. Like I think the whole idea of changing the energy model based on thermal is not really good. Generally, the energy model calculations, we do have lots of inaccuracies in our calculations. Like for instance, we have an inherent assumption tasks are periodic, and they are really not periodic more often than not. So the utilization signal, which we use to calculate or estimate how busy they are, is not very good. Like we as well, like when the task continues to run after like calculating the energy at the wake up path, like the energy math goes completely wrong. So we don't do rebalancing. And that's actually like maybe one of the good things of like Vincent's patch of like the push load balance to do in power. It will allow us potentially to do better calculations. I see a lot of complexities and for potentially really, really very little gain. And like you're talking about thermals, like I think from my view, thermals at skin level, it's slow enough to react to them. But when you talk about SOC, they change really quickly. Like, I'm not sure how fast you can react to them to really do very accurate calculations. And then given that we're already inaccurate, I don't know, like once you do this, like if we're gonna see potential, maybe you can find corner cases or test cases, this shows a benefit. But when you look at whole day views and like people using this, will it make an impact? I really doubt it.
So that would be for longer running workloads case. It would be for gaming, for instance, when you have the GPU heated up and you basically run the same set of few tasks in the game engine. They roughly do the same thing, and it's long running workload. So you heat up the whole chip because of the GPU, mainly that's the case, and then you actually have around 20% error in the energy model for this big CPU. It won't handle any use case like in a generic way, but for the long running workloads it's possible to derive that. If you have, let's say, so if you have information about the total power and the dynamic power, then you can easily deduct, you can subtract the dynamic power from the total power and you see the leakage. And this is basically an attempt to work around this missing sensor, which tells you the dynamic power, because then you start from known leakage, like a set value, and then you actually have a signal which is increasing 2 times after a while, or even a bit more.
Yeah, I still think like this is not gonna produce really like on practice a lot of results. A little bit complicated in my opinion.
Well, so there are some downstream tunings which actually leverage the current interface for the energy model in some phones, which for the long running workloads they play this kind of game for the tunings for games. And there is missing bit in upstream, but it's hard to address that in generic way in upstream. If you own the platform and you run the experiments, you can have the module which knows basically everything about the current situation, and you can play that game. But this is the attempt for making an upstreaming solution for kind of long-running workloads.
5 minutes.
So I think one view is that if we make energy model as the default way of enablement of platforms upstream, then I think that's going to stall a lot of upstreaming as well, because characterizing all of this actually takes a lot of time to do this accurately. And can't we just, so when you propose that we basically create a new power cooling device by merging DefFreak and CPU-FREC cooling devices, which kind of work today. I mean, they're not perfect, but they at least work somewhat without relying on energy model and whatnot. So that I think we should have a two-track enablement where at least the basic stuff can be done with heuristics. Might not be great, but then if somebody wants something better, you have something with the energy model in place to get better performance in mainline.
So we have this diaphragm cooling which already uses. I'm sorry. That's my dog. That's very early morning on my side. I'm sorry. So there is energy model already in the DEFRIC. There is one driver which actually supports this upstream. That's the Panfrost driver for GPU. Yes, and I agree that would be an engineering effort to tune the energy values, power values for the GPU, for instance. We can help with this a bit for the tuning bit. We can maybe create a module or a code which can help derive the proper values. But yes, I agree. You would have to measure at least the power on the GPU. Because then you need those three actors, CPU and GPU, and well, two actors,
Well,
CPU and GPU, but they are
I'm going
little and big
to be
cluster.
talking about co-processors later, and then there's modem and NPUs and accelerators. So it's all going to be there at some point.
Yes. So yeah, I agree. If those
Yeah,
would have the energy model, then they would be in the power cooling device in the new one. But if they are not, then yeah, that would be the problematic bit.
and this also depends on the form factor, right?
True.
And the case and so on, because if you put all of the stuff in a thermally constrained case, it will change. So you
Yes,
have
it
to
will.
you have to basically take that into account as well, right?
Yes, and you would have to run this tuning module to derive the new settings.
Yeah.
So yeah, most vendors are going to do this on a reference board, which is open, and then
watch, right?
teams would have to figure. Yeah.
Yeah, so this is what they basically do now when they derive those more accurate models. We don't have anything in upstream close to that. This module, kernel module, which could do the tuning, would have some limitations, like the simplified model for the leakage, for instance, dependency between temperature and leakage and voltage. Yeah, but we don't have this infrastructure to derive the power in those use cases. So that would be still kind of an approximation of what they
2 minutes,
really
Peter.
have in the products. Yeah, thanks, Daniel. Yeah, so maybe skipping this update feature, there was this, Daniel, we discussed this, that we maybe can handle the duplicated code inside the DTPM and the IPA, which uses the same idea to derive the power energy based on the energy model and utilization. This might be maybe refactored a bit into one place.
Yeah, that makes sense.
Yeah, we still have, I don't know if we handle this, Daniel or Rafael. We have this dependency when you power cap some device and then you actually don't know about this in the thermal governor. I think there was this PMQoS issue that we actually don't read inside the thermal governor, the setting from other subsystem. But when we will merge those two, I think this would go away.
When you're saying thermal governor, you mean IPA?
Yes.
Okay. Yeah. There is that.
Okay, so yeah, currently they cannot work together, the power cap and thermal IPA governor. So I might handle that as well, those two.
So I would say this is, I mean, reducing code duplication is always good, right? And so maybe that's a low-hanging fruit. And then the coordination between IPA and PMQoS would also be good to address, I think.
Okay, okay, thanks, Rafael. Yeah, I think that's it. 2 minutes left. It's gone already.
Okay.
Thank you.
Thank you, Lucas. So the next talk, it's about a generic voting mechanism. So last year we discussed about one feature. So what we wanted is to have the user space to be able to ask for some performance level for CPU or some other devices, and aggregate this this information, this request with what the kernel wants. And also what we wanted to do is to prevent the user space by putting a constraint or putting a performance level to a specific device and then go away, and so this information is lost. So what we wanted is when the process is exiting, then we remove this constraint or this performance level. So we agreed that we should implement that with /dev. So that's what I've done, and I sent that to as a RFC, and Rafael basically disagreed with the overall design. And so I just wanted to, so I stepped back and I say, okay, but that actually, really what we want to do is at the first, before anything, what we need to do is to do some kind of aggregation or some kind of voting. And what we have, so that was the initial need. So user space asking for performance level, kernel asking for another performance level, and we have to take a decision based on some heuristic or logic inside directly. So we can have, that's an example, but we have more subsystem doing voting and exchanging decision. So all these are interacting and asking for different performance level or minimum or maximum. So I think before talking about a QoS or a constraint or things like that, maybe we should provide a subsystem, which is a voting subsystem, where we can vote, allow the user space to vote, allow the kernel to vote, allow some subsystem having more priority to put a veto on the vote or force a specific vote. And we can find some complex voting mechanism, for example, in the interconnect, and where we give a list of different will, and then the system inside is using its own logic and finding one winner in this vote. So I think we can actually move a lot of logic and a lot of decision just by using the right voting mechanism. And so today, what we want to do is aggregate. So choosing the maximum or the minimum, we can say it's not really a vote, but it's a vote. Actually, we just take the bigger or the lesser. Yeah, so that's basically the proposal. So it's a subsystem, generic, and other subsystem can use this voting. So I've been looking at the policy for different policies for voting, and there are a lot of different policies depending of how we want to promote one or other decision. And so it's interesting, and I think we can put a lot of logic inside instead of polluting all the subsystem with their own logic while we are duplicating that. So yeah, so that's the proposal, and maybe begin with something simple, just auction, and auction is like aggregation. So when you have maximum auction or minimum auction, that's it.
So the use case is we need to adjust the state of cooling devices, right? Or generally speaking, devices based on those votes.
It's not on. Yes, today is one of the use cases is the cooling device, is the DTPM, but also aggregate what the user space is asking with the kernel, and provide the mechanism where the user space obviously does not have precedence on the kernel because the kernel is always in control, but also provide all the cleanup by removing the votes when the user space is exiting. Is the idea is
so what I'm asking about is what's the subject of the vote, like, because there will be some adjustments will be made depending on the results of the vote, right? And now what do you want to drive with this framework, say, right? The state of cooling devices or something else, or what's the target?
Yes, cooling devices. Well, you will have one system. Let's say, for example, CPU FREC. The CPU FREC is receiving the votes and is taking the result of the vote to change its state. That's one example. So all the voters are DTPM, user space, cooling devices, etc.
Yeah, so state of something depends on the
state of something. There's nothing that could be
of something, not necessarily a cooling device.
It's generic, so it's totally an abstraction. So it's an abstraction. So the voting is not taking care of what is the value actually, what is the meaning of the value. Just give a list of value is giving you the winner of this list of value.
So I think Daniel is proposing a generic voting infrastructure that could be used for anything.
Yes, right. And the first user will be
sounds like that.
Yeah.
But if you have different drivers from different SoCs, don't you need to agree on what the value of the voting is, so that the vote, what it represents? Like within one SoC, you could control everyone votes for the same unit, but you have drivers which are multi-SoC. What is the unit of the vote?
So the vote is abstract. You have to build on top of that your own layer to do the right the unit you want or whatever you want. But the votes is just providing a way to do a selection of what all the voters are providing, and providing also the user space interface.
How can you unify different SoCs and different drivers to have the same abstract generic thing? Some DT CPU idle are shared, right?
I'm not sure I get your point.
Well, for example, Qualcomm would vote for some performance level for, let's say, a clock, or I don't know, bytes per second, whatever, right?
Right.
But different vendor might measure all of their drivers in different units. Let's say they have 3 states or
Okay.
yeah, for example, right?
Right.
States. So what would you pass to a generic voting mechanism? What would be the argument which you pass to the call for the something, you know?
So it's a draft for the moment, the patch set. So the idea is to give a list of value. So when you are in a case of the aggregation auction, then you pass one value, and all the voters are passing one value, but you have for each vote, you create a ballot. Then when you create the ballot, you assign a policy to the ballot. So that could be the aggregation auction, or it could be something else, weighted vote or something else. So you create this ballot, and all the voters send values, and then the ballot is giving back the winner. But there is a policy associated with the ballot.
So the policy also would determine the unit used for the voting, right?
No, you choose the unit when you create the ballot. You instantiate, yes.
Correct me if I'm wrong, but I think what you're suggesting is everybody could choose to instantiate a vote. The appropriate drivers would get some sort of notification.
Right.
Then they would vote for whatever that unit is.
Yes.
So we could potentially use it for interconnect, maybe clock framework, other things. Is that what you have?
Yes. It could be a power value, for example, milliwatt, but it's all the voters are agreed it's the milliwatt.
Very ambitious.
As usually, right? If you find multiple users able to using it, yeah, it's fine, right? You don't have to propose the patch, which and the users. This would mean that, for example, different platforms, SOC platforms, or different architectures.
Okay.
I have a question, Daniel.
Yes.
So this there are two types of this vote. For instance, critical or normal, and what you would like to achieve with this. For instance, I don't know, a critical, that's definitely not something that we would like to pass through. But then a hint, or so you can.
No, critical. So a critical, you can force a vote as a dictatorial vote. So it will. So it's the fourth bullet. So you have a critical situation. Someone is voting with a critical. So there is no. It is taking over the vote, and the consumer of the vote will take this value.
So if we take as an example CPU frequency, and there are two subsystems, one is setting the critical max frequency, and the other is kind of creating, in this case, a hint, which is a bit lower frequency, but then you can cross the first one, but you cannot cross the second one, or how that would work?
The critical. So what will happen? You will do a vote, but the vote, if you choose the vote in the critical situation, this vote will be specific. So it's a dictatorial vote, and when you do the vote, all the other voters there is a veto for them what they want, and that will be your vote, and the system connected with this ballot, with this vote, will take this information to directly use the result of the vote. So the subsystem is connected with the ballot receives all the votes, and when the result of the vote automatically updates the system, the subsystem, which is subscribed to the ballot.
So I have the problem, Daniel, with, for instance, you have this DTPM and thermal governor for the same CPU, and then you set the power profile for the whole platform. But then you have the second actor, which is thermal, and now the thermal is the critical the voter which has the highest priority, and it actually can change the profile for the platform. For instance, the power cap was lower the power, save the battery, but now the thermal actor actually increases the frequency a bit and removing the power cap profile, the known from the user space. Could that be possible?
In this case of voting, no, it depends on the kind of vote policy you choose. So
okay,
if
so
the thermal, so the power cap and what you will have is one subsystem connected with the ballot, which is CPU-FREC. Then you will have all the voters. On all the voters, you will have thermal, and then you will have the TPM. But also you could have what is in the SysFS, the sys devices system and CPU-FREC.
The third one, yeah.
Yeah. So these are all voters. But if the thermal is saying, okay, I am a critical situation, I'm taking over the vote, he sends a dictatorial vote. That means its vote will overcome all the other votes. And this decision will be used. The subsystem connected with this vote, with this ballot, will be CPU-FREC. He's not aware of what's happening. He's just taking the result of the vote. And then we receive an update, apply this vote, this value. But you need a glue between the CPU-FREC.
I have a question. How do you decide which voter can be the dictatorial one? I mean, if everybody say, I want to be the dictator and select, I mean, how do you say, yes, you are allowed to be the dictator or you're not allowed? How do you make the selection? Otherwise, everybody want to be the dictator.
But that's so it's kernel, so it's not user space. It's not a library you give to user space. You don't know what people are doing with the library. It's a system you are developing, so you are supposed to know how you put in place the system. So if you do a misusage of the voters and you put a dictatorial for everyone, so yeah, somehow
it would be a static configuration then.
Yeah, I think it could be a static configuration. So thermal typically needs the dictatorial vote. Power cap, not.
So is there any specific use case you have in mind for using, for this?
So yeah, I have two use cases. All the aggregation needed for CPU-FREC, the FREC, and maybe but I have to dig into a bit more is interconnect, where the different actors are asking for performance or power and bandwidth, something like that, and it can give a list of the preference, and then the voting mechanism with another policy can do a vote, a weighted vote on that, and then select one of them. So that's two direct application. And for what I've been investigating into the kernel, there are a lot of different voting mechanism. There is interconnect, there is in the file system, also distributed file system, there are voting mechanism, etc. So I think we can identify some part, and when we have this voting library, will be under the library, then we can, if people are creating voting in their driver, we can ask them to move on.
Yeah. So I am a bit skeptical with starting at the library level or generic mechanism, because it's then hard to convince people to use it instead of what they use already. So I think that it really is. There really need to be at least, I don't know, 2 use cases for this where they can be addressed with it, and you need to demonstrate that it's helping, right, in those use cases, and then go from there, and it may like build evidence for other people to maybe switch over, right? So that's
right. I think the first thing will help is the user space interface. So you create a vote, and you have automatically the user space interface.
Well, yeah, but that's why I'm talking about the use cases, because then you will need to basically show that or demonstrate that this works in practice in at least one or two use
I agree.
cases.
I agree. It need to be connected on something. I agree.
Do you have a concrete use case where you want user space to vote on something?
Yes, CP-FREC and DEFREC.
To override what the governors choose, or what's the actual use case? So when the user wants to select a particular frequency for testing or something, or what are you?
Yeah, there is an aggregation. There is in thermal, there are aggregation in the cooling state, and so we can use the voting, replacing this aggregation, which is duplicated in each governor, and we can probably, if Raphael is convinced by the solution, replace the aggregation of FREC, QoS, max, and min by this voting.
Yeah, so I don't know. So is there a problem with the current? Or what problem is there in the current with the current approach, where there is a QoS for min and max, and
so it's difficult to extend the current code, the FREC, QoS, min and max, and there is no aggregation with the user space.
What
Yeah.
do you mean by this? No aggregation with user space? That's
so
a very broad statement, and there is some aggregation, because the user space currently just has
user
a
space
request for.
It can do a request, but if the user space go away, the request stay there.
Oh, you mean there is only one entity in user space that can set it, right? That's
Yes.
true, because we have a SSFS interface.
Right, and the initial.
But as long as we have a SSFS interface, there will be the same problem, right? So
No, because when you use so that was the initial proposal when I proposed with the RFC with the PM, what I called wrongly the PMQoS, the usage of /dev when you can have several processes opening this file and doing.
But this problem is separate from the voting kind of framework, because this is a problem of an interface, not a problem of.
Yeah, but I'm proposing to do the voting with all this interface already with user space. So the vote can go away or stay with the process handling the file descriptor.
Yeah, but the you may kind of you may kind of regard the current solution as a voting mechanism, right? That very much, right? Because it's like somebody that there are multiple actors. Every one of them has a value, and they are like casting those values, and somebody wins, right? That's how this goes basically. But the interface for user space is SSFS. As long as it is SSFS, then you will have the problem where there is one entity in user space that can participate in this, but we can add a dev/dev based interface to the current thing and then see how it goes, right?
Right.
Independent of all of this. So to me, there are two different things. One is the interface question, and the other is how the values are going to be aggregated this way or another, right? So those are two. So what I'm saying is that those two things don't need to be tied into one solution, right? They could be treated separately or addressed separately in principle.
Okay, I will send a series in some
But
weeks.
your hope was to have a /dev/vote thing that is standardized on top of the voting mechanism, right?
Right.
So why don't you try to create the voting, the common voting code, and get that sorted out in the kernel as a helper library, and then as a second step, then we can look at see if it makes sense to tie that to a dev interface.
So
right.
Alternatively,
okay.
if you go the other way around, then you come up with use case specific dev interfaces, and then we might come to the conclusion that later on that we could have tied it to the voter.
But I'm not saying about use case specific dev interfaces. I'm saying that this is a different. I don't see in principle why the interface should be necessarily connected to a specific handling of the values that are provided, right? So a user space. So we need user space to be able to say I have a value for this, right? That's a one thing, and then we need to take this value and do something with it. And I'm not sure if those two if these two things need to be tied together. Yeah. Well, I don't know. Yeah, if you send patches, it will be easier to kind of talk about it, because this is a very high level right now, and then but again, there needs to be a specific use case in which it is applied.
Yeah. Okay. Yeah, sure. Okay. Thank you, Rafael. So I think it's time for the break.
A good use case might be, first use case would be that actually takes into consideration both kernel constraints. Because right now you have to pick between like on-demand or whatever, schedule or whatever. Or there's also a user space governor. And I've seen platforms turn on that user space governor, right? A user space daemon that sets the stuff with and provides its own voting or whatever, which several people do that, but there's no way to do voting in user space and voting in kernel at the same time for CPU free. That can be easy. Have a new voting governor in CPU free that allows kernel.
But then we're still speculating whether that is the same user space interface as voting for other things. Like you mentioned, interconnect. One of the three drivers we have is for debugging purposes, being to override what the kernel votes say for testing to drive different losses to max speed and so on. So that could very well be the same user space API, or it can be a different one. Yes. But if you tackle it from the other way around, then you have these duplicated aggregations, voting mechanisms in the kernel, you could have common library of that. Then we will know whether we have this set up and we can abstract that through the same API. So it's just a question of whether do we speculate on there being commonality first, or we create the commonality and then we expose it. I think it makes sense to do it. It's great to do some common code for stuff like this, because it is something we spread all.
Yeah, and the voting, you can change the policy of the voting, and I think there are a lot of algorithms inside the kernel. You can just remove them and just choose the right voting.
I just wanted to confirm this. So when we were talking about the thermal runway, so what are you proposing? Are you proposing that you need, because the slopes are going to keep changing, depending on.
So you talk about the first.
Yeah, the first one. Sorry. But you had a different opinion on.
No, when I listened to what you said we just measure and then we see when there is rate changes, or we measure the rate changes at any point in time, and then we react to that.
But that's a use case driven thing, right? I mean, we know.
One example, if depending on the exterior temperature, the case temperature, the saturation, so you can have the temperature changing like that, or you can have the temperature changing like that. If it's doing that, you need a big hysteresis. When it's slowly moving, you need a small hysteresis. So today we have fixed hysteresis, and we know we are losing performance. And we are, but if we are able to detect that the temperature is moving fastly, then we can adjust the hysteresis. That's one tune. But you cannot do that with the PID, because the PID has coefficient, and these coefficients depend on the slope of the behavior. But as soon as the temperature is changing, going faster or slower, then all these coefficients are no longer valid. You need to readjust them.
What we have is all the.
The funny thing is that class is the only thing that keeps me from getting my degree.
Signals and systems?
Yeah.
That was a hard one. So what we have is numbers that you're looking for TJ and T-skin, is what we say, right? So the temperature on the die and the T-skin is what you feel outside. So we have those numbers, but again, I mean, we're talking on milliseconds here, so or less than that.
No, we don't, because we will never be fast enough in software to cap to make the CPU core survive. But we need this kind of stuff for limiting the skin temperature, and that changes over much longer time periods. Right, so that's.
And also the faster is the temperature change, the temperature slope. The faster you need to sample.
But that's basically your TDP budget, right? That's your overall TDP budget.
Right? Yeah, but with the accumulation in the PCB and in the thermal
and the casing and everything.
But that's also the problem with this. We cannot provide good values for that, because say a phone, if you wrap it in your case or in your pocket, then it will behave differently.
Which is what I'm saying.
So doing something dynamic is.
So you have to look at dynamic.
Yeah.
And if you are,
then how do you do it then? So that's the part that I'm not getting at this point.
Because I think what you are seeing is we have temperature transition very fast, too fast to be handled by the canal. So that's not in the scope of the canal. But you have other places where the temperature is not so fast, that you can monitor from the canal. But the faster is the temperature changing, the faster you need to sample. So you have also to adjust the speed of the sample. If the temperature is changing slowly, then you can sample slowly. If the temperature is changing very quickly, then you have to reduce the sampling window and adjust the hysteresis. And by doing that, prevent overshoot and
Yeah, and I wonder if that actually matters in that case. Like if so, what we use is the software thermal control for would be to not burn the user. So that is a
T-skin. T-skin is what T-skin.
Yeah, so it's a really slow.
Yeah, hysteresis is 1 degree per second. So it's,
and it's
that's what I measure more or less.
So,
it's a lot more.
I would say it's much lower. So, the typical scenario is like if you compile a kernel on the laptop, it takes a couple of minutes of having the cores at 95 degrees until you hit 50 in your line. And it takes many seconds before, and if you then stop, it takes many seconds before it starts to go down. Goes very slow. That is a really slow process. What we don't do well is when we hit that 50. So we start actually counting. How do we then prioritize?
You have the inertia. What you say? There is the inertia and the temperature is to go keep going up and then reduce, stop and go.
Yeah, because the heating element that within the CPU cores that will go to max immediately.
Yes.
So there we can react. But then after minutes, the actual shell will have reached a point where we need to stop.
Yeah, but if you sample the temperature, if you sample the skin temperature, you can do an extrapolation. When you will reach the skin temperature. So you can.
But if you want to anticipate that.
Yeah. Should be able to anticipate.
Yeah, but do you want to? Say I have a word. Say it takes 2 minutes to set up the skin temperature, and I have a word that it takes 2 minutes. Do I want to start the throttle before?
Not throttling at the maximum, but at least what you want to prevent is so there is an array of the temperature. So you have 43, 44, 45. And the other is the duration before having skin burn. So it's 8 hours for 43, and it's 10 minutes at 50. So you can accept that. If you don't go above and you stay in a 43 violation.
But isn't that what IPA was designed to do effectively? Basically, reduce this way.
Yes.
That was what IPA was.
Yes. But the
I have
IPA,
one driver.
Yes, but there are other ways to. I think there are other ways to mitigate. Not using the IPA, because the problem with the IPA is very sensible of the change of behavior. Sensitive to the change of the behavior of the thermal medium.
Yes.
So,
which is why I'm saying that it is getting. I mean, we have one driver I think which supports IPA upstream, maybe two, last 10 years ago. Because of the characterization that had to happen to get all of that. If there is a way to make that simpler, make IPA simpler, with something that you have in mind, I think that would be very useful. Because IPA today is too complex, and it was designed to do exactly that.
Yes, it's too
but it would be really, really nice if it was self-learning instead of having to. In particular, you have that case where you don't know what the environment is, or the environment is changing, so the characterization of the data is incorrect in most use cases. Or rather, when as soon as you take the thing out of the lab, the numbers are right.
Exactly. I mean, even the environment. I mean, taking it from a pocket to
you take your laptop and you walk from the lab out in the sun, and then you walk
exactly.
Or in the Swedish cold, and it's going to behave differently.
Exactly, and you need that external input.
Much more dynamic.
Yeah, I was thinking about the Bayesian network.
I mean, anything that would simplify how to do IPA, right? I think would be very useful. Right now, it's too hard. I don't think there is enough documentation for products. Well, in general, for all of this, yes, energy, IPA, for product engineers to go and tune the products to do the right colors.
How do you have multiple contributors to the lead? So the sensor, the case sensor is in the anticipator, right? You have a copper medium and the sensor on top. And this copper is on top of the
like some corner of the PCB where you on a per product basis say that approximates what the user touching outside would be. So it's really it's much slower than that. So you can have the say the temperature of the air coming out from the fan or whatever.
Yeah.
That can be much warmer. Or that and presumably that could be a different thing that you want to throttle on. But no, this would be like what is the underside temperature of your laptop, not what is the cooling system temperature.
Okay, so how do you know which component you mitigate?
Well, you have the hotspots. You know all the hotspots.
So you need
we
to
have,
have-
at least on Qualcomm SoCs, you have.
Well, effectively, we have the chip is the CPU cores, they're going to be at 90 degrees. And then in the outskirts of the SoC, it's going to be a lower temperature, but it's still going to be that. And we don't care about that in this use case. What we care about is that if you hold that thing at 90 degrees for some amount of time, then this corner over here at the PCB or in the plastic at the bottom, there we have a sensor. And when that hits a certain rate, then we need to make sure that we don't produce more heat. And there, I guess it would be good to have some level of sophistication, so it's not an on-off thing, as that temperature is.
Yeah, so you need to mitigate, but having a lot of entries before.
Yes.
For all the sensors, you know which one is.
Oh yeah, no, we have one specific sensor.
So you have one specific sensor, but you need to monitor all the others to know which one is contributing.
No, so you have the SoC, that is going to generate heat. And then we have far off the SoC saying now the temperature here is approaching the point where plastic is going to be at a certain temperature. But from that point of view, sure, you have the question of when we're approaching, say, 50 degrees or 40 degrees or whatever, we need to tell the SoC to start to ramp down.
But how do you, which one? So, for example, if you are doing gaming.
Yep. Yes, so that's another question. That is, how do you actually connect those things?
That's the use case.
And then we have even without use case driven, you have some thing where you need to connect that to limit. And the only thing we do today is that we limit the CPU frequencies. That is suboptimal in the current form, because what happens when so if you build a kernel, and when we approach the point where that, or we hit that skin temperature point, then we start the kernels, or the cores. So what will happen is that the performance cores will stop doing anything, and then the energy cores, they will effectively keep the temperature at that threshold. So they will do suboptimal work to just keep us on that boundary. And I think we could do better there. But that seemed to be just a matter of making sure things are set up more properly.
Yeah, I think that was more of a configuration.
But then there's that other problem. If you do a mobile device, how you mitigate the temperature, that's the use cases. Like if the user trying to record feedback now, or are they gaming, or are they doing data transfer, for example?
You have to vote.
Yeah, but the policy would have to change at runtime based on what that's the user, what that applications do right now.
I mean, Google just gave a talk about what was it, PuffQoS, which they're proposing. Basically, a user space library, which, I mean, we've been talking about this for years now. User space policy and being able to detect what is the use case running, which
But the
can
thing
make
is,
more
how do
intelligent
you do that
decisions.
so when we're building embedded devices, then you have that end-to-end control. But if you rely on that, how do you build a laptop? How do I get a decent policy into my Fedora system?
So have you looked at the resource tuner that we've been working on internally?
No.
Okay, so that's been pushed to GitHub now. Yeah. Everything that was described in the talk, the PuffQoS talk this morning, we have all of that. It's available. So it's all the usual knobs around CPU freak, clamp, scheduling policies.
But the question is like,
and there's a classifier engine.
Yeah.
There's a classifier engine which actually knows what's the Chrome profile, what's the gaming profile, and they've done something
with LLMs to basically teach it
Yes.
how to detect.
So that takes care of the embedded use case. If I build an embedded product, then I do all of that and classifies, then I release to you my full software stack with everything. Sure. Yeah. But what if I did a release to you a dev platform, and then you run away and you build apparently a gaming device out of my camera platform, or I intended for this to be camera, but you do gaming, but you do AI. So that means that my profiling is not going to be suitable for you.
Yeah, I mean, you might have to add more profiles to
And
extend.
then Kevin runs over to Best Buy and buys a laptop, and he doesn't like Debian. He wants to do Fedora. So
where do we carry all those
his
policies?
profile in there?
And how do you combine user space decision making with kernel decision making?
Yeah. Well, what that even means to I'm running the camera use case.
So
what does that even mean?
Isn't that similar to why thermal isn't effective today? I mean, thermal is being run by every distro, and it's only capping CPU and maybe a GPU at this point.
Yeah, well, but yeah,
it's not. It doesn't know about the use cases.
No.
So that's the same problem. I don't have the answer to where the policy will be hosted, but we could at least start with a default policy saying this kind of works for this subset of workloads that we have characterized. And I don't know if it becomes a crowdsourced database. I don't know.
Yeah.
But yeah, it is a perfectly good question.
I would definitely like to have a configuration scheme that comes with the device, which takes care of the basic stuff, and then have some of the kernel be able to adjust that for if you have knowledge about the use cases. Yeah. But having the base system work pretty well would be.
Yeah, so I think that's the current target. What they're characterizing is a basic set of use cases around.
Yeah, but I don't have those use cases because I'm not running their software at all. So they characterize something for some particular, like, oh, I'm playing a YouTube video playback in Android.
Sure.
That's going to be a data point. And then I start Wayland, start Firefox, and do YouTube.
Yeah, so we might have to do we might have to create our own configuration file for.
Yeah, but
again, yeah.
But then
you're right. I'm agreeing with you.
Laptop thing of everyone needs to figure out which config file to download from where, and you don't. And then we end up in the problem that what day can we actually take a laptop and send to the installer and have him just run it, because he just needs to read this wiki and download this file and put that over here and overwrite this in EPC. And oh yeah, by the way, you had full disk encryption, and we give you 10 seconds to type in your password before we turn off the regulator to the display.
But yeah, it's like you have to know.
We need to get out of that embedded thing. That would be a special case of the generic system.
Right, it would be so much simpler if we just did one type of device.
Well, no, but yeah, all our software in our space is written for the fact that we build one type of device. And if you build another one, then you build that device. But these other things are killed.
Servers. So to reload a few things. Then yeah. Do I need to reload my slides?
And now you updated my laptop to 618. Did you give you the prompt of the file system password? And I had about 10 seconds before I would start using it for a timeout. Now it turns off the screen while I'm trying to type it in. So I can type it in. And if I'm fast, I'm beating the deferred probe timeout, and everything would just work. But I can't see that I'm typing.
I don't even have a laptop at this point. I've been trying to get a laptop so I can start working on
This year when they submitted.
Yeah, and I saw the PMIC guy. He was finally resubmitting the ADC driver without. I'm not sure you can see that. So on we don't have skin temperature cooling support yet, because we don't have ADC to read the temperature. Because the guy who wrote the updated a new driver for that, the first patch is some header files. So he had one commit that changed the include path in the drivers, and like 25 different device tree.
C'est bien parce que tu vois le reste.
So it's been like 1 or 2 releases where I have never merged this because
Pourquoi lui il a le droit d'être toujours là et
if I merge it, I'm going to break the drivers, I'm going to break the trees. Alors que System One, then I tried to do that, and then the patch didn't fly anymore because he had reset. And then the next time he had sent it, the IO key had been updated, so it didn't merge. But now finally he has a problem with
Il se croyait dans un cadre. Mais t'as pas vu qu'il était en fait, il était en train de chanter. Il n'était pas en train de parler, il chantait.
Yeah. Well, I think a daughter that's 38.
Donc t'as vu après, il faut qu'on se file pour être au restaurant à l'heure. À 6h30, t'éteins tout la lumière et puis on part. Tout dépend si t'es rapide. Tout va dépendre de toi.
C'est toi le It's unfair to impose because nobody's been focused. I think it's that.
You don't know that it's that's what I got mine. That's what I got.
Juste mon manager.
I completely
These are -9 something. Oh, that's
yeah. Well, we tried it out. Why is it somebody wants to start one?
Yeah, so I see where I slide. I no, I can actually sort of semi-read, but it's not easy. So I can make the big ones.
So I think
This one?
Okay, we are starting the
Okay, yeah, it's on.
first presentation of the second part with Kevin.
Okay, I think we're ready to get started again. This talk is a combination of work from myself and for Ulf. Ulf is online, but he's home in Sweden and up early. Thanks for joining us, Ulf. I'll be presenting from here, but yeah, Ulf may be jumping in as needed as well. So I'm going to cover like three parts to a similar topic. So let's just get going. So the first part is about suspend to idle state selection. So just a little bit of background. So as modern SoCs have lots of low power idle states, we're all familiar with that. CPU idle has a way of choosing between idle states based on various criteria, latencies, and so on. But we also have this suspend to idle feature in the kernel where we can do system-wide suspend using the same kind of idle framework. And today, the way that works is it doesn't actually pick among the available idle states. It always just picks the deepest idle state. So that's the kind of the problem here that we've been trying to solve is basically when we're using platforms that are using suspend to idle, how can we suspend and have a choice of the available idle states similar to how CPU idle works? Right. So then the question is how do we pick those states that we want to pick between? So CPU idle has its way of picking states, but we want to have a similar way to suspend to idle. So that's kind of the current state of affairs. Although very recently, Ulf introduced a new mechanism for helping to choose this state. So this actually, since the time we proposed this talk, the proposal from Ulf actually has been merged. So we have this, at least the beginning part of this feature already merged. So the way it works today is it maps, so this existing user space interface, the CPU DMA latency, this is an interface that's existed for a long time. It's used by CPU idle. But like I said, we didn't have a similar thing for suspend to idle. So in some discussions on the mailing list, we decided to have a separate to not reuse the one from CPU idle because the kind of low power idle use cases and decision making may be different from the system-wide suspend decision making. So we created a kind of a parallel, similar interface. So the second one here is the one that Ulf proposed in his latest series. So this new value is used by the system-wide low power state selection for suspend to idle. It's also used for CPU idle, and it's also used for the PM domain idle state selection. So in PM domains, it's also checking this value and can make some decisions based on domain idle states. So that as a few weeks ago is the current state of the art. Yeah, go ahead.
When you say there are several system-wide low power states, are these states you have different IPs with different level of power, or is some devices are not powered down and some other are powered down? So it's is it all the component having different idle state, or is it just a patchwork of what can be powered on and not?
It's kind of a patchwork, but it's a very SoC specific. So similar to CPU idle states, they can be defined. They can be defined in many ways, but because a lot of these states actually are implemented in firmware, it's very SoC. These are like PSCI states, right? So in PSCI, you could the firmware might make different decisions that it could be some peripherals are left on in some low power states, some are completely cut off. All that's kind of SoC specific. So here I'm just trying to stay at a little bit higher level, but it's the same. You can imagine like the same set of states that are available to CPU idle would be available to suspend to idle, maybe with a couple exceptions or some additional ones available. But yeah, it's the same idea that it's very flexible. It's and platform specific. Am I doing okay so far, Wolf? Anything to add?
Well, just one small thing that the current support in the NPD is only for CPUs. So the domain idle state selection is only done for CPU idle states.
Oh yeah. Okay. Good point.
If that was unclear, I don't know.
Well, that gets me to the next slide because we want these. We would like these, or at least I would like these states to be to also obey per device QoS constraints, right? So there are CPUs that are in power domains with other devices that might have constraints, and I would like those constraints for devices to also affect power domains that CPUs might be in. So yeah, this is kind of where we're going. What I would like to do is extend this. So my proposal, kind of on top of the series from Ulf that just got merged, is we already have this PMQoS resume latency that can be exposed per device QoS that can be exposed to user space, and that applies to essentially runtime PM. So you can make runtime PM and PM domain governors look at these QoS constraints and make decisions based on what domain idle state to hit. And that all works today for runtime PM, but we don't do anything with these QoS constraints when we're going to do suspend to idle. So similar to looking at CPU states, I would like us to take into consideration the per device QoS states when we make a decision on suspend to idle. So what I proposed, kind of in this thread where Ulf series happened, we discussed this a little bit, but I need to update it now. But what I proposed is essentially to kind of reuse this same interface. And PMQoS also has this notion of flags that already exists in the kernel today. So my initial proposal is to just reuse this per device QoS latency and then set a flag to say that we also want this latency or this constraint to apply to suspend to idle, not just to runtime PM decisions. So that's what's on the list today. Ulf and I have been discussing that a little bit, but I'm curious if there's any more thoughts on that here. Or if nobody knows what I'm talking about, that's okay.
No, I put a question there. Is when you say, sorry, when you say this PMQoS resume latency, can there be a value in that which can be set, which can prevent S2 idle?
Yeah. So the first one is the value, and the 500,000 or whatever there. That's the value in microseconds essentially that you're saying that this device I want this resume latency for. And then the flag, the second one is basically a Boolean flag that you're saying, I want this resume latency to not just apply to runtime PM, I want it also to apply to suspend to idle.
So that will prevent S2 idle if somebody put a wrong value, right?
No, it would. So the idea is to allow the firmware to pick up a different idle state for the SoC based on those things, right? It's not like preventing suspend, but rather changing the target state of the SoC. If I understand correctly.
But the firmware can prevent it, right? Like, but the firmware can.
So we don't have this. So this problem doesn't exist on x86 hardware.
Yeah, I mean, the firmware is always going to do what the firmware is going to do, but this is a way to tell it what we hope that it hopefully influence what it would do, right?
But you would need to hook it up to the firmware somehow, right? Because nowadays,
well, at least in ARM, in the PSCI case or in the SCMI case, you can pass these types of arguments. So the PM domains can pass arguments to the firmware and say, this is the state I would like. Okay. And of course, the firmware has to support the feature, but it is available on ARM, on PSCI.
So is there the same concern as for CPU Freak that those values may be different for suspend to idle and for runtime? Like you may want to set a different constraint in this case.
There may be, but in the use cases that I'm familiar with right now, it's kind of one or the other. You may want it for runtime PM, or you may want it for suspend to idle, and so that's why I set this flag. I use this flag, but this is one thing I've been discussing. You may want completely separate values for this. Yeah,
the flag is
looks like
either or. Like
Kevin,
the flag is either or, so it is not like it. The meaning of it is if I set PMQoS latency says, it means that it only applies to suspend to idle, right?
Then what it's the way it's implemented in my RFC is that it applies to both, but we could make it apply to either or. But my initial proposal is both. Yeah. But I'm flexible on that. That's part of the RFC part.
Yeah. So because I can imagine that people may want to have different constraints for depending right on runtime or suspend to idle, but I'm not sure. It's
Okay, I'm gonna update the RFC now that OLF series is merged. I'm gonna update this RFC and post it, and we can discuss some more from there. But yeah,
I'm a bit confused with the semantic of this file, because you say it's per device, and then we apply in a per device directory a system-wide information.
Oh yeah, so that is confusing. So
I was saying that it's a bit confusing for me to having a per system-wide value inside a per device directory.
Oh, yeah, it's not a system-wide value. It's still a device value, right? Because
it's a device value, but the values get aggregated up into the PM domain level, and then the PM domain governor could then make decisions based on all the per device values that are in the domain.
But what happens overall? Okay.
So just interpretation of this one. So we have a use case where we want to put the device into a wake up state. So let's say it send a request to the remote processor somewhere. It's idle, but it's not idle. It's waiting for a response. So can the kernel driver actually program this? Do we have APIs to do that? And does it indicate that the device will be in a not a low power state?
The kernel drivers can already set these constraints. This is just about the user space interface.
Okay. So right now these APIs are already available in the kernel, and then we could.
Yeah, the PMQoS the only thing that I added here was this flag one. The existing QoS latency framework is all there. It can be done from kernel space. Yeah, on a per driver basis already. Yeah.
So,
it's the main thing that's not happening is you can set these constraints. It's just that suspend to idle doesn't look at them. Only CPU idle or runtime PM might look at them in today's kernel. So my proposal, or the dilemma here, is how to make suspend to idle kind of use the similar type of constraints that CPU idle or other idle states might look at.
Even the user is actually really good, because some applications like AI,
yeah,
we are generating lots of requests to the DSP, and it wants to keep the system awake for that response to come back.
Yeah.
And keeping it in a low power state will add more latencies to that kind of workloads.
Yeah.
But my basic problem. So my concern, maybe not the problem, is that this is all. So suspend to idle will have latency in addition to all of those values, right? Because it will suspend all of the devices, freeze user space, whatnot, right? So it will introduce latency beyond all of those constraints.
Of course, yeah.
And also they will kind of aggregate in not necessarily independently, because they may the total latency may be a sum of the, or the sum of all the latencies for all the devices. So
Yeah.
this is not straightforward, is my point.
Correct. I mean, we have that's a similar issue that exists in CPU idle today as well. It's just that in suspend idle, these numbers might be a little bit bigger and the aggregation effects might be bigger, but it's the same as CPU idle. There's a question here. Then.
Yeah. So the PMQS resume latency microsecond, you're aggregating a number of vote on that right now. We have PMQS behind, so you're taking probably the max of what is.
Yeah, or the min, yeah.
So you can have some kernel framework setting a resume latency, you take the max. And for your user space interface, it's only user space, so it's one thing. What happened? I mean, it's mean that when you set that, you assume that you will take the max value that have been set by all the system. So,
or the min, yeah.
Okay.
I mean but this stuff all exists today. Maybe we want to go towards Daniel's voting framework at some point for this type of thing to do also. But like today, the way it exists is there's one value. It can be written by kernel space. It can be written by user space if you expose it to there. Yeah.
And this one, this Echo one, it's only accessible from user space. It's only the user space that decide.
No,
the kernel
can do it as well.
Okay, and you're aggregating also. What's happened? I mean, it's the last.
It's last man wins.
Last man.
Yeah. But that's not new. Again, that's not new. That's not part of what I'm adding here.
How does the firmware decide which low power state to end based on the latency? I mean, the map between the latency and the low power states.
Yeah, so in the firmware it depends on your firmware, but like in the model here is PSCI, like OS initiated mode, where the firmware should do what the PSCI driver in the kernel is, CPU idle driver in the kernel is telling it. So in PSCI, you can pick a suspend parameter and you can pass that to PSCI. So the idea is that the kernel's gonna make some decision about what state to pick and ask PSCI to pick that particular state.
Okay, so so from a device driver point of view, if the device driver is specifying a PMQS latency of, let's say, 50 nanoseconds or milliseconds, and then if it expects the within that, if it can decide its own latency, right, and then it can also do some operations like whether to power down the controller device or to keep in low power state, and then what is the agreement between the device driver expectation and then the firmware expectation? What if the device driver keeps it in low power mode and expects the device to be up? What if the firmware decides that, okay, let's just power down or hit the low power state and power down the domain or something like that?
Yeah, I mean, that's not a new problem. That happens today in CPU idle. The drivers have to know if they're going to lose context or not, and maybe save and restore context. But what's happening here is the driver's saying what all the driver knows is that it has some sort of latency constraint. Those constraints will get collected by the PM domain in this case, and then the PM domain is going to aggregate up to the domain that actually includes the CPUs, and then the PSCI driver is going to say, okay, now I have all these constraints. I'm going to pick the minimum of the latency or whatever, and then I'm going to pick my CPU idle state based on that. And so the drivers have to be aware that they may lose context, but that's not a new thing. That's not anything new that I'm adding, but it's still there. Yeah.
Okay.
So I'd like to move on because we only have a couple more minutes and I had a couple other topics, but is there any other things on this one? So another tricky part, I got a blank slide. Oh no, there you go.
I just want to
there's
add
another
one quick question here. So
go.
I have one more use case in mind that I don't think you have described here. So there's like storage devices that's completely out of power domain hierarchies for this. So you may want to have a latency for a specific storage device when you go to system-wide suspend. You might want to have a different value when you go to runtime suspend, based on the storage device and based on the use case. So my point here is that I think we need to keep that kind of use cases in mind as well when we introduce this interface.
Okay, so that would mean just having a separate and instead of using the flag, just having a completely separate one for runtime PM and a separate one for system-wide suspend.
Well, it doesn't need to be completely separate, but I think at least runtime needs to be. I think runtime PM needs to have a separate, similar to what we did for CPUs.
Okay.
At least when I'm thinking of the storage use case.
Okay.
But yeah, we can talk more about it. Please go ahead.
So the next one is kind of describing, it's related to this because the CPUs can be in domains, which obviously affects, so if you're using suspend to idle, you care what's happening to domains that contain CPUs. So the problem here is that let's say you have a SoC that has domains like this. So the green, in my case, these green devices are, say, SCMI power domains, right? So they are in a larger domain that also includes a cluster and CPUs, right? So when you're using suspend to idle, the state of your CPUs, whether they might be turned off or not, or what low power state they're in, or what low power state this PD0 domain is in, depends not just on CPUs, but it depends on other devices that might also be in those domains that are not necessarily related to CPUs. So this is where kind of the aggregation gets involved. And I define low power states based on the combination of what happens to cluster 0, to PD0, to PD1, and to these dev domains, right? So the system-wide state is defined by the combination of all these, but then obviously because of the hierarchy, there's dependencies. The problem today is there's not a great way to describe this hierarchy for all PM domains, and particularly for PM domains that are not simple. So PM domains that actually take arguments, like in the case of SCMI. So SCMI, the way SCMI is defined right now, is completely a flat hierarchy. So it only gives you a list of flat indexes. There's no notion of hierarchy. The driver doesn't support it. And the spec doesn't support it either. So, but if I have a case like this where I have some SCMI domains that are nested in PD0 and some other SCMI domains that are in PD0, and I have some low power states that I want to control those differently, how do I describe that so that my Linux drivers can do the right thing? So I brought this up initially on the list, and Rob Herring suggested that I use this device tree notion called nexus node maps. I'm getting the red flag here, so maybe we'll have to discuss this offline. But so the idea is that DT spec defines nexus node maps, and it's kind of a generic way of mapping things between domains. So I'm kind of repurposing that to describe hierarchy where the underlying domains themselves cannot describe hierarchy. So it's kind of, I agree that it's kind of convoluted, but there's no other way that I know how to do it today. So I was looking for ideas here. So I'm out of time now, but if you have other ideas on this, or in particular, the one thing I really need help on is the way I'm implementing this right now. I don't know how many people are familiar with the code in drivers OF, but the code in drivers OF kind of breaks my brain. So I'd really like, if anybody wants to help me with the device tree parsing and the iterators and stuff that are in the OF code, I would love some help there. Because the one thing I do need to do to implement this is essentially iterate through these nexus node maps and then do power domain parent-child relationship definitions based on the iterating over each of these. So I do have there's already some RFCs on the list for this now, but I definitely could use some help on the OF side of things. I was hoping Christoph was here, but it looks like he's not. Anyway, I'm out of time. So yeah, definitely come and talk to me if you have some ideas on this kind of stuff, and if you have ideas on how else to do this. I don't know if you had any other final words, Ulf.
No, it's fine for me.
Okay.
Great talk, Kevin.
And then I had one other thing that I'm not going to get to, and I just want to say thank you to Texas Instruments, who's funding the work that I'm doing on this, the upstream power domain work on here. So thanks to TI. And then who's next? You next?
Thank you, Kevin. Thank you, Ulf. So next presentation is done by Srinivas about hibernation challenges. Your turn, Srinivas.
Yes, can you hear me? Good.
Yes.
Okay, so I have a control. Okay, good. Good evening, good morning. I'm Srinivas Pandruwada and I work for Intel. So my topic is about hibernation testing challenges and for some scope of optimization. This is topic is slightly different than the other topics discussed today. I'm discussing systems which are several CPUs or bigger systems slightly than phones or small laptops. And so typically, as you know, hibernation is not enabled out of box by distributions. And but most of the customers still insist on testing hibernation. And our internal milestones, I cannot change my slide. Sorry. Our internal milestones are even tougher. We need to run thousands of cycles on several systems, and each cycle takes several days to complete. And we always end up in challenges because there may be some issue in either kernel or driver or firmware, and the system will stop, and then again you have to repeat, again you have to wait for a long time. And a lot of times the lockups will be very random, and there will be no signature that that particular driver or a firmware or something failed. And we face a lot of issues with debugging this type of issues. So, but hibernation testing is very valuable for us because it not only finds problems in the hibernation area, but it finds problems in everywhere in the system. For example, not firmware, hardware, and like PM core, driver PM, and CPU online, offline, or boot flows. And the hibernation is really a good test to exercise everything. In addition, it can bring in all the thermal problems or whatever. So we really like hibernation testing, even if it is disabled by distros out of box. Like some of the recent failures, for example, we found like our PCI PM core. When after D3, it does not restore the bar address atomically, and it restores 32-bit at a time. And while it is doing it, keeps the memory space enable bit set. So basically, it gives the hardware. The hardware can really start decoding the addresses and start acting on them. And that's sometime if there is a clash, hardware doesn't know how to route it, it may basically generate a catastrophic error. And that's very, very difficult to find because it really took several months to find out this issue. And sometimes as simple as a print K calls inside the hibernation path causes lockups, and there were some fixes done recently in 619 because K-log workers were invoked when they are suspended and when the epic was not there, and they were getting woken up by IRQ wake. And luckily that was fixed now. But the first problem with the PCI PM is still not fixed. I don't know whether anybody here in the audience is PCI expert here, but yeah, we are internally trying to sort this out. So my objective today is somebody, any question there? Okay. So my
So the PCI issue, sorry, the PCI issue you said, was it reported to mailing list?
no, it's not reported to mailing list. No, it's still discussed internally inside Intel with all the PCI and other experts. Yeah. We currently put a workaround in firmware. Yes. Yeah. So my objective is to to reduce somehow cycle time, because as I said, each of these tests takes several days to complete. And also while doing this test, we realized that our hibernation is really not fault tolerant. Some of this fault tolerance can be built so that it doesn't lose all the values which it did. And all these features are optional. These don't need to be enabled. And it also adds more debug capabilities than what we have. We have lots of debug capabilities in our PM subsystem, but we can add more for hibernation. And I want to check what's the value of these patches upstream. And second, if there are people from distros here, I want to see how they test and what level of testing they do on hibernation, so that whether our internal expectations are really matching theirs, or wanted to find out that. So my first objective, as I said, is to reduce the cycle time. And if you look at hibernation flow, there is a suspend part of it. And in the suspend part of it, we offline CPUs, and of course, and devices are disabled and suspended. We create a hibernation snapshot image, and then we online all the CPUs again, save and compress and save the image, and again offline the CPUs. And typically, some of the systems of bringing up CPU can take between 100 to 200 milliseconds, and offline can take 70 to 100 milliseconds. So each of these states is adding lots. Each of this online and offline, which I highlighted in red, is taking a lot of time. But I realized that, like if you have like 128 core system, you just don't need only 4 cores to really do the same level of compression and saving the image. So you can literally save more than 60% of your time during suspend. So that really saves almost a minute of hibernation time so that will save, like if I run 1500 cycles, that adds a lot. Second thing which we did is, if you look at hibernation, currently what happens is when the kernel boots, the next kernel boots, it checks for whether there is a hibernation image present. If this image is present, it will immediately remove the signature. Like the way hibernation's image is identified, there is a signature in the swap space that it is hibernation, and it removes that signature. Once it removes that signature, it's basically a swap. It converts into swap space again, and it does the freeze, the process and k threads, and the load images, and again offline CPUs and device suspends, and then jump to hibernate image, which was stored before. In this, after removing the signature and jump to new hibernate image, there are lots of failure paths. And if any failure happens, it will just continue, it will ignore this, it will just ignore whatever hibernated image. So basically you lost all the goodies which you did before you hibernate, and like all the state is lost just because of maybe one device had problem, or some firmware had random reboot because of like some watchdog kick in because something is taking too long. So this change basically delays this removal of signature till to the end, after after hibernation image is it jumps to hibernation image, devices are resumed, and before the user space process are unfreezed, you just mark the signature again, remove the signature, so that any of the failure condition you still survive. So next time you can again retry the image. So this is also this, as I said, this is all optional because this is not suitable for every use case. But if suppose somebody wants to have very, it's the hibernation is that important, signature, image was some critical data there, this may be useful because that it will be add more fault tolerance in it. Next, let's set of things for debug. I allow another, like currently, if you look at hibernation is done on the swap space, as you know. We have there is an offset in the swap you specify where actually the image resides. But you can add, but I optionally allow them to add another backup offset, which is basically another swap space. And anytime the after you compress the image, that image will also be copied to the new place, new swap space, and and when it's the original one is restored, you can that image is still preserved. So for example, if suppose you have some failure condition and you want to repeat that test, you don't need to really wait for 3 days to run it. You can run the same image, swapped image saved, and continuously run, and in that way you can reproduce faster if there is something wrong in your original image, or because some for some images creates problem faster than others because of some state. So this is also optional because if it depends on whether you have another backup offset. So that concludes my slides. So if are there any questions?
So I have no questions. I just want to say that I'm already sold on the suspend optimization part. It's useful in my view if you can do it, and that's okay. I'm less sold on the other two things. So if you can ensure that reusing the image after a failure is not going to corrupt any state on persistent storage, and go for it.
It won't. Yeah, it's not going to do it because it's still keeping the it is the signal, and it is still doing
Well,
it
so it depends on when it happens, actually, because because you have to reset the signature before enabling file systems to work, basically, right? That's what needs to happen.
Swap space. File system can be enabled. Just swap spaces won't be enabled.
No, but then okay, so we need to talk about this. But anyway, so that's why I'm less sold on this. The third one is basically that debug feature to me, and I'm not sure how much use that is there for it, or there is for it in the main line. So yeah.
Any more questions? It was quick.
Okay, I think there is no question. Okay.
Thank you all.
Yes, thank you, Srinivas. So the next presentation is done by Amit for thermal binning support.
Turn that one back on.
All right. Okay, I'm hoping this one
isn't too controversial, but here's the problem statement. Basically, Qualcomm now has parts, which is basically the same SoC with slightly different thermal properties. So based on packaging technology. So you could have, so it's lit. So we could probably sell the same SoC in the IoT market and maybe an industrial market with higher temperature thresholds, critical temperature and whatnot. So maybe the one sold in the IoT market is rated for 95 degrees before it hits critical temperature thresholds, and industrial might be 115 degrees, for example. So that's effectively the problem statement. And yeah, I mean, the details of why the packaging technology, so it's the thermal conductivity is what dictates this stuff. And why do we need this? For cost reasons and whatnot, always. So we are looking for a way to not have to rewrite all of the device trees, but still be able to represent something like this. So the proposal is we have this information stored in the fuse somewhere. And what I'm proposing is introducing a new DT property as part of our the thermal bindings, which is very similar to what we already do for CPU frequencies. So we have OPP supported hardware property, for example, in device tree today, which allows you to do something similar for speed binned CPUs, which is why I chose the term thermal binned CPUs here. I'm not attached to the name. If there's better suggestions for the name of the DT property, that's fine. But effectively, so if you see that DT snippet, that's how we would read the fuse. That part I think is obvious. Currently, we just need a 2-bit field because we're hoping we never go beyond 2 bits. 4 different variants is already way too much, but that should be enough. So we will just read that. And this is one of my proposals, basically on how to fit that in there, fit that into the thermal bindings. Effectively, I mean, using the NVMem bindings, you would basically say, okay, this is where my thermal bin is. This is what variant it is. And as part of the trip description, you would just say this particular trip, so in this case, trip 0, is applicable to hex 1. So if you think of a 2-bit field, it could be hex 1, hex 2, that's 2 different variants, which would allow me to differentiate, so 95 degrees and 110 degrees, for example. Conrad, Daniel.
One thing that stands out to me immediately is that you put the NVM cells property in the top of thermal. Is it possible that we may only need this information for some of the specific thermal zones, or that it may vary more wildly? So we could have a different source of information for, say, the GPU thermal zone, and a different source of information for the CPU thermal zone. I mean, I'm not sure if there's a physical representation of this, but just as an abstract.
So as a requirement coming from the product, I've been told there won't be a variant based on different IPs getting information from different places. So it's just packaging technology has changed. It's the same SoC.
Okay, thanks.
Yeah.
So are they considered completely different SKUs? So like, if I understood correctly, you want to have one DTB for both SKUs.
Ideally, yes.
You don't want to basically treat them as 2 different SKUs with 2 different DTB, but share the same everything except the thermal.
Yes. Yes.
really save a lot?
I'm sorry?
Does this really save a lot?
Save a lot meaning?
Like, I mean, if you have two DTS files, I don't think it's too much header because you can share a lot of code the way you would share the DTS between like different things that have shared commonalities, just different definitions of them.
Well, the way
thermals just have to have two DT files at the top level, basically. Each one will include different thermal definitions, but they share everything else.
You would basically have to override the thermal node then for the different SKUs then. And this could be across a lot of SOCs. I mean, as we get more involved in the IoT space and the industrial space and whatnot.
So from a DT maintainer / reviewer perspective, overriding such a huge amount, well, very likely a huge amount of very different properties is not really maintainable. And if, for example, an OPP table differs between two related versions of an SOC, we would normally delete the whole table and write it from scratch so that it's human readable without using the preprocessor first.
Peter, back there.
So I don't know if you've seen Doug Anderson's proposal on overlays on the mailing list.
I haven't. Sorry.
It's a Pixel essentially solving this problem by using, say you've got like different cuts of the silicon and also like pre-production devices of the phones. They kind of have an incomplete device tree that then the bootloader applies overlays to on maximum frequency. Just cut of the silicon, doesn't support OPPs, things like that. So overlays get applied to produce the final DT that the kernel gets given. That could be another way that you could. He's discussing that on the device tree mailing list to, whether you can have upstream like incomplete device trees that then get completed by overlays.
Unfortunately, the reason why he's still discussing that is if we want the bootloader to make any sort of overrides, then we can never mess with the node structure again. And with NVMe cells and then OPP supported hardware, or what Amit is proposing, we have a way of just extending the existing device tree and perhaps extending the mask with new SKUs.
And in a lot of the cases, it's usually the critical trip point that changes. Everything else remains the same. So it's just one trip point, literally.
We would want to throttle as close as possible to the critical point anyway. And if there's no skin temperature sensor or similar, which is again per product and not per SOC, that's a whole other scope of problems.
Just to clarify the, so here you have trip 0 to trip 1. You said that it's only critical.
Yeah, so those are the two trip points that I care about. So for a certain SKU, which is identified by the fuse mask hex 1, I need it to be 95 degrees, and for another SKU which has a hex mask of 2, I just want it to be 110.
Okay, so yeah, because the format here it's very close to what we have with trip point definition, and
this is being added to the trip point.
It's just critical.
In this proposal.
It's just critical. There is no passive trip points.
I mean, this is the most. So it's about a. This is only about characterization of certain SOCs to be able to run up to the higher temperature. So it's not about the intermediate trip points. That's not really what we are trying to address here.
Okay. Yeah, because I'm wondering if
be trying to elaborate something generic enough to be used by other boards. And because if we want to take into account the NVMe,
What do you mean by other boards?
Or the brand?
I mean, this. I am actually proposing that this become part of the thermal trip binding.
Right. Okay. So that needs
Would be
to
generic.
be. Yes. So that's why I'm saying that. We have to collect the needs of other boards doing the same thing with their custom solution, trying to find a format, a common format for the NVMe. And what are the maps?
Sorry, what are
the maps in the?
Oh, the maps. That's where you basically tie the trip point to. So that's just to a representation. It's not. It's basically saying that with the same device tree, I would be able to. I wouldn't have to change the maps at this point because I've encoded the information about which SKU it is in the trip point itself. So I wouldn't have to change the mapping. It would just pick up the appropriate map. Depending on the SKU.
Okay.
So,
I do have a couple of other proposals. Sorry, go ahead.
In the context of the example in the slide that is currently displaying, I would prefer this to be temperature of a trip point depending on the thermal bin rather than the trip point itself as a whole depending on it, because then you get complicated with respect to thermal maps. Because then some trip points will be enabled on one configuration and some of them will be enabled on another configuration, and then you have to take that into account in the parsing code. Whereas if you make the temperature depend on the thermal bin, then you just have a different value for a different, different thermal bin.
So, Rafael, where do you suggest we do the mapping then?
So do something about like in one trip, like in trip 0, do something that will say temperature that will be the temperature for thermal bin 0 or the temperature for thermal bin 1 instead of making the trip depend on the thermal bin, right? Because you are now making the trip.
Okay, so I do have that as a third proposal. Let me, in case I fail with this one. All right. So this is that proposal, I think, that you're asking for. To the right.
Yeah, that's what I would prefer. Yes, from the parsing perspective.
Okay, but then I felt that this was a lot more intrusive for everybody else in terms of us changing the definition of what a temperature a property looks like. But if you're okay with that, I'm fine.
So I think that it would be good to possibly put the lowest common value or the lowest possible value across all the SKUs in temperature, and then maybe temperature dash the value of the fuse. So temperature dash 7, for example, equals the presumably higher one that's allowed on certain SKUs.
So you're basically asking it to become a tuple with temperature and the fuse value.
No, the fuse value would be part of the property name after a temperature dash. We haven't done anything like this because normally, for example, we have pin control -0, meaning it's the state 0 of n to choose from. But that, I think, would be the closest to what Rafael is asking you for.
Yeah,
but
that would work.
You
Yeah,
have with Rob and Krzysztof first.
Okay. Krzysztof, you just walked in. Do you have any opinions? Do you care?
Just use the same stuff which is for OPP, right? There is already option there. I mean the bin property.
I have one question.
Maybe we could perhaps, I know it sounds silly, but maybe an OPP table for the trip point.
It might be too much. I don't think we're
It
expecting
certainly
to
sounds
have.
like too much, but just throwing it out as an idea.
Okay.
Certainly prefer the thing that I suggested previously, but you know.
Yeah, I was going with the principle of the least amount of changes for the existing bindings. But so that's the first proposal is where we would basically add a property to the trip binding. And then the second one is where we basically change the temperature property for everybody. There is a third one where I basically say, does this make more sense in the map? But I don't think, I think that's the worst of the three options at this point. So that's the third option.
You also need to take into account the amount of changes to the code that would need to be made in order to parse the binding, not just to the binding itself, because that's one side of it.
Okay, so I
have a
guess I'll
question.
send out an RFP. Yes.
Do you know how this is currently handled by some other chip vendors, like mainly focus on automotive or robotics and industrial? How they distinguish this kind of configs?
Yeah, I think that's what Daniel proposed, that we should send out an RFC and find out.
Because if I recall correctly, something like NXP has different flavors from the same kind of type of SoC, but they actually have a copy of some important bits. Like in this case, they would overwrite only this section for the trips, and they would probably just fetch the data from the specific flavor of the chip. But I guess you cannot do this because you are reading this from actually running OS based on the register, right? On the fuse.
Correct. Yes.
Okay. So I would vote for the first option, to be honest. This one on the left side. Thanks.
So copying and overriding may work if you have 5 thermal sensors. If you have 60, it's less convenient.
Yes. So that was also one of our driving concerns.
Yeah, one of the suggestion, I don't know if it's doable or not, but why can't the bootloader actually do the correct? Because it knows what kind of SoC you're going to boot on, and it's in the right position to take a decision. Normally, bootloader overrides lots of device properties. So,
from where does the bootloader take the data?
It must have already data.
It's also device tree.
How do you connect the thermal zone critical trip point with this information? How do I connect that? On the thermal zone, you have the critical trip point description. Wouldn't that be part of the map? So you will. So will you add that in the parsing, separate, or do you have? Will you add, for example, the critical trip point temperature p-handle instead of a value will be a p-handle to something? Yeah, I would. I mean, I would try to do it through the p-handle. Am I understanding? No, can you say it again? I mean, I would try to use the p-handle to the critical trip point. Yeah, okay. Yeah. Okay. Any other questions? Someone there in the back.
So for another vendor's standpoint, and we don't have that particular sort of scenario, but whenever we're dealing with things from fuses, it's typically, it can be handled in overlays. Also bootloader, and the bootloader is aware of the device tree, and it may manipulate that or change it depending on what the device is. But just looking at this, I can also see that it's not just thermal, it could be other things where you're reading fuse values to change other properties. So, you know, it could be
I mean, we already do that for the operating points.
yeah.
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 I mean, so it's already, I mean, there is precedence for that in device tree. And so that's what we started with. We have 1 minute, so one last question, perhaps.
Mark, like, I mean, if there's, maybe you want to generalize this, you describe this as a different SKU. Maybe somebody can use this information useful for something outside of thermal. Like, say this is SKU fuse 0. Then instead of basically say this is thermal bin, so basically only use it at thermal, but if there is potentially other differences, it can be used in another.
Yeah, that's a fair point. Well, at that point, somebody might say, then why not the OPP table also falling into that same node? No, it's not. I mean, there are different values. So.
In the Qualcomm case, for example, the GPU is linked with a fuse value, and you can have the full matrix of from A to B GPU max frequency and different kinds of packaging. So it needs a separate source anyway, or it may need in some configurations.
Cool. I was just thinking there's a possibility for use, but I don't care.
Yeah. All right. I'll send out an RFC and see if there's any more feedback from other vendors. Thank you. How do we? Yeah, I think so. This is it. Okay. Oh, and I get to stay on. So, all right, coprocessor thermal management. So we've had a bunch of patches languishing downstream for a while on how to manage, how to get coprocessors involved in thermal mitigation effectively. So in the Qualcomm case, it is modems, NPUs, GPUs, accelerators, and so on and so forth. Several of them, maybe all of them in this case, they use some transport mechanism to talk to the application processor, but they don't run Linux. And so there's in our case, we have QMI as the high-level protocol that we use to talk to these coprocessors. I think there's RP message for some of the older stuff that I don't remember. I haven't worked on. And so the other problem is that all of these coprocessors have their own notion of performance states. So it could be, I need to drop frame rates, I need to reduce resolution. In the case of a modem, it might be a special way to negotiate with the base station to maybe not have to ping the base station so often. It could be anything. The point being that Linux doesn't know and maybe shouldn't care about how, because these are sort of islands and they manage their own state, all of these coprocessors. Previous attempts at trying to manage performance or thermal on these coprocessors have been around introducing a new cooling device effectively. So we have CPU FREC cooling, we have def FREC cooling. We call it QMI TMD. So QMI is the protocol, and TMD is a thermal mitigation device. That's what we use internally. And so QMI TMD cooling device is what we proposed. By the way, all of these coprocessors have temperature sensors. We've got lots of temperature sensors, so that's not the problem. We know exactly where the hotspots are on them. So this was posted in 23. I think there's 2 or 3 people who've tried to upstream these patches. One of the feedback that we got is that this is better modeled as part of PowerCap, DTPM, and whatnot. But I am basically asking the question, I mean, are we going to block upstreaming to try to fit this into PowerCap? Because I don't see a lot of traction in the 2 or more years upstream for these frameworks. Allowing a simple cooling device interface actually works fine. I mean, we don't really need to know, and we actually don't know. As on the application, the Linux side, we actually don't know what these coprocessors are doing as far as performance state management is concerned. All we care about is 1, 2, 3, 4, 5, and they'll just do whatever is appropriate. So I think the question I'm asking is, would it be okay to instead and make it more generic? So the previous submission was a very Qualcomm specific QMI TMD cooling device. Could we have a more generic, like a remote proc cooling register? So cooling device, which would allow other transport protocols and things to register, to do something similar. And you would basically care about a set of performance states, like 1, 2, 3, 4, 5. The remote processor would register with a device name and a function callback, which allows it to send the QMI message to the coprocessor, go to state 1, go to state 2, go to state 3. So that's hidden away in a SoC specific registration function. But basically, we just have a remote proc cooling device, which talks to the thermal framework. Could you pass the box back there?
Quick question. So, for example, we are talking about model, right? So why should the CPU care about power management of model? Because model could be driven by multiple things, not just the CPU. It could get something from it might be interacting with other processes as well at the meantime. So CPU is not the only one who will feed the data into it. So is it right to actually do that from the CPU?
But CPU is the actual entity that's controlling the thermal behavior, right? So that is
well, it knows because there's a T-Sense on there. You know that what is happening for overall system state, and some of it could be user space policy, some of it is actual information coming from T-Sense. We want to be able to take some action. What I'm asking, what I'm raising here is, do we really need to know all the details, or should we just provide an interface to say, GPU go to that state? Oh, well, GPU already has that with DefReq, but modem go to that state, NPU go to that state.
What does that actually imply? Does it imply that people who control the traffic to the modem? In this example, let's say we have a phone call going on right now on the modem RS from Wi-Fi. So your CPU gets a temperature hit, and then what are we going to do? We're going to say to the modem,
That is part of the user space policy. So the user space policy is what decides what is the critical use case that needs to protect, and everything else is.
That's irrelevant. It's irrelevant to the CPU. So the CPU doesn't know what the modem or the process is going to do. What it knows is that it generates sort of heat, and that is going to cause some issues. So it says that, okay, lower your bandwidth or do whatever, just make the heat go down. So that's what the CPU has.
So the problem is that, so especially the TMD devices now, they can actually cool and also they can warm the.
Yes.
So if you use the performance statements, how can we differentiate between these two? Warming and cooling effects.
That's a good question.
I don't know the answer of it, but I would like to have some generic interface for communicating with the work product.
Well, I think that's something that is lacking in the semantics of the whole cooling device. I mean, we have it in the name itself. We call it cooling devices as part of thermal framework. But I think we've been talking for many years now about the concept of.
You want to connect. You want to connect this cooling device to the thermal zone? Or do you want to have this cooling device only managed by the user space?
Like I said, I already have T-Sense on all of these coprocessors, so they are connected to the thermal zone. There are already thermal zones for them.
There are, I mean, but you connect that as a cooling device of the thermal zone, or they will be just registered as cooling devices appearing in the CIS class?
What I would like to be able to do is actually take actions on them. So the cooling device, I would like to be able to say, provide the P handle and say this is the state that, I mean, they need to throttle to a certain state from the device tree, from the. I don't have a DT slide for this one, sorry.
Actually, my question was, do you want to control these cooling devices from the user space or from the thermal space?
So why does it matter actually? So I mean, I can hook this cooling device with something like thermal input or some sort of user space tooling, and user space control it. So why are you looking for differentiation between?
Because we had already this discussion that the cooling devices should be a device controlled by the cloud. And sometimes what we see that these cooling devices, the user space is acting on the cooling device. There is no aggregation with the thermal zones and the governance with this cooling device. So I'm not really in favor of having controlling the cooling device directly from user space in this namespace of the thermal framework. But I think we need something to be, so you say, for example, you have a performance index, that was part of the voting mechanism. So giving a user space interface. So when the user space is going away, like the process is dying or just forget to change the state, automatically remove the performance state input from the display. So it says it's they always win.
So don't any of the other vendors have any of this at this point?
We have some sort of thing called PCI. So we have the PCI and the cooling devices, and that's primarily introduced for x86. And I don't think kernel is handling those cooling devices. It's exported to user space. I think thermal
So it bypasses thermal framework completely.
Yeah, I mean, it is exposed as cooling device. So in CIS class.
Okay.
The user space can actually activate, right? So.
But then why is this different then in that sense?
It's for me it's an abuse of, as it's just to say. So we are not really using that as cooling devices and part of the thermal framework. We are using that as a way to export an API to the user space. So the user space can act on it, but it's not really a clean interface. A clean interface, you should have the user space is changing the performance state, and say the user space is going away. You have a way to have this constraint to be removed from the performance state, or try to something else.
So basically, Daniel, your point is that a cooling device should be associated somehow with a temperature sensor, I suppose, right?
But it is in
So
this case.
with what temperature sensor?
Well, we have temperature sensors for each of these SOCs. I mean, so the T-Sense for
Okay, but they are. Do you register thermal zones for them? In the
Yes.
kernel, yes. And then you
Yes.
need trip points in there that will be, but the cooling devices should be bound to trip points in those thermal zones, and then that will be managed by a thermal governor in the kernel, right?
It can't be managed by the thermal governor because managing all these coprocessors means just sending them some message over SOC or a vendor-specific transport layer.
That's part of the cooling device interface, right? The thermal governor simply sets the state of the cooling device, and then the driver of the cooling device needs to take care of what passing it to the hardware actually. So the
Yes.
question is how you want this to be managed. Do you want the kernel to manage it through thermal governors and thermal zones, or do you want to manage it somehow differently? I don't know, from a user space daemon or whatnot.
I think we're fine with the kernel managing it.
Okay. Then I don't see a problem with this.
So, for example, the GPUs get involved, and it's because of probably a video decoder is running on a dedicated processor, and it's streaming to the GPU. The end result of the GPU is get involved, and the event what kernel receives is GPU, but actual source is something different. So you're going to try to control GPU, but that's not what the source is. The source is that video decoding happened from somewhere else. So you might, I don't know, the kernel governor to actually work, and it should be very much user space driven and use case specific, I think.
So this concerns specifically remote processors where we do not control the frequency or do not schedule work from the kernel really. So
Yes.
the GPU, we already just use OPP to reduce or, well, set the frequency, and it is registered as a cooling device, and it has mitigations. But for remote processors, such as the NPU, the kernel has no clue what frequency it's operating at.
Yeah.
So,
and there's also inter-DSP communications happening. So which
yeah, one of them is going to heat up, and we don't.
But I think what we're trying to find is a perfect solution. I don't know if there is a. Yeah.
If it's hot, you should probably know it.
Yeah, I mean, we're talking about die about this size with 40 temperature sensors.
We don't know the source actually.
Is there any order? Excuse me, because you are talking and I'm waiting. Just guys, is any fair queue or something? Yeah, I was going to say that I share the same opinion as Rafael. I think there is no blocker in terms of concept. I think the list of states, if we agree that the list of states has the order and the governors which will bail out to not control this device. For instance, IPA, which has the energy model requirement, it will just bail out. In any other governor in the kernel, if it can bail out from this kind of device, then it's fine. The controversial bit was that Daniel has raised. If we are not part of any thermal zone, but the cooling device is there, managing from the user space explicitly through the sysfs of the cooling device, that might be kind of in my opinion. But if that lives inside the thermal zone, as Rafael made this clear, then why shouldn't we just agree on this let's say, a generic state cooling device. Then it's a kind of state only, which has the meaning of this list of states, let's say 10, and the order determines we are throttling or not, going through the list. Why that cannot fly?
If the display device is connected with the control,
Daniel, I barely hear you. There's something with mic.
Can you hear me?
Yes.
Oh
Yeah.
yes, way better.
Yeah. So what I was saying is, if the this cooling device is connected with the thermal zone and trip points, I don't see a problem. But if the goal is to manage them from user space, then I don't think it's the right. I don't think it's the right place. And from a bigger perspective, well, I think it's today we should prevent from the thermal framework to let the user space play with the cooling devices. We should maybe export that, show that, but at least we should prevent the user space to deal with them, because there is no protection against these changes. So, for example, we have here one you say that there is one cooling device changing the resolution, and if I remember correctly,
What I'm saying is I don't know.
Yes,
Each of these.
Okay, but one is reducing resolution. So I think if I remember correctly, it's done from user space. It's the library changing the resolution. So that means, let's imagine the user space is changing the resolution and then it dies and the resolution stays in this state all the time. And we need something.
No. This is in this case, it could be a video accelerator, and that's the coprocessor. It's not user space.
No, but when you say you change the
again, what I'm trying to say is that we are trying to get into the details of each of the use cases of a coprocessor that Linux doesn't control. We don't know how those states are managed in those coprocessors.
Right, but it's just. But it's just giving the state, right? So go ahead, Rafael.
So if the purpose of this is to register this cooling device and bind it to a trip in a thermal zone, then this is all fine. If the purpose is to have controls in SysFS for this, so user space can play with it, it is not fine. Okay, so the purpose of registering a cooling device interface should be to bind it to trips in a thermal zone. But I think that we cannot retroactively prevent user space from using those interfaces, because that's happening already. But I wouldn't like to. So okay, so let's just say the condition for me to move forward to it is that the cooling device definition should go along with a thermal zone definition that will involve trip points using this cooling device. Or yeah, that will be that's what I want to be there.
I have a follow-up question, Rafael. So if we agree also, so this list of states, it doesn't have to have linear relationship.
Obviously not.
Throttling. Okay, of course. Then
yeah, because we don't know. I mean, and every coprocessor is different.
They are just, you need to know which thermal state to use in which trip point, right? So if you cross, say, trip number, I don't know, 2, you will use the thermal state number 4 of this device. right? That's the relationship essentially. So this is why they are bound to trips, basically.
Okay. Yeah, fair enough.
Conrad.
You said that you're okay with this.
I think it's off.
Yeah. So as long as it goes again, as long as it goes along with the thermal zone that will use those those cooling devices, then it's all fine, because it's a cooling device. It's like a fan in this case, right? You have a thermal sensor, and you have something that reduces the temperature somehow, and if you cross a given trip, you trigger this cooling, and that's fine.
And wouldn't you mind having a potentially a hybrid solution where the kernel would encode the general temperature trip points, but the user space having potentially more information could be a little more conservative? Like,
Yeah, I
it
know
would
that
still
this is already
be
happening, and and we cannot prevent it from happening. But so my threshold for getting that into a kernel is the existence of a thermal zone in which this will be used. I cannot force user space, or prevent really user space from like trying to manipulate those cooling devices by itself. But my condition is that there needs to be a thermal zone in the kernel with a thermal sensor hooked up to those cooling devices. Okay, so
right, we can probably do that.
Yes. I think that part is. And would you be okay with a QMI cooling device, which is Qualcomm specific, or would you rather have two levels of abstraction? So have a remote cooling device, which is
well,
then used by other
it's
users.
fine. So we have a cooling device for Intel Wi-Fi right now. So I don't know how that's different from it.
Okay, so PCIe has one as well. So I guess it's okay to. All right.
Maybe we'll skip the warming part and then just.
Yeah, I think we need to come back to that anyways, and we have yeah. All right, I think that's it. We will send this out again in a few weeks. Thank you.
Thank you, Amit.
Thanks.
So that was the last presentation. Thanks to our sponsor again for supporting this event. I think that was we had good discussion. There were some still some point to clarify for some topics, and yeah. Thank you very much for attending.
Thank you, guys. See you.
You are currently the only person in this conference.